help make that productivity as a .NET developer better. So I'm going to pass the mic to y'all.
Great. Thank you, Leslie. Thanks for the introduction. Like you said, PMs on Visual Studio. So happy to be here. This is my first time speaking at .NET Conf. Really excited to join you all today. And even if we have to be remote, I'm really looking forward to showing you all the wonderful things that we have to share today.
Yeah, well said. Absolutely. I'm especially excited to share some of the things that you can be using to get up and running in CodeSpace today.
Yeah, I am very excited for that. Let's talk a little bit about what we're going to talk about, actually. So we have, just like what Andy said, what are code spaces? What are GitHub code spaces? How do they work? So I'll be talking a little bit about that and kind of diving into some more details, which we haven't shared in this way before. So I'm really excited to kind of like unveil that and let you all into what's going on behind the curtain with code spaces. Then we're going to have a demo. I'm going to show you all code spaces, some cool new things coming out in Visual Studio, and as well as the way that it connects back into GitHub with Visual Studio, code spaces, and GitHub tooling. And then lastly, we have Andy, who's going to talk through our customizations, which is really cool. And I'm really looking forward to learning, even just like getting a preview of what Andy is sharing around customizations in code spaces and with Visual Studio all up. I think with that, Andy, did you have anything else to add to the agenda?
No, it sounds very exciting, and it's exciting to be here. So I should just get in. I want to see these demos.
Okay, great. Cool. Well, we can just go ahead and hop in then. Thanks, Brian. That's me. Very excited to be here. Okay, what are code spaces? When we talk about code spaces, we think about the way that GitHub Code Spaces provides value in a few different areas. From an all-up perspective, we think of GitHub Code Spaces as this fully managed, on-demand development environment where you can develop from anywhere and be able to have the power of the cloud in an environment that you know well and love, whether that be Visual Studio, VS Code, or also in our browser experience. The things that come out when you're experiencing code spaces is that what we've heard from customers in our customer research is that it feels like their local environment. We're going to talk more about that. But that we have this power and this compute in the cloud, so it really opens up the options here for us and what we can do and what our limitations, our previous limitations on what we develop based off of maybe your machine specs are now elevated, and you have access to more essentially. So let's just talk a little bit about what that actually means, because that's pretty high level. When we talk about GitHub code spaces, there are two aspects that come to mind. And one of the things that we hear from customers in our customer research and our onboarding studies and in all the hours that we spend listening and getting feedback from you all is that there are some times where customers are wanting to know what the difference is between what is in a local scenario and what is in a code space. So if you look at this diagram, you think you have this whole section that's cloud hosted where you have your code spaces. You have essentially the entire VM, whether that be a Windows or Linux-based VM, and it has your compute, your storage, everything that you need as far as the power and this kind of backend behind the code space experiences. And then you have this other side, which is the editors. Sometimes we also call these the clients. These are these lightweight UI and this kind of like front end to present the tooling that you know and love through VS Code, the browser, or Visual Studio. So today, what we're going to talk about is we're going to focus in on that last one. We're going to focus in on experiences for Visual Studio, for .NET, for in this context that I'm sure many of you have known for even many years. Great, okay. So just to kind of recap a little bit, We have the code space. It's this backend half of the GitHub Codespaces service all up. Gets you everything that you need to get started completing a task, reviewing PRs, using Git tooling, debugging, editor, everything that you are used to in this type of context, right? So let's see how this actually works. So I am going to switch my sharing screen here, and we're going to hop into a demo, which is very exciting. Okay, here we go. Great, everything looks good. Okay, cool. So here we are in Visual Studio. I'm in Visual Studio Preview, Visual Studio 2019. And one thing that I wanted to just point out right off the bat, right? So when we open up our start window, we see this new option here, connect to a code space. So that looks very intriguing. You know, I definitely want to click on that in just a second. But I also wanted to draw your attention to, in our most recently used list, we have this option here to connect back to a code space as well, or pin it to come back to it later, or keep it at the top of our stack here. So when we're thinking about code spaces, we're really thinking about how do we make it easy to get back into a code space? How do we make it easy to initiate a code space in all of these different contexts, right? So here we're going to go ahead and click on connect to a code space. And as we're doing this, you know, you'll see a slightly different experience than the first time. With your first time connecting to a code space, you can request access to the beta. And then once you have access, you just sign into your GitHub account. So I can just point it out right here, my VixMix GitHub account. And then once I'm signed into my GitHub account, then I get this option here to create a brand new code space, which is very cool. One of the things that I do at this point too is I can just go and grab my repository URL from GitHub. I'm going to go to my repositories here, grab this eShop on Web one, drop that down, drop that in, and here I can just quickly clone from my GitHub repository. I can select what type of power I want in my instance type, and this is in this Windows VM. I can select what time it'll suspend. One of the things to also just point out here is that it doesn't go away when it suspends. You know, it just idles for a little bit, and then I can jump back into my context. So I could take a lunch break and come back, and my code space would still be up and running. So here we go. Let's go ahead and connect to code space. So during this creation process, we see a lot of questions come up around where things are between the kind of boundary lines between Visual Studio and its experience in code spaces. So some of the things that we're going to point out here too is just how easy it is to initiate the type of tasks that you have in your regular day-to-day, but inside the context of a code space. Now, you may have seen when I pulled up my browser here, on the previous screen, I had this tab open for code spaces. And you can see here that yesterday I created a new code space for my sample app, eShop on Web. You can see that one. And then I can also create one here, which was just created 21 seconds ago, about 47 seconds ago. So here I could also manage this or open in the web. Now, just something to notice here when you are editing here in the browser is that that's using VS Code to have that editing experience in the browser, right? So just think about it as a way to do maybe like lightweight edits and small changes, but maybe not the full development experience that you would have with Visual Studio, right? Because it's in that VS Code environment, but in the browser. So just something to keep in mind. It looks like we have our code spaces all ready to go, which is great. I even have another one open, so just pointing out that we could have multi-sessions available here. And now that I'm actually in my code space, you know, the first thing I'm going to do is here I have my eShop on Web solution open. I'm just going to build and see how this goes, just straight off the bat here. Great. So as this is building, just a little bit about this app that we're running. It's just a .NET kind of like shopping cart system, a little website, and it looks like it's built successfully, which is great. I'm going to trust and trust, and here we go. Great. So now it's already up and building. So the it's pretty cool actually. So all I did was clone my repository in a code space. Here I have my app running in a code space, building, and I can already start interacting with it. And that was within minutes, a minute, I don't know, very quick, which is awesome. One of the things that I was given a tip from Andy to go and check out was that there's this little bug happening where when we added something to our cart, it looks like the image is broken. So I'm just going to investigate that and take a look at it in my code space. I'm going to go ahead and stop debugging. And I noticed that when Andy pointed it out, he was talking about something about the basket remodeled service. So I'm going to just pull that up and here in my control Q, and there we go. Go ahead and pull up that file. I really like using control Q for a lot of different things. Anytime that I feel a little bit lost or like I'm not sure how to find a particular piece of code in my in my solution, I use control Q. If I'm looking for a new type of feature and wanting to point that out, then I also use control Q. So I'd recommend giving it a go. And as you could see, as we were typing in, we could also do code search here, which is really cool. So here I am in Basket View Model Service. I'm going to scroll down, and it looks like I got this little tip about the get basket items function. So here I can just go ahead and set a breakpoint and go through just a basic debugging experience and start checking these things out. Just keeping an eye on the time to not get too deep into it. I actually know where, I'm pretty confident I know where this issue is. So I am going to look down here where we have the picture URL. And it looks like we have a name here, which is not that helpful. So I'm going to instead, change it to picture URI. All right, sweet, looks good. Save. And now I want to point out something else that's really cool about some new changes in Visual Studio. There's this new tab here that's called Get Changes. And I have been really enjoying this new Git tooling a lot, actually, because I just find that like when I have to go into terminal to make my Git changes, sometimes like I just feel a little bit lost or excuse me, just finding kind of like my footing each time, when I'm getting in there can sometimes be a little bit confusing. And especially when I'm switching back from a UI based navigation, like with Solution Explorer, and then back into terminal and back and forth. So the Git changes tooling has been really, really helpful in this. So here you can see I already have my changes. I'm just going to go ahead and commit this because I'm pretty confident I know what's going on. We have like an inside scoop here. So here we can see the commit here, and I can also go up into the top here, navigation where we see Git, and I can open up my manage branches and see what's going on here too. And I can easily push. So here I get this cool visualization. I get to know what everybody's been doing. I get to see my activities, which is, again, really good for myself as a visual thinker. So this has been really nice and made it a lot easier for me to make changes that I need. So then I can just create a pull request easily and make this change, which looks good. I'm actually going to save that for later so that I know we get to everything that I want to show. So here, another thing that I wanted to point out was that we have some really cool new tooling around the way that GitHub interacts with with Visual Studio inside the context of Codespace as well and outside of it. One of the things that has been really interesting to try out is this right-click publish. And the option here, we have this new option to publish directly with GitHub Actions, which has been very interesting and cool. You can see that I've already made one, so I'm just going to create a new one to show you what it looks like. So here I can just select Azure, yeah, Windows, looks good. I could create a new resource group if I want to. Let's go ahead and do that. Okay, great. Looking good, looking easy. So when in the kind of like the next option here, we're going to be able to see the kind of like last bit where we have this option to publish through GitHub Actions. And I want to show you as well where that shows inside of the context of my repository. So here I'm in my Bixmix, a fork of the eShop demo app. And you can see here in my workflows under actions that I actually already have one, spoiler alert, but here I could go ahead. And so the CI/CD, this availability to extend my workflow past just my inner loop activities through GitHub and GitHub Actions has been really, really cool to play with and figure out. Here, let's go ahead and hit next. So here is where you can go ahead and publish automatically using GitHub Actions. So just wanted to throw that in there. I would recommend if you all wanted to try it out, let us know how it goes. We are very much looking forward to hearing all of the feedback from code spaces, from the context of our new Git tooling with GitHub Actions, and trying to really develop this cohesive relationship between all of these different aspects of our great, powerful tooling. So with that, just keeping an eye on the time, making sure that we are going. I think that is what I wanted to show as far as in the code space context. One last thing that I'll point out is that you do have access to your same kind of collaboration tooling as far as live share and what you might need as far as collaborating with teammates too. So I could quickly grab this link from in my environment, share it with Andy. He could jump into it. He could start exploring it. He could do his own publish, all with that same type of collaboration tooling, which we know has been, and what we've heard from customers has been really helpful inside of the context of this kind of this quick transition to a remote first environment that's brought its own challenges along the way. One of the things that has been really interesting as far as like the way that we as a team with Visual Studio and GitHub and Codespaces have been thinking about how we make that, how we meet you all where you need support or help or tooling around those different aspects of collaboration. So I'm really excited to get into Andy's portion as well, because we're going to be talking about the way that teams are able to use different types of customizations to set up their environments so that it's just quick and easy to run through in the way that it was for me, but also even in more depth of customizations as well. So let's go ahead and pull this back up and do a little recap. What did we talk about? We talked about creating a code space. We talked about Git changes. We did some code navigation. We debugged within a code space, collaboration tooling, and GitHub Actions. All of this has been a really cool learning experience from having conversations with everyone as far as what the development looks like around how do we make sure that this tooling is providing a solution, a possible solution to a need that we're hearing from everyone and our customers. So why use GitHub code spaces? You can quickly create them. You can delete them if you don't want them. You can have this managed environment that's just easy to spin up, get going, burn down if you don't want it anymore. This predictable pricing structure you pay for what you use, and you save these compute resources. So the way, when I first started working remotely in this, like I was on my like little laptop that I used for like jumping from meetings or traveling to conferences or that type of thing. And it was getting pretty hard to work on larger repositories in Visual Studio. So using code spaces has made that a lot easier because, like we talked about in the way that code spaces works, it removes that aspect for us of having to have all of that processing power and that compute on your machine. In fact, it just removes it and just creates you to this experience where you're able to just use the UI that you are familiar with. So even as I was pulling it up, you could see my dark screen. You could see the way that I like to have my development environment set up. So all of that felt nice and familiar, and that's what we've been hearing from customers as well. So without further ado, let's go ahead, and I'd like to pass off to Andy as far as what does customizing a code space mean? How do we do that? What are the details? Andy, take it away.
Yeah, thank you. And thank you for some great demos to help highlight the value of code spaces and how you can use them. So as Vix mentioned, I'm going to be talking about how you can customize a code space. And firstly, you're probably thinking, what on earth does that mean? Well, customizing a code space is all about getting you up and productive in an environment as soon as possible. Like Vix mentioned, one of the really nice value props of code spaces is to be able to write code, build code, run code, debug code as soon as possible. I'm sure many of you have had an experience in the past where you start a new project, start on a new team, and you get clone the repository down, and you try pressing F5 and it doesn't work. You have to get some other stuff. Maybe the repository was super nice and it had a nice markdown file that defined exactly what you needed to do. Or maybe, just maybe, there wasn't such a file and it was all in Bob's head. And half the challenge was just going to find Bob and extracting how on earth to set up this project such that you could run and build it. And so really we want to tackle that problem. We want to make it so it's easy for you as a developer to create a development environment in a code space so you can be productive. So the next person that comes along can have that experience where they just hit F5, boom, kind of like magic, it works. So how are we going to do that? Well, firstly, it isn't actually magic. There isn't such a thing as far as I'm aware. So what we really need is your help in defining these development environments. Like one of the challenges with a code space is because they're automatically created or programmatically created, I should say, in the cloud in Azure, they can't rely on a person going to a wiki page, copying a link to an MSI or Googling for how to install Python to install it. It has to be defined. If you can imagine this compute environment starts off as a blank canvas, we need your help as a developer to fill that in, to paint that picture, to tell us what your application needs. And so this is the tough part. For the first person, the first time, someone has to go through and kind of define what on earth that this repository needs to be able to successfully build, run, and of course debug and things like that. And once that's done, everyone else benefits. Obviously yourself, if in the future you decide to create a new code space or a new virtual machine, but anyone else joining your team and working on your project gets to benefit from that work of defining this development environment. And that's really the key trick here, is how to the key trick is really around defining that development environment. And what we want to do with CodeSpace is to give you some new tools to make that easier, both in the case of CodeSpaces, but also in the future locally with regular Visual Studio. So before we get too deep into how to define these environments, it's really worth hammering home something that Vic's already talked to, which is a code space is kind of a story of two halves. There's your local experience, and for this talk, I'm really just focused on Visual Studio. There's the Visual Studio client, the EXE you run locally, and that connects up to that resource in Azure. And the resource, the compute resource up in Azure is where all the magic, or I should say magic, all the hard work is done. Like that's where your repository is, that's where the files are, that's where it's going to build, that's where it's going to run. And that's also where lots of services from Visual Studio are. So some of the computationally expensive stuff from VS, like language services, debugging service, and all those sort of things run up in the Azure compute, and your client is connecting to them to utilize them. That sounds great. And like you said, like Vic's mentioned, it's a great way to get scalability because it means your client has to do a lot less. But one interesting challenge this presents immediately as a developer who's probably used to Visual Studio and Windows for some time is that you don't have some of the familiar tools. Like you can't use File Explorer, for example, Windows Explorer, just to navigate to files and stuff like that. And you can't do what you might do locally to install stuff. You can't just browse the internet, download an MSI and run it and click, yes, I agree, a couple of hundred times after reading the very long EULA. That's not possible in this option. In this world, you have to use Visual Studio as your window into the computer in the cloud. So all the features and capabilities of Visual Studio will be there. They're not all there right now. But certainly some of the big ones, such as the terminal. So if you've used Visual Studio for some time, you might know we have an integrated terminal using PowerShell or Console, which is a great tool locally. But in the case of a codespace, it's really important because that tool is how you execute and interact directly with the compute environment. The other thing to keep in mind is that, if you are using like a terminal, it's a bit cumbersome to use that every time. So one thing you want to think about is that ultimately, we want to get everything that defines your development environment into your Git repository. Your Git repository is the artifact of everything about your project. It should be the one source of truth for your project, and that includes what is needed to set it up. So if you depended on someone installing something like Python 2.7 for some reason, then that should be captured somewhere in that repo so that someone else, and in this case, the code space, can know about it. And so what we're going to talk about next is how you can customize these code spaces for Windows and Visual Studio. So when I say customization, it's probably not a term everybody uses. So what we really mean here is doing anything with the compute environment such that it's specific to your repository. So that can be installing software, like a completely new software, such as like SQL Server or Redis or RabbitMQ or anything like that. It could be something, a Windows capability, enabling IIS, for example. Anything to change that in compute environment to be more specific to your particular repository and your application. So if you think about how the customizations are structured inside a code space, it's like a layer cake. At the bottom, what you have is the base image. This is the very base thing that is shared amongst everybody. So it has nothing to do with your repository. Every single customer of a Visual Studio code space will get this. And that base image is built on Windows 10, Windows 10 client, and it has Visual Studio 2019 installed on top of it. So that gives you a ton of capabilities off the bat. Obviously with Windows, your application may be using any number of APIs, and Visual Studio delivers a bunch of dependencies such as, SQL Express, local DB, as well as languages and tools and SDKs and runtimes. And one thing to keep in mind, as I mentioned that, is that ultimately you do want to make sure that you don't rely on what's in this base image. Like this base image today has a set of capabilities, but tomorrow it might have a different set of capabilities. For example, Windows could update and add or remove or change a feature or version it so that the version you're depending upon is no longer programmatically API compatible. And the same could happen with the dependencies Visual Studio is bringing along. And so if there's one thing to take away from this entire little section, it's that the most valuable thing for you to as a developer is to define your development environment such that someone else can reproduce it without having to install the same version of Windows 10 as you, or Visual Studio with the same workloads, etc. So with that being said, the next two pieces of customization come from your repository. Like I mentioned, the Git repository that you have is your real only pipeline into the system. And so everything has to really come through that. As Vic showed in the Visual Studio UI, there wasn't a place to enter any random stuff. There was just repository, idle time, and the type of SKU, and off you go. So the two things that you can put in your repository. The first is a .devcontainer.json. So you may have heard of this file. You may even already have one in your repository for use in Visual Studio Code. So VS Code has a remote container development story and has done for some time. It's fantastic. We are starting to reuse some of that. This might change its name. As the warning says at the top of the slide, this stuff is still in beta and preview, so some stuff is subject to change. And this naming is a bit confusing because we're not running in a container. So all the Docker and container related properties that you might be used to if you're using a devcontainer.json from VS Code are not applicable in a Visual Studio and Windows code space. The most important thing that is the post create command. And this is probably the major thing to put in this file. And all that does is it's a property in the JSON file called post create command. You'll see a demo of it later. That will execute a series, an array of commands you provide as strings in the default shell, which in Windows, of course, is the console command as admin. So that's the first way you can customize, really, is you can execute a script after the repository has been cloned. And so if you already have the script that does that locally, then you just plumb that in there and you're good to go. Job's done. But if you don't have that script that deploys your environment and creates all the stuff necessary for developers to be productive, that's where we're introducing a new tool, a tool called devinit. And devinit is a tool to help you define and create development environments on Windows. It's something it's just in preview. It's for Codespaces right now, and we're looking at how moving it to Visual Studio for local experiences in the future. But right now, it's part of Codespaces. And what is it? Well, it's a command line tool. Devinit is starting off as a command line tool. It's on path in a code space. And really what it is a tool that drives other tools. So apologies if there's too many layers of tooling there. I just couldn't think of better words. It's a meta tool, maybe that's a word to use, that drives these other little tools to actually do work to install. You can almost think of it like as a recipe or as a checklist of stuff your application needs. So in this tool, devinit can be used to install software. And the principal way it works is you as a developer define a JSON file. So up here on the right, you can see they've got this JSON file, and that's that little recipe that you're going to define that says my application needs these things. And then with devinit, you can just run it from the command line and execute a command called init. And what that will do is take these specific tools and then execute them and do whatever action of each of those tools. And that's what we're going to look at a bit more today in a demo, is how to use these tools and which tools to use. But with that, with this JSON file and with this devinit init, you can install software, configure things that will be the foundation of your development environment, such your application can build and run. And that's the most critical thing, is that you can define what your dependencies are. And it's simple to use JSON file that in the future will hopefully provide better tooling for integration into Visual Studio, etc. And so that's a bit of one of the reasons we went for JSON, and it could have been YAML, it could have been it could have been XML if this was the 90s. But the reason is that it allows us to have some tooling on top of it. You know, if you write a script and you already have a script, then you should just use that. But scripts are very difficult for other tools to interact with because it's basically a black box. It executes some stuff and it can literally do anything. It's very hard to know what the underlying things your tool was trying to achieve or the state it was trying to achieve if it's just a script. So that's why we got this JSON file. You can check it into a repository and it can flow along with the rest of your code. And so, like I mentioned, this devinit tool itself is really just driving these other smaller tools to do actual work. So let's talk about what they look like. So yeah, each of the tools is just a wrapper. So in devinit, we just have a bunch of wrappers that call into another tool, because one of the beautiful things about the Windows ecosystem is there's at least 20 ways of doing everything, especially when it comes to installing software. There's many ways that Windows has been configured over time. I'm sure many of you might already have things like a packages config file for Chocolatey, or you might already have an MSI, or you might already be using foo technology. There's lots of great ways to install stuff on on Windows. And what devinit is trying to do is to use those things. So for example, today, if you were locally to use an MSI to install, so you download MSI, you run it, we have a tool that will take the URI for that MSI and execute it. So you just pass in like a URI to the MSI tool, and then it calls into MSI exec or some other tool that actually does the heavy lifting. Devinit is not actually, it doesn't actually do the installation itself. It relies on something else. And we'll look at that a little bit more. But the key thing is it's just really a shim to something else. We want you as a developer to bring the technologies you already have and plug them into this world. We don't really want to build a whole new package distribution system. This is not a Winget or apt-get or Chocolatey or anything like that. It's not about, devinit is not a package distribution system. It's just a thing that really can be used to poke those things so that we know that they're there. So if you're using one of those package managers and stuff like that, you can just write this in a JSON file so that the Codespaces knows where to go to get that stuff and execute it. Like if you, for example, in your application, you probably use like npm and NuGet as a package manager, and those are brilliant things, obviously, and absolutely great. And devinit is not addressing those problems. What it's trying to solve is, well, who told me to get npm? Like, obviously, you have to install Node for that to happen. So we're just trying to, I guess at the meta level, the inception, trying to solve the challenge of how do you get the first layer of tools if you start from a blank canvas? and how do you paint that so that the rest of the ecosystem, like NuGet and stuff, can all just work. So yeah, how do you use it? Well, we talked about this a bit. So the first step, and we'll do a quick demo of this, is you need to add a dev init JSON file that defines what your application needs to run, debug, and build. This is the 99% of the work. This is basically all of the work, is figuring out what your application needs, which may sound trivial, like, like, oh, I know my application, I know everything it needs. But there's a few gotchas, specifically around things that, ultimately you want to make sure that the definition you create, works on basis that there's a blank canvas to some degree. Like for example, if your application depends on something that Visual Studio is bringing, like if Visual Studio is bringing a specific version of the .NET Core SDK, and you rely and depend on that because you've pinned using global JSON or something like that, then what happens when Visual Studio no longer brings that? Like, for example, you could get into a situation where your application is specifically for reasons that, your application is taking its dependency on using an old version of like the SDK framework, sorry, the .NET Core SDK, but Visual Studio's moved on beyond it. Like, future versions of Visual Studio won't ship with like the 2.0 SDK and stuff like that. And if you've pinned to that, how do you get that back? So that's a big thing to keep in mind, is that in some cases, Visual Studio may already be bringing a lot of your dependencies with you, especially, if you're coming from a C++ world where there's C++ tool sets. Obviously Visual Studio is probably what you use to install those today. And you might have had an experience in the past where you've updated your version of Visual Studio and maybe it deployed the latest, like the 142 tool set, and then poof, your app didn't build anymore. So the thing there is to think about not just the obvious stuff the app depends on, like, oh, hey, it's got SQL Server because, you install SQL Server, or it's got IIS because you have a script that deploys and installs IIS. But think about other things that your application might need, like even simple stuff. Like you probably assume you have something like Node installed locally because you can't live without Node to do front-end development these days. But Node might not always be available in the servers. And even worse, if you depend on a specific version of it, and this is probably more true for Python and other languages, then that version may not be there by default. So again, this is the hard task, is figuring out what your application needs, defining that in a JSON file, and then you just hook it up to the dev container JSON. So let's look at this in Visual Studio. So I was working on the same eShop app as Vix was showing earlier. And so this time around, though, I'm going to show you the customization story. So the couple things to note is that in the Solution Explorer here, we have a .devcontainer.json in the root, and a .devinit.json, and we're going to work on this JSON file first. So just mentally going through my head, I know my application requires the .NET Core SDK, but how do I get that? Like, how do I tell Devinit that that's the specific version I need? Or how do I even use, know about this tool and stuff? Well, the truth of the matter is we're going to have to use the internet, and we're going to have to search. And the best way to do this is just to search for, like, if you just search for Devinit and docs, you should be taken to our documentation. And this is going to sound a bit cheese-tastic, but using the documentation and the samples is probably the best way to get started. Obviously, we have some documentation that talks about everything and things like that. But the hard problem you have to go through is to map a dependency, a concrete dependency your app needs, like the .NET Core SDK, back to a tool in Devinit that actually installs that thing. So, like, how do you install SQL? How do you install Python, or whatever other dependencies you need? And so the first place to start is probably this tool list page, where this lists out all the tools we currently have in Devinit for doing things like, installing VC packages and enabling Windows features, etc. But in this particular case, like, I'm just going to be cheeky and just Google for .NET. And if you search find a page, not Google, you can see that there's a tool to install the .NET SDK, and that's what I want. And so this is the challenge, is mapping what you need to a tool in Devinit. So here you can see there's a tool called require.NET Core SDK, and obviously this is the documentation for it. And you can see some examples here. And the easiest example is if I just take just the name of the tool, and if you go back to the JSON file, you see the structure of the file is to have this one property called run and an array which contains a set of objects, and those objects are the tools to execute. So we're just going to do this with a default because we know we need the .NET Core SDK, and that will install it. The next tool we need is the .NET Entity Framework tool. As Vix mentioned, this tool uses a database, and that uses Entity Framework Core. And so we need the .NET tools, the Entity Framework tools, to perform things like migrations and stuff like that. And so again, you can search here, There we go. And you can see the documentation here. It's like, oh, just the name of the tool, plus, like in this case, we can make it global so I can use it everywhere. Great. Okay. That's done. So if I go back to Visual Studio, so we add that tool. And so we've got the name of the tool here, the input. And again, because the way that the dev init is structured, these tools are really just shims to something else. So in the case of the .NET tool installer, it's a shim to the .NET tool install command you probably run from a PowerShell or whatever. And so here we pass the name of the tool along with some additional options, which is specific to the tool. But one other thing I want to add is I know this tool, this eShop on Web, like I mentioned, uses database. It's using local DB in my particular example. And that local DB is today delivered via Visual Studio. My Visual Studio installs local DB in a couple of workloads. But say in the future it doesn't, or say you decide not to have that workload, you should specify that, like, hey, I want to install local DB. And so what I can do is I can go back to this, and one of the challenges of local DB is there isn't a specific tool that will install local DB, but there is things like an MSI tool that will obviously take the MSI for local DB and execute it silently and accept all the prompts and stuff in the background. And there's also, if you prefer, like we currently have a tool for Chocolatey, so you can also use Chocolatey to install it. So if I just did that, you can see that all I need to do is pass in the name of the tool to install. And so there's an example using MongoDB. So we can use Chocolatey to deliver the tool. And since I'm using Visual Studio and have a schema for the JSON file, you can see that you get IntelliSense as you'd expect. And so let me just copy the name of the SQL DB tool, which you get from as a Chocolatey package. And see, that's the JSON file. So with that, I could, from a command prompt, just run it. Like if we just list here, you'll see that in the current path in the root of the repo is the .dev container JSON. So if I run .dev init, and if I can learn to spell, what will happen is we'll go through this and it will go through and install all the things we need, which is great. You can also, for what it's worth, pass in with a specific location. So if you put your dev.json wherever that you want, like in a specific per project location, you can pass in the location with -f. And of course, there's help. So there's command line help as well as in the documentation. So with this done, I now have the dependencies my application needs to run. So there's a couple other things I want to do. I want to hook it up to dev container JSON using that post create command. But before I do that, there's one more thing I need to do. I want to create a PowerShell script that will execute a couple of other things, because I know that even once I've got stuff installed, there's some commands that need to be ran. And that dev init is not a place to execute commands like you would in PowerShell or Terminal or wherever. So here I've got a PowerShell script, and I'm just going to use it to run those 2 update commands, which will perform the migrations that will get the database ready for whoever's going to press F5. And then what I do is in the dev container JSON, I call PowerShell. Since, like I mentioned, it executes in the default shell of your application of the OS, which on Windows is command. So I want to call PowerShell. And then because the default behavior on PowerShell is to require signing, I need to put the execution policies unrestricted. So that's tip number 1. And the second tip is don't forget to add the / at the start so that it's unambiguous if you meant a script or a built-in command to PowerShell. And so with that, when Vix created a code space, this command executed and installed the software, ran the database migrations, and so that you could just press F5 and off and running without any more work from the person creating the code space. So we went from having instructions like this to basically no instructions. And again, of course, as your application gets more complicated, you can obviously version and increase, add or remove dependencies from this file. So that was the demo. We talked about this quite a bit. So again, you have a JSON file where you define your dependencies, and each tool has a specific behavior, and you should really look at our documentation. We're thinking about how to build better visual tooling and some integration to Visual Studio, but for now, it's JSON. So you have to look at the docs, and then you execute the dev init command. There's also a way to run a single tool if you want to test it, for example, where you can just go dev init run and pass in the name of the tool. And yeah, this is what it all looked like. You put in your dev container JSON a link to a PowerShell script that called dev init, and then whatever per repository commands you need to execute. And then lastly, a dev init JSON, which had a list of all those things to execute to pull down the dependencies you need. And again, there's a bunch of tools there right now. Some of them are very open, like an MSI installer, which can be used to literally install anything. And some of them are very specific to Windows, like a enable Windows feature. So if you to enable specific capability of Windows. So yeah, so just a recap of what I've talked about. The biggest thing is to go away and think about how you define your environment in a way it can be reproduced. DevInit is a tool to help you to do that, so that it's easy for you as a developer, if you don't already have something, and if to define a JSON file that captures the dependencies of your application, such that it'd be super easy for someone later to go and deploy them. And this is just one option. There's many options of how to do this. Like I mentioned, if you have a script, you're good to go. If your application is solely container-based, that's fantastic. And there's many infrastructure code solutions for containers that you can use. But for those who have a Windows application, this is a new option. And really the call to action here is, yeah, check it out. Like this is a really early tool. We're just testing it now in code spaces. We aspire for it in preview 2 of 16.9 of Visual Studio to ship inside the developer command prompt of VS so that you can use it locally, because that will make things like testing and using the tool much easier. One, you won't have to be on the code spaces beta. And two, when things do go wrong, which occasionally may happen, it's much easier to use Windows, like the event manager and all the tools you have locally to diagnose those. So check out the docs, and more importantly, like there's a survey here to get some feedback information, because we'd love to hear from you. We want to make sure this tool is solving your problems. It has the features and the capabilities necessary for you to deploy and create your environments so that it's easy to get onboarded and started with a code space. Yeah. So Vix, I think it's back over to you. My rant's now complete. Sorry.
Yeah. That was great. It was great. I'm so intrigued by the new tooling that's coming along. I'm excited to see what comes out for the local experiences as well, and enabling those as well, because I've been playing with it in a code space for a while now, and I'm like, ooh, okay, how would this also work inside of my local experiences? But it's been really interesting to hear from folks in onboarding studies,
Yeah.
like in the way that you and I have also watched just like hours and hours of customers going through setting up these customizations. So I not just the customizations, but the code spaces. And so it's cool to get even more in depth and detail of how DevInit customizations and using that across the board of Visual Studio, also inside of the context of a code space, can provide value. So definitely interested in hearing what folks have to think about that. Cool. Okay, let's pull back up that slide and let's look at some of our call to actions for code spaces. So to sign up for GitHub Code Spaces with Visual Studio, like we mentioned, it is in beta. If you would going and trying it out, there may be things that there will be things that will shift and change. We are definitely taking all types of feedback from folks. So you'll want to download Visual Studio Preview, and there's a link to it there. You want to sign up for the GitHub Code Spaces beta, and then we will add you to that access. And then also, if you want to learn more about GitHub and Azure integration and GitHub Actions, we also have a resource there to learn more about that as well. So that kind of like last bit of what we talked about. So those are the main things on your to-do list. If you are interested in code spaces, if it sounds like something that would be helpful for you, or even if you just want to go try it out because it's free and you can just do it, please give it a go and let us know what you think. We are on Twitter. We will talk to you about it. So for the last slide, also just wanted to take this kind of step back and a broader look too at what's coming out and what's new in Visual Studio all up. It's not just the context of code spaces, but all up. So let's go to the next slide.
Oh, that was me. Sorry.
That's okay. You're doing great.
It's okay. That's charming. Let's see if the slide is still there.
Yeah, that's great.
All right.
Good.
PowerPoint has froze on me. So, all right.
Okay.
There.
Yeah.
Yeah.
There we go. We love live. Okay, awesome. So just to show here with some of the things that are coming out for Visual Studio all up in 16.8 GA and 16.9 preview. So here we have your AI assisted productivity. So that is in IntelliCode. We have the team completions portion of it as well. So getting your own suggestions as far as what the custom models for your team, and then sharing that with your team, those custom models. Like we talked about inside of the preview, we have GitHub Actions workflow for your .NET Core apps. Like we also talked about in the demo, we have these Git workflows. We would love for you to try those out and give us some feedback. I'm admittedly a fan, but I would so like to hear if there are things that you feel like still need to be added or changed, even just comparing to the previous like Team Explorer experience as well. .NET Productivity, the Roslyn analyzers, and the .NET Code Styler analyzers, also in preview for that last one. And we have some Linux, .NET Core debugging, and debug with Linux core dumps. So, and lastly, we have this XML diagnostics improvements. So if you would like to go try those out, update, try 16.8 GA, try and install and installing the preview for 16.9, and please give us feedback. So either through developercommunity.com, through Twitter, you have our handles. We are happy to hear from you, and it's really valuable. We spend a lot of our time just listening and asking questions to better understand where we are helping improve and where we have room to improve ourselves. So
yeah. And just a quick plug, the next talk I think is Mark Downey, and he'll be covering some of the diagnostics things you just mentioned. So stick around for that.
That's awesome. We love Mark. That's great. Okay, cool. I think we can probably, it looks like we have a little bit of time for Q&A.
Yeah, over to you, Leslie.
Yes, we do. So thank you, both of you, for that awesome talk. There was a lot of content that I thought was very interesting, and clearly the viewers did too, because we have a lot of responses and questions from Twitter. So one of the biggest questions that's being asked a lot is regarding Codespace's support and what is supported. So we have E. Brosman, forgive me if I'm messing up names here and there, but anyway, we have Dead Speed and E. Brosman asking if Codespaces support desktop development, Azure DevOps, and we also have Jeremy Sinclair asking about mobile development. So what are the different things that Codespaces supports today?
So firstly, we can talk a little bit about the Azure DevOps support. So the way that we're thinking about, we want to provide options for customers to be able to work in repositories that they know and love. I think that as we're going through the beta, we're learning a lot about what aspects of that in Azure DevOps we can provide and continue to provide. Today, you can, in the beta, go and create a code space with an Azure DevOps URL and repository. There are definitely things that we're still figuring out inside of our research and that are subject to change around what we're learning with that type of support as well. But if you'd like to go give it a go right now, you can absolutely do that today, and let us know what you think, and let us know what you want. So great question. And also we're still learning and kind of shifting and iterating on what is going to be in kind of the final version of Codespaces as well. So that's for the Azure DevOps question. Great question. Andy, do you want to take the other part?
Yeah, so I think the other part of this was really around like, hey, do we support desktop and mobile in Codespaces? And so right now, we're really just starting with ASP.NET Core and .NET Core projects, so like libraries and console apps. That's the first place we're starting. And then alongside that, perhaps not so relevant to this conference, but we also have support for some C++, like cross-platform applications using CMake and stuff like that. So those are the kind of two beachheads that we're starting with, two project types. We're obviously appreciate there's a lot of developers who are using things like desktop or mobile or other things that aren't covered by those two. But those are the two we're starting with. And, as Vic's mentioned, we're keen to hear feedback on the scenarios you have for outside those two and where we should go next. And the request for desktop and mobile has definitely been heard loud and clear.
Awesome. So other questions we got, Jay McCormick and DeVito asked, will Codespaces be extended to third-party repos like Bitbucket or on-prem repositories?
Excellent question. So as far as so two parts to that. The way that we have Codespaces set up today, I don't feel like that the on-prem repositories would be something that we would tackle anytime in the near future. As far as the third party too, we're really wanting to create experiences that expand on the tooling that we have access to. So with GitHub, like we talked about with creating a kind of like further experience with GitHub Actions, or the way that we can also have Codespaces in the browser context through github.com. That's where our focus is right now. As far as the other third-party repositories, we have heard that from customers, like with Bitbucket. Very much heard. As far as where we're going to go next with what we support, I think we're also, similarly to what Andy said, we're trying to get a good base core experience for Codespaces first inside of the context of GitHub, and also adding in some of this Azure DevOps support. And then once we have that as a solid foundation and knowing that it's working well for folks, then I think we can start exploring research around what other types of repositories we may or may not support. But today it's focusing in on those two.
Great.
Do you have anything to add to that too? Or?
Not at the moment. I think the on-prem thing is interesting. Like I kind of talked about, like Codespaces don't have access today to on-premise resources, but this is something that we're aware of is a challenge. Like you might have a SQL Server you're sharing, for example, amongst your peers. And so this is definitely something we'd love to hear more about, because bringing in access to on-prem resources brings in all sorts of interesting complexities in terms of management of resources and things like that. So that's definitely something you can reach out, and I think something we'll be actively researching about how we enable those scenarios.
Yeah, good points.
Okay. Up next on the topic of dotnet, Jug Harton and D. Morazanato ask, can you run a dotnet to set up a local machine? And also, is there a way to get the base image used by GitHub Codespaces to locally test dotnet configuration?
Yeah, so on the first question on the local side, yes, we plan to ship dotnet as part of Visual Studio in the 16.9 timeframe, hopefully for preview 2. But we definitely realize that shipping it locally is a great way to test, because when you're creating that JSON file, it's nice to have a small loop rather than go to Codespace and try it every time. So that's definitely there. For the base image is not available. We do list out what software it has. So there's documentation if you search for Visual Studio Codespaces in Windows, and we'll list out all the stuff we have in the version. But the image itself isn't available because it's a syspressed image that has license key and stuff associated with it. But the list of software is there, and you could reproduce that. And I can look actually at sharing either a dotnet file or some other file that will allow you to create that image. And so you could just mount it locally in Hyper-V. But we don't share the direct images.
All right. And I think we have time for one more question. Andreas Fredrickson asked, is it really worth getting into GitHub if you're just working alone? What are the perks of using GitHub when you're the lone writer of your development?
That's a great question. I can think of a couple off the bat. I think that there was a long time where I was using GitHub and just as an individual going through different testing applications and different samples and learning in that context. You still have access to the other additions of tooling, even just inside of a code space, and how as an individual working alone, I'm not sure what this particular person's context is, but even when I am primarily working alone, doing work for a nonprofit or grassroots organizations, I have to switch context quite a bit, because there will be maybe a small update on this app or an update over here. And I find that Codespaces has provided value for jumping context, even in the context of just being the kind of like sole developer on the project. So that's something that comes to mind for me. Interested, Andy, if you have thoughts as well.
Yeah, I always think back to college, makes me so old now. Disaster recovery. Like, I don't understand the full context here, but having your source code in a place that can be accessed from other machines is always very useful, both for history control, so you can see revisions, like you can go back in time and see stuff like that. So I'm not sure if the question was about GitHub as much as source control. 100% source control, like there's so many good options, free and otherwise, to have source control. So you definitely have that. GitHub specifically, frankly, it's just the best place for source control out there. Am I allowed to say that?
Yeah.
All right. Great. Well, thank you two so much for that very informative talk. And they listed their calls to action as to how you can learn up on all these cool new tools such as Codespaces and DevNet. And with that, thank you guys.
Yeah.
Thank you. Enjoy your rest of the day, everyone.
Yeah.
Sweet. So next up, Andy already plugged just a couple of minutes ago that his colleague Mark Downey would be here to talk about debugging in Visual Studio. So keeping with the theme of Visual Studio working to improve .NET productivity, Mark Downey, who is a senior PM on the Visual Studio team, is going to talk about the ways to effectively diagnose and debug .NET applications in Visual Studio. So passing the torch off to you, Mark. Welcome.
Hi, Leslie. Thank you very much. Hi, everybody. My name is Mark Downey. I'm a program manager on the Visual Studio Debugging and Diagnostics team. And I want to take the opportunity to talk to you about how you can effectively diagnose and debug .NET using Visual Studio. So my talk today is going to be kind of split into three topics. I'm going to be talking about debugging .NET with Windows subsystem for Linux. I'm then going to go talk about how we can enable certain debugging tips and tricks to make your life easier as you kind of navigate Visual Studio on a day-to-day basis. And also I wanted to kind of introduce the perf tool and how that can be helpful in helping you kind of see day-to-day issues that might come up in your code, that kind of hidden perf issues that can kind of be revealed using that kind of tool. So first of all, talking about Windows subsystem for Linux. Well, what is it? Well, it actually is it's a tool that allows developers to run a Linux environment directly on Windows, completely unmodified. And unfortunately for us, it comes without the overhead we normally associate with virtual machines, and certainly the overhead we associate with dual boot setup. So what you can do as a user of Linux distro is go to your Microsoft Store on your Windows 10 machine, go find the Linux distro that you like the most. You can install it directly from the Microsoft Store, and then you can run common commands like grep and awk, and you can also run bash shell scripts and command line applications and so on and so forth. So WSL2, Windows Subsystem for Linux 2, is simply the latest iteration of the Windows subsystem, and it has much improved speed over the original incarnation. So why would you debug with WSL2? I know many of you are thinking that I have containers locally, I can remote debug over SSH, and all those are good. But we believe that WSL2 debugging gives you a real sweet spot between production realism and your actual productivity, just getting things done. So the things about WSL2 that we love is that it's really fast and easy to install. It's fast in and of itself. It doesn't require you to have a bunch of other tools sitting in the background. So again, if production realism is what you're after, then maybe a container is the best solution. And if you need to connect directly to a production environment, maybe remote debugging over SSH is the better option for you. But if you just need to verify and validate some things locally, quickly, and easily, then we want you to consider Windows Subsystem for Linux too. So I'm going to hit into a demo to kind of really show off what I mean by fast and easy. I have been working, the problem space that I kind of want to introduce this to you with is with an open source project I have called DOSBlog. I have been using DOSBlog for some years now. And DOSBlog, I more recently converted DOSBlog, which is a system web old school IIS web forms application, and I've been converting it to ASP.NET Core, and with the intent that it should be run in a cross-platform fashion. More recently, colleagues have been using it, And one of them realized that there was problems on Azure App Services for Linux that I couldn't replicate on my Windows machine. So he proposed, hey, go install WSL2 and investigate. And so what I'm going to do now is just kind of show you how we use WSL2 within Visual Studio, and then track down a bug that is only has impact on the Linux environment. Okay, so I am going to go ahead and open up my DOSBlog project here. And as you can see, immediately in the launch profile, my mouse is all over the place. Originally in the launch profile, you'll see we have a new option, WSL2. Now, in order to get that, you will probably realize that those are kind of driven by the launch settings file. If you look under your project file, under properties, you'll see launch settings JSON file. And in there, you'll see a defined JSON object here with WSL2. I'm going to go ahead and get this started while I'm waiting on this. I'm going to go ahead and launch that. And what I can do within this launch settings, you can see that there is a command line, WSL2, and a distribution name here, which is left blank. And really what that's doing is it's using the command line tool, the CLI, for Windows Subsystem for Linux. And if I list them, I can see the list of Linux distros I have locally. I actually have Ubuntu 18.04, I have Ubuntu 20.04, I have Debian, and the default one right now is Ubuntu. So in my actual launch settings program, the actual one that will pick up is my default. So if I actually wanted to change that, I could actually do WSL-S and change it to Debian and have Debian as my default if I wanted to. Alternatively, I could go into my launch settings JSON file and add other options. So I could literally add specifically name a distribution that I want to debug as. For now, I'm fine with Ubuntu. My colleague is running Ubuntu, so I'm fine with that. So I'm going to go back to my project, and I should be up and running here momentarily. In fact, should be running momentarily. Here we go. Let me try that again. And as you can see here, it actually is building out an output directly to, you can see it's mounting everything here, building directly into the Linux distro rather than your local machine. And these are all being loaded into WSL2. So you can see my output running there. Let me see this. I can get this running one more time. And that's still going. Hopefully this will do it. 1 second. Give that just a few seconds more and hope that my local debugging will start. Let me see. Looks like it's not coming from me. Okay, I'll continue with this. In principle, what was happening here, I don't know if it's pretty obvious to some of you who are Linux developers. I made an assumption about this particular project that assumed file names all began with a /. Unfortunately, that's not the case for Linux. And essentially what I should have done here, and that became obvious once I was able to start debugging in with WSL is that there are there's actually options that allow me to decide what the directory separating character should in fact be. And so this allowed me to kind of see what values were being passed in. I could see it wasn't a Windows directory. I could see that there was other assumptions I needed. And essentially using path.directory separated character allowed me to realize that actually the data I assumed would be there was actually Linux based, and I needed to correct that. I'm going to go ahead and start looking at our next section here. And debugging tips and tricks. Let me switch to doing my regular debugging. Hopefully I have more luck here. I'm going to start debugging here. So as we think about debugging more generally, I like the idea of thinking about my debugging in a couple of different simple ways. I like to think about the data that the debugging session has, and my objects have particular values, set of values that I'm interested in. So I like to think about the data first. Then I like to think about the call stack second. I like to think about the context in which my application is running and which call stack it's running in. And then finally, I like to think about the big picture. What are my threads doing? What are my tasks doing? And so as I think about that, I think about the different ways I can use Visual Studio to kind of get me close to all of these particular types and techniques of debugging. So let's move now back into Visual Studio. Hopefully I've had more luck here. It's still loading here. Excellent. Close down some of my other windows here. All right, perfect. All right, so I've logged in now. I'm going to go ahead and set a breakpoint right here. And I'm going to go to my blog. I'm going to select a particular post and hopefully hit the breakpoint. Perfect. Okay, I've hit the breakpoint. Now, as I said, I like to think about data first. What are objects and what are my properties of those objects? So for that, I like to think about pinnable properties. So for example, I could look at this object here and see it has all these particular properties. And I'm actually interested in seeing the author information. I may be also interested in seeing the entry ID, and I might be interested in seeing the title. And what that does for me, that pinnable property, being able to pin that allows me to have this information pinned to a particular location in source. So as I'm kind of debugging my issues, I can use this as a mechanism for kind of highlighting the most important data for me as I move throughout my application. So that's pinnable properties. As you can see, I'm pinning to source at the moment, but I actually can unpin that and actually have it navigate with me as I go through the file. And I can see that information consistently with me. Obviously, this information exists in locals and in autos, but sometimes you kind of almost want to pop some information quickly and easily and consistently in a particular location as you debug. So that's pinnable properties. And then as you can see, I've kind of set this breakpoint right here. And there's technically, I actually want to start debugging this get comments method right here. But as you can see, I set a breakpoint on line 69, and that's supposed to be a breakpoint on a particular line of code. But technically, this is 69 to 77. And I actually want to step into this location. So if I actually hit step into, I'm always kind of confused about where I might be stepping into. Am I going to step into a get or a set? And there's obviously a bunch of gets here. There's a select query, link query select here. There are a bunch of other methods that get called. But I actually am interested in going specifically into this method. There's a nice little trick here I want to kind of share with you. If you right click in the window, you can step into specific and go directly to get comments. So I'm interested in going only to this one right here. So normally what I'd actually do is go find get comments and put a breakpoint in it. Well, you don't have to do that. You can simply right click, step into, and get comments. And again, now I can start diving in deeper and deeper into the call stack. I'm going to hit my step into, which is at F11. I'm going to go ahead and step in. I'm going to go down a little bit further into the call stack, and actually one more step into the call stack. Because now that we've kind of thought about what data looks like, I actually want to look about what the call stack. So I like my call stack window to be right there with me. And the call stack's telling me I'm obviously where I am. But now if I wanted to, I can right click inside the call stack window and run to cursor. That allows me to pop back out. I've been pushing into my call stack. I can now pop back out of my call stack by hitting run to cursor, and that pulls me right back out, right? I'm now actually I'm actually only one step deep. I've allowed it to run. And actually, of course, I can then go right back to the top of this call stack by run to cursor again. And then just again about navigation of within here, within the call stack and within the method, within this particular frame, I actually can, if I wanted to repeat something, maybe I missed something or I set the breakpoint too late, I can go back up towards the top and pull my next statement via the yellow arrow and kind of reset where my next statement is and start to execute again. And I can hit continue there and go back to my breakpoint. What I can do is if I want to go forward, I can hover over a line of code and run to a particular line of execution. So I can run further into my code by hitting that particular line of code. So again, the idea here being I can not only see more data, but I can navigate my call stack. I can navigate around in my code. I can go backwards. I can quickly move forward. All these are kind of help you save a bit more time as you kind of debug. So in addition to this regular everyday debugging on the call stack and with data that you have, I also like to think about the big picture, the even bigger picture of the call stack is really the thread in which that call stack is running in, or the task that that particular call stack is running in. So I also have another quick application here I want to show. This is from my friend Christoph. He's a brilliant diagnostics and debugging engineer. And he created this app that allowed you to think about things in terms of threads and tasks. And what we're going to have here is 3 people that are making orders, and we see that the orders being processed. And after they're processed, at some point, this application gets stuck and doesn't process any more orders or add any more orders. And now there's really no information within the data objects themselves or within the call stack that can help me at this point. So now I need to take an even bigger step back and think about what's happening to my threads. And I think a really powerful tool to doing that is the parallel stacks window. So I'm going to go ahead and pause. Obviously my app's no longer responding. None of the orders are being processed or added. So I'm going to go ahead and pause the app. And I'm going to navigate to the parallel stacks window. And it now is a slightly different view. You may have noticed Visual Studio has always had a threads window, which presents a tabular view, kind of like a row by row view of threads. And we've always had the tasks window, which again throws a row by row view, a tabular view of the tasks. With the parallel stacks window, we have a more visual cue about what's going on with your application. It allows you, one of the really important improvements we've made in recent previews and recent releases is additional annotations within the call stack to let us know what might be going on and the relationship threads have with each other. So as you can see, the current call stack that I'm looking at in the bottom right corner here, I am waiting on a lock. I can see that it's annotated as a frame, and it says that it's waiting on a lock that is being held by thread 28492. And so I can now see by this view is that I've got 31 threads that have the exact same call stack, and I have 30 of those threads are waiting on thread 28492. I then have one thread that is waiting on thread 11020. And I can actually go through and figure out actually what's become just obvious to me. And I'm hoping this is large enough for you good folks to see. Let me just scroll in a little bit here. But 28492 is rating on a lock owned by 11020. And if I scroll over here, I just think I saw 11020 is also waiting for a lock owned by 28492. What that has quickly told me is that two threads are essentially waiting for the other thread to release something so they continue processing. That is what we describe as a classic deadlock scenario. And by quickly inspecting the large picture, the big picture presented by parallel stacks, I get to see what's going on between my threads. Again, that's the big picture view. Parallel stacks comes in two iterations. You can think about it as threads and tasks. So I can actually switch to the tasks view and start to see that, again, it's got these deadlock symbols all over the place. It's even more obvious now that, in fact, I'm in a deadlocked scenario. Everything is waiting on something else. And unfortunately, that something else is waiting on the original thing. So I'm in a deadlock scenario. This is probably a low CPU deadlock scenario. All right. Let me move on for the last few minutes here, and let's talk about perf. So everybody that starts producing code and putting it into production, I think sometimes we get tricked into thinking that the only time we can measure is when we go to production. However, we have perf tools inside Visual Studio that allow you to measure how effective and how efficient your code is or is not running. So I'd like to introduce you to the perf tool today, so you can quickly get started with kind of analyzing methods and code that you have running locally, and just to see how it's running. You may be surprised at which parts aren't running as efficiently as you think. Let me show you what I mean by that. Let's open up one more project. So I have one more project to share with you. It's called Buggy Demo Code. It's an application I've created with the express purpose of creating code that doesn't necessarily look obviously wrong, and using that as a mechanism to describe what the things we want to measure potentially before we go to production. So if I wanted to measure this particular function, this poor regex function, I'm kind of giving away my punchline here. But if I wanted to measure this, I could go to, I would set it as a release project. I would go to debug, and I would start the performance profile tool. And then I could start profiling specifically around .NET async and CPU usage in this instance, but I could also do things around counters. I could measure how long my database queries are taking, how much allocation's going on, how much memory my application's using overall. There's a bunch of measurements we can do, and we're supporting, and we're building up more and more capability there. So quickly, I want to move on. I've just got a couple of minutes left here. So I actually captured this particular trace a few moments ago. I didn't want to do it while I'm presenting. And as you can see, I took a trace. I saved this trace, and I took a trace for 42 seconds. So that's the timeline you're seeing across here. And in the y-axis, you're seeing the percentage of the CPU usage. As you can see, when I started up, there was a little bit of activity there. But the real activity came when I actually started to test my code. And as I started to test my code, it became obvious where the inefficiencies in my code existed. Now, as I said, the code I showed you had a really big for loop that was writing to a file writing to a disk and doing some small calculations. I had a big while loop that was writing to a disk, and then I had a single regex search on a relatively small URL. And what we end up seeing isn't that the for loop or the while loop ended up with the CPU usage, but that regex was actually really, really badly designed. And as you can see, it actually ended up consuming about 94.9% of the resources, all focused on this regex. So what I can do here is use this hot path to really allows you to see which path your code took and which one is the most likely to allow you to find improvements. And then if I click on that particular path, it kind of lands me directly in my code. And this code is supposed to simply detect that I've got a valid URL. Unfortunately, it's so badly designed that it ends up consuming a bunch of my CPU. So that brings it to a conclusion. I think I am right at time. If I could, once again, highlight some of the releases that we've had. we've got, again, as was mentioned in the previous session, dev environments in the cloud with code spaces, AI-assisted productivity. Check out the GitHub actions around workflows that you can do that directly in Visual Studio now. So you can think about your CI/CD and your DevOps scenarios directly in Visual Studio. Git workflows are amazing. Again, I am doing most of my open source work with GitHub using Visual Studio now. I don't actually do the command line stuff anymore. I think you'll love that. Consider again the Linux diagnostics, the area I just spoke about. The WSL2 native in Visual Studio gets released with the 16.9 preview. Please check that out. And my team just released debugging managed Linux core dumps directly in Visual Studio. So you can take a memory dump on a Linux box directly in your production environment, get that onto your machine with Visual Studio, and drag and drop that directly into Visual Studio and start a bunch of analysis, including on the parallel stacks window and other things there. That kind of brings me to the end. Thank you so much for joining me. Again, my name is Mark Downey. You can reach out to me at PopperString on Twitter with any questions you have or follow-ups. I would love to hear from you. Thanks so much.
Thank you, Mark. That was a fantastic talk. Not to be biased or anything, but debugging is awesome. Or I mean, debugging can be frustrating, but the tools that Visual Studio has certainly aren't.
Right.
Cool. So we have one question from. Oh no, we got a couple. Okay, cool. So first question, the Stonehead asks, what are the benefits of debugging in WSL2 versus inside a Linux Docker container?
I would say it's all about speed and convenience. I think if you want to really focus on a scenario that feels like production, then maybe Docker is the better alternative. If, however, like me, I was kind of just trying to figure out the lay of the land and figure out directory structures and how that worked, then I think WSL2 is just quick, easy, productivity is high. I don't necessarily have to have the overhead of installing a bunch of services. It took me just minutes to install WSL2. So again, it just depends on your scenario. If production realism is what you really want locally, then yeah, absorb the cost of the overhead associated with Docker and virtual machines. If, however, you just need to quickly check something, WSL2 is a really, really good option.
Cool. So similar, but maybe just more like auxiliary too. Luis Brian Orexon asks, WSL2 can give you a lot of information, and can all that information be shown with Power BI as well?
Okay, so this sounds like more of a WSL2 question, and I'm not really sure, but I will follow up with you, Brian, online and see if I can get the answers you need to that.
Cool. F Small asks, what's the best practice workflow when dealing with threads and the parallel stacks window?
So again, I think the question, I guess I'll answer the question broadly. I think the idea here is that we want to think about, when you want to think about the big picture of your application, for example, if I start memory dump debugging, I start with the parallel stacks window because I'm thinking about what is the entirety of my apps doing, right? So if I have an app that is multi-threaded, that is got lots of tasks doing a lot of things, I always start my debugging and diagnostics with the parallel stacks window because that gives me the big picture view. And then from the parallel stacks window, I get to narrow in on a particular call stack. If, for example, I've got runaway threads, then I'm kind of interested, or threads are being blocked. I kind of think about, well, what call stack should I pick out from the parallel stacks window? Because that's the big picture idea. Now, if I'm thinking about data, yeah, then I'm going to tie in to pinnable properties. I'm going to look at the locals window. But if I'm thinking big picture, I'm thinking threads, then I start with parallel stacks. I think it's a great feature.
Great. And I think we have time for one more question, also about the parallel stacks. So Dr. Edgar Knapp asks, seems to me one can find wait for cycles automatically from the info the thread diagrams contain. Is this true, or is this in the plans?
That's a really, really good question. If I hear that question correctly, I think you want to know how long something's been waiting on a lock, maybe. And if that's the question, that would actually be really, really interesting additional information to add. And I'll make sure to follow up with you because I'm really curious about the idea you have. But what I'm thinking I'm hearing is that you want to know how long something's been waiting for a lock to release. And that would be really, really interesting, especially when you are thinking about the constant moving parts of threads, and that a deadlock may not always be the most common scenario, but certainly waiting for too long for a lock to release is a common scenario. And I think that additional information would be very, very powerful. So yes, I think that would be a really, really good idea.
I also think that would be a really good idea. I can see scenarios where you're just trying to determine what the issue is for time help.
Yeah.
Sweet. So that is all the time we have. Thank you so much, Mark. Please go check out all these cool debugging tools. It'll make your life so much better, we promise. And yeah, thanks for joining us, Mark.
Thank you for having me. Thank you. Appreciate it.
Cool. So actually, I'm about to pass the torch over to my VS Toolbox co-host. He has been hosting the show for years and has been living the cushy retirement life now. So I'm going to push the next remaining VS related talks over to Robert Green.
Thank you, Leslie. Hi, everyone. Welcome to the next part of our .NET Conf Day. We are continuing our look at Visual Studio. And our next guest is Katie Caldwell. She's a Visual Studio PM. And she's going to talk to us about what's new in Visual Studio 2019 and beyond. Hey, Katie.
Hi.
How are you?
I'm great.
Everybody should know and probably knows that Visual Studio 2019 16.8 released yesterday. You should download it, play around with it. Lots of great stuff. You're going to tell us all about it, right?
Yeah, so I know we have a short amount of time today, but I'm going to try to go through some of the recently released features, and I'll get it through as much as I can. If I don't get through everything, there is a session right after that will go through some of these new features as well. Is that great? Cool. So let's actually get started. So today I will try to breeze through as much as I can. And today my demos will cover customizing your Visual Studio environment. So that includes how to actually apply those really cool themes. I will also demo how to get those, how to have some custom .NET Core templates, how to apply those, how to get those. I'll also we'll be looking at solution filter. So I'll be demoing how to actually filter a solution load, and I'll actually save that filter for your next loads. I will also be showing you how to configure some of your file nesting. And after that, I will show you some of the productivity tools if we have time. So I will show you IntelliCode team completions, IntelliCode suggestions, and also show a really cool preview feature that is called Web Live View. So let's get started. Okay, so I am actually going to switch over to Visual Studio now. And we will start. And the first thing you'll notice as you see Visual Studio open, you'll notice that I have a really cool theme. So how did I actually get this theme? So let me show you how I downloaded, installed, and applied this theme. This is a really cool way that you can personalize Visual Studio just as you like it. So the first thing I'll do is I'll actually use Control Q, and I will go and look to manage extensions. And the reason why I'm going there is because that is currently how you can download and install extensions and how you can install specific themes. So let's actually use the search bar again here and search for themes. And as you'll notice, I have two themes already installed. So these are two extensions. One is Color Themes for Visual Studio, and the other one is OneDark Pro. OneDark Pro is the one I'm actually using. But if I wanted to install another extension that would give me themes, I could install, let's see, say mid-century themes. I would download this, and the way to actually install this theme is after download, you will have to close all your instances of Visual Studio. And once you close those instances of Visual Studio, it will install this as a V6. And then later you will be able to, upon reloading of Visual Studio, you'll be able to select that theme. So let me show you, since I've already downloaded OneDark Pro, how I've actually applied this theme. So again, I'm going to use Control Q to search, and this time I'm going to search environment. I could search environment, or I could actually search themes. And you can see the top item is change environment color themes. So I'll click that. And as you'll notice, the color theme I've selected is OneDark Pro, which is the theme that I installed via the extension. I could also go back to the default blue that you have, and I will do that just for the sake to show. And as you can see, voila, I have reverted back to the default blue. And let's show that again with Control Q. I'm going to go to themes, and I'm going to select that and go back to that OneDark Pro that I really enjoy. So I am sure that everyone loves just personalizing Visual Studio. So let's continue on with a couple other ways that you can customize and personalize Visual Studio. So another way is, as a developer, one of the pains of beginning a new project is setting up that project with all the class library folder structure, or configuring the dependency injection. So project templates really help save you time, that startup time, when you're beginning a project. By adding what you commonly use and bundling this in a template for reuse later. That means that there's no use or no need to copy, paste, or rewrite code that you've already written from previous projects. So once you've created a template, you can just simply reuse this template the next time you create a new project. So I've already created a project. I called it Test Console App. And the notable thing about this console app is I've already created specifically I've written a class called Observable Object. This is going to notify you anytime there's a property change. So this is a very common thing that you would do, and something that I would probably want to reuse later on for when I'm creating another project. So one of the really cool things you can do is you can create this as a template. So I'm going to use Control Q again for searching, which is a great little shortcut. And this time what I'm going to search is template. And as you can see, and at the top, you see export templates. So I'm actually going to do a project export template, and I will walk you through this. So as I choose the template type, I will choose project template. And this is called Test Console App, this project. So I'm going to base it off of the project. If I had multiple projects loaded, I would, of course, select which one I would want to use. So for this one, I'm going to say this template includes observable object class. And I could really say whatever here, whatever makes the most sense for you. This description will really be helpful for after you've saved this template and you want to reuse it later. This is extremely helpful for you to figure out exactly what this template is doing. So put whatever description that would be helpful. So I've actually saved a really cool icon earlier today. So let me actually back and click this .NET icon. And I'm going to select that .NET icon again. And the next thing that I'll do is it's going to display the Explorer window. Oh, 1 second. I will delete that file because I've done this before. And as you can tell, what you're seeing a bit better. You will see under Visual Studio 2019, my exported templates, you'll see that this template that I've just exported, as you can tell, I've done this before. So I did this yesterday. So you'll see a previous folder that has this, but it's as a zip. And the cool thing about this is I can actually unzip these, I can extract all these files and I can go into these files. And since I've already done this, I will go inside there and you will see that there is a mytemplate.vs template file that I can actually open in Notepad or any sort of note or text editor. And I could also open it in Visual Studio. And one of the cool things about this template file is that I can actually update the metadata tags associated with this, which will help with filtering. For sake of time, I'm not going to open it right now, but I will go back and show you how you can actually go and access this newly created template. So let's go back and let's say that we want to start a new project. So I'm going to select File, New Project. Having a little delay here. Sorry, folks. Okay, cool. And you can already see that I've pinned this from yesterday, but let's just see if we can see this show up in the list. This newly created template. Let me actually just go and search and filter here. Let's go down. Let's go back to the top. And let's see, Devs Console app. Back. Sorry, the filter is going just a little slow today, but we're going to try to see if it's filtering. I think my machine's just running a bit slow, but for sake of time, I want to just show you that it is actually filtering and showing this in the list. It will show in the list, but as you can tell, I already have this pinned for myself. Once you've actually created this filter, or once you've actually created this template, you will actually see this template show up, which is really, really cool. You will see this show up automatically as part of not just your recent project templates, but also within the superset. You can utilize the metadata tags associated with that template to then filter. So I can add a language tag. I could also add in the platform or the project type. All of these are metadata tags that can be configured from that template file. So for sake of time, I'm just going to show you with this project template that I've created. I'm actually just going to select that. I'm going to click next, and I'm going to call this Test Console NET Conf. And I will be created as a new solution. That is fine. I will use the same solution name and we will create that. And as you can tell, you'll notice that the observable object class is there. It's literally just ported this over. So for sake of time, I'm going to move forward to the next demo. And the next demo is actually going to be solution filters. So a really cool thing about starting on working on a big project as a developer is the ability to work on some pretty large code bases or some pretty large projects. But one of the issues that happens is that Visual Studio performance, as you could tell, I was having some performance issues before. Visual Studio performance can sometimes be a drag if you're trying to load a really, really large project. So I'm sure that you've probably worked on a large project and you've been waiting for all the projects to load in that solution, and that can be very frustrating. So luckily, Visual Studio has a new feature that allows for solution filtering to select which subset of projects you'd like to load at a time. This decreases the solution load, really improves Visual Studio performance, really improves that sort of like local build and test runtime by enabling you to just focus and review just the sort of cone of influence that you care about. So let's actually get started. So what I'm going to do is I'm going to show you how to actually do this. So one of the things you want to do is you want to open a project. So let's say I want to open a solution, a pretty large one. So I'm going to go and pretty large is called the. So let me go into that folder. And as I go, you can see there's a ShareX solution. So what I would want to click is I would want to check the box, do not load projects. And by checking this do not load projects, I'm able to load selectively which projects I want to. So what will happen is I will do not load projects. I will open up the ShareX solution. And as you can tell, it loaded very quickly. The solution is loaded, but none of the projects are loaded. So let's say that I'm interested in working on, a specific, part of this solution. So maybe I'm responsible for working on, maybe something that's more, back end. So maybe I'll work on the helpers, and maybe I will work on perhaps like the image effects, right? So what I would do is I will highlight the one that I will select which project I want to load. So let's say the helpers lib, as well as maybe image effects lib. So I'll press Control and also select, so I can do that multi-select. And then what I will do is I will right click, and then I can reload the project. So as I right click, you'll notice that instantaneously those two projects are loaded. So let's say I want to hide these other projects that I don't decide to load. So I will right click again. I'll right click on the solution and I will say hide unloaded projects. You'll notice that I can also load all projects here as well. But let's say for right now, let's just hide the unloaded projects. So now I'm just focused on the projects that I care about. So another thing that I can do is now save this as a solution filter. So let's right click again, and you'll notice that there is a save as solution filter. And this really helps me for the next time that I decide I want to load. So let's call this backend task. And we can say backend task ShareX, right? And so as you'll notice, what I just did is as I save that, the next time I come back, I can actually go back to that solution and load that solution. So let's actually go back and do this. So let me save this as a solution filter again so I can open this up. Let me actually not do this and let me go to the File Explorer. Okay. Sorry, my computer's going a little slow today. So let's actually do this one more time. And you'll see backend task ShareX as a solution filter. I can actually select this And as I select this, I can, when I actually open this, so once it opens, you'll notice that it will only open the specific projects that I've saved for that solution filter. It's just opening a bit slow. Let's do it one more time and see if it opens. Okay, I think it's just opening multiple times. 1 second. I see it opening now. Oh. I think my screen share is causing a lag. So let me actually close this. I think I've clicked it too many times. No, do not do this. As you can tell, it's opening very slowly, but it is opening. This is probably just due to having multiple instances open. So let me actually close some of these. And as you can tell, I have this solution filter open back in Task Share X that I've created. And as you can see, 2 of the 11 projects are loaded, and I can just start focusing and have a focused sort of coding session. So let me close some of these. Okay, let's close some of these, and then I can move on to the next demo. It really wants me to focus on this task. So the next thing I want to show around just personalizing the Visual Studio experience is around configurable file nesting. So file nesting is important for nearly all projects. However, it is essential while working in large projects. So we've all been there before when we have a number of files that we have, just a bunch of files that we want to nest under each other just to make it make sense and also to clean up our Solution Explorer area. We received a number of feedback tickets, as well as just a fair amount of feedback from you all about how difficult you found configuring file nesting in Visual Studio. That just the file nesting default that you have might not necessarily be the rules that you want to apply. So having the ability to sort of configure some of these nesting rules is very, very important for many of you. We heard you, and now we want to support you to do this. So if you don't like what you have out the box, you can always create your own custom file settings that instruct Solution Explorer how you want to nest your files. You can add as many custom file nesting settings as you like. You can even switch between them as desired. So you can create these new custom settings. You can just start with an empty file. You can also use the default settings as your starting point and then edit from there. So let's actually see this in action. So I'm going to jump back to Visual Studio, and I am going to show you, once this closes, I'm going to show you this application. Let's make this a bit larger. And as you can see, I have a number of files. Just look over here under the resources on the right in the Solution Explorer. You can see I have a number of files that sound pretty similar. So I have portal.coffee, I have portal.js, I have portal-vsdoc.js. All of these files, maybe you want to clean up. And of course, this is a smaller set, but many people have a lot more files that, these can get pretty gnarly very quickly. So how would I actually do this? So directly in Solution Explorer, we have this little icon that allows you to have file nesting. So you can actually click this icon to actually enable file nesting. Another thing you can do is you can right click on the respective area or scope that you care about having file nesting. So I can right click on the solution to add file nesting. So you'll see file nesting. I can add solution settings directly here. I can also, on the specific project, do the same thing. So I could also here add file nesting here for at the project level. So what I will do is I will actually just, I've already created some this before this time, just so that we can get through this a bit quicker. So what I will do is I will just actually enable the file nestings that I have. I can actually add custom settings here. So let's actually just do that. So let's use the default as the template, and let's call this .NET Conf settings. And so as you can tell, this is actually the default settings that have been created. And so this provides you with all the rules that are relevant for this this project or the solution. So one of the things that we can do is we can actually enable this. For the sake of time, I'm not going to edit, but you can always, like I mentioned, edit all of the, any of these rules, and that will enable you to have an easier, cleaner experience in Solution Explorer. So let's actually see this in action. Okay, I think my machine is actually frozen. Having a bit of issues with the machine, so we might end up having to move on to the next demo if it does not unfreeze. So I think my Visual Studio instance is frozen. Let's do this one more time and see. Yep, I think it is. So I'm actually going to go to the next demo, and hopefully we can come back to it and see this in action. But the cool thing that I wanted to show is you will see there's a nesting based off of these rules. So we would actually see that this npm shrink wrap JSON would be nested under the package.json, and then also portal.js would be nested under portal.coffee, and portal vs doc.js would be nested under portal.js. So these are things that would have happened. Just having a bit of issues with this specific instance of Visual Studio. We'll come back to it and see if we can actually get this working if we have time. So moving forward, I don't have too much more time, so I actually want to just focus on one last demo that you probably haven't seen before. So I would have loved to see IntelliCode. I believe other people will. I mean, you can see my own videos as I am the IntelliCode PM. You can see my own videos online, and we can show those later. But I really want to show Web Live Preview. It's something that's super cool. It's a feature that is still in preview. Let's just actually get started with that one. So I'm sure that as an ASP.NET developer, you're going to love this new extension. So if you've ever worked on an app that has some sort of UI, you've run into this issue. You make a change, you compile and run that app, you see the change wasn't exactly what you wanted, you sort of see you stop debugging, you go back, you wash, rinse, and repeat, and you do this over and over and over again, and it becomes sort of like Groundhog Day, where it's not exactly what you want, but you have to go through this whole process in order to actually see what happened and change it. What if you could actually change this in real time? That would be really cool, and see what your edit would be. We've recently released a new editing mode experience called Web Live Preview. So Web Live Preview enables a real-time mapping between your source code and a rendered HTML for your ASP.NET Framework apps. So let's actually see this in action. So hopefully this is going to work out. I believe I have it open here. Let's actually see. I don't think. Let's actually see if this works one more time. Okay, still having frozen screen. So let's actually go back to this. And I am going to go back and open the solution one more time. Sorry, folks, just one more time. Having a slight issue with this. I had to reopen the file, just having a slight issue. I'm going to go back and see. I'm having just a slight issue with this, but the goal here is for me to show you. I will actually just go and show you IntelliCode suggestions as I'm having an issue with opening one of my files. So, so let's switch gears and I will actually show IntelliCode suggestions. So you're probably super familiar with IntelliCode at this point. So IntelliCode is sort of the suite of AI-assisted developer tools that are available in Visual Studio. We've been around for over 2 years. We've showed you previews of IntelliCode completion. So those magic stars you get in those IntelliSense lists that sort of gives you the most likely completion for a given context. So we showed that at Build 2018. And since then, we have been providing more interesting, cool features. So one of our latest features that we GA'd just a few months ago is called IntelliCode Suggestions. And IntelliCode Suggestions, and that allows you to get suggestions based off of repeated edits. So whenever I'm making multiple similar edits in my code, I will be provided a suggestion that will help speed up that process and make it less onerous and much faster. So let's actually see this in action. So let's actually start with editing. I'm going to edit a file. So in this file, what I've done is I've hard-coded a number of Fahrenheit to Celsius conversions. And I've actually created an F to C helper method that will actually make this a bit like this code a little cleaner instead of having all of these hard-coded conversions. So let's actually use that helper function. So as I mentioned, it's called F to C. And what I'm going to do is I'm actually going to just call F to C and use that variable fmin. So I'm going to go to the next instance where this would be useful. So here's another hard-coded conversion. So I'm going to use F to C again. I'm going to make that edit one more time. Okay, so I've done this. And now I'm going to go to the next instance. And as you'll notice, this is my next instance. Here, you'll see that there are 3 small dots underneath. And what it's doing, it's telling me that IntelliCode suggestion, based off of my recent edits, is already providing me with a suggestion to call that helper method. So it's seen what I'm doing. So what I'm going to do is I'm actually going to look through this. I'm going to click this. I could do a control dot in order to enable this from with a hard key, or I'm just using my mouse here. And then what I can do is I can actually go and select, and you can see I have a couple options. So I can go to the next suggestion, which it gives me the line numbers of this current location, but it also can take me to the next one. I can also apply, as it's sort of seen through my code, I can apply the suggestion in 4 other locations in this file. So I can apply it all at once, which will definitely save me time. I can show the 4 IntelliCode suggestions. And if I do this, it will actually, let's see what it does. It'll pop open this tool window that will provide me with the different locations that I can apply this. Again, I can go back here, or I can ignore suggestions like this. Just let's say that it wasn't actually helpful or isn't exactly what I want to do. So in this case, I know exactly what I want. I'm seeing this sort of diff here of what's actually being changed. And I'm just going to apply this for all suggestions because I've looked through these and this is the exact same thing that I want. I'm going to apply all 4 suggestions for this type on this document. So now that I've done this, you can notice those 4 locations have gone away. And let's actually go and see if that actually worked. So look, you can see here that F to C helper method is being called, and it's using the variable that is relevant for this context, so F total. Let's go one more down and see if we can see this in any other places. We can see this happening here as well. So this calls to this F2C with ftemtim. And as you can tell, this has saved me so much time and also made it so that I'm not, making any errors in the process. So given that we are sort of out of time today, I really wanted to be able to show you Web Live Preview. I also, let's just see if there's a way, if this is unfrozen. It's still frozen, so I'm not able to show this nesting, but hopefully, reach out to me. I can definitely make sure that, we can show this in the future. Just having a bit of a, running a little behind from the previous session and not having enough time today to actually get through it. But as I mentioned, try out Visual Studio 2019. Let me go back to my PowerPoint and I can actually show you just some of the things that are coming up. So as you can see, what's coming up next is you'll sort of learn more about our AI assisted productivity and some of the more future sessions. Also, since I'm the PM for IntelliCode, you can check out my other videos. There was a really cool toolbox session that I did pretty recently around team completions that has gone GA for 16.8. You can actually try it out today and also read our blog post as well as our release notes for all of the information to the documentation of how to actually use this. We're also going to hear from people coming up around .NET productivity. I think Mika is going on next, and she'll be sharing with you all the cool things that you can do in .NET. And hopefully she'll have some time to actually show you team completions in action if she does. And then there's some other, cool sessions this week that will really help you see all the other cool things that are happening in Visual Studio. So for instance, our Git workflows and the ability to use GitHub Actions directly from Visual Studio. So thank you for joining, and I've really enjoyed this session. Pardon having any of the issues with technology. Sometimes, your Visual Studio instance might freeze, and that sort of puts a damper on things. But we made it through, and I'm hopefully you've learned something new today. And please let me know if there's on Twitter if there's anything that you'd love for me to provide a quick sort of demo of or video of, and I can provide that too.
All right, Katie, that was awesome. So much good stuff. There were a bunch of questions asked about the templates, so many in fact that I think we're going to do a Visual Studio Toolbox episode on it, or maybe a couple episodes on it. So you guys with questions, make sure to look for that coming up soon. And Katie, maybe you can go pop over on Twitter and see some of the questions and answer them directly.
Okay, cool. Yeah. Was there any specific one that I could just answer very quickly?
No, I think we're going to move on to Mika and Kendra at this point. So, but thanks so much for that.
Yeah, thanks.
So we're going to move on now to Mika Dumont and Kendra Havens, and they're going to talk about improving your productivity with Roslyn analyzers. Hi, guys.
Hi.
That is not easy to say quickly. Roslyn analyzers.
It's a tongue twister.
Yeah.
How are you?
So good. How are you?
Excellent. Thanks. Take it away.
Yeah, okay, let's go ahead and get started. I have some slides. I think they might be shared. So yeah, this is improving the Roslyn analyzers. I'm Kendra Havens. I'm a program manager on .NET and Visual Studio. And Mika?
I'm Mika Dumont, and I'm a program manager on .NET and Visual Studio.
Cool. Same thing, same team.
Yeah, seriously.
So Katie just showed this. Wow, what cool improvements. Especially excited about a lot of the stuff that her team IntelliCode is doing. We always want to show the Visual Studio preview. That's what we'll be using today with all of our demos. So check out 16.9 preview to get some of the latest features. There's environments in the cloud, AI assisted productivity, so many cool things. We're going to focus in on the Roslyn analyzers. So we're just going to give an overview of what's new, go through some of the latest code fixes and refactorings, go over some of the .NET 5 SDK analyzers specifically, and then Mika's going to show us how to write a Roslyn analyzer. So before we get into it, Mika, what is Roslyn?
Well, Kendra, I thought you would never ask. So Roslyn is the code name for the C# and Visual Basic compiler, where we built an open source API surface so that any developer can write really smart code-focused tools and technologies. And some of these tools and technologies are also known as analyzers. And analyzers is basically a tool that will run analysis on your code as you type, and it will report diagnostics in the editor. And these diagnostics will manifest as squiggles. And so if you're ever in Visual Studio or VS Code and you see those squiggles, those are analyzers running in the background. And analyzers also surface a light bulb or a screwdriver suggestion, also known as a code fix or refactoring. So the best way to understand what an analyzer is to actually see an example of one. So if we switch over to my screen over here, yes. So this is an analyzer. And analyzer has two parts. It has the squiggle letting you know that there's a violation. So that's going to be part of the diagnostic. And then it has the code fix. And so this will fix that violation. If we take a closer look at my error list, you can see that I have these analyzers running in the background. And they're reporting violations in my code. And analyzers also have different types of severities. So we have the error severity, the warning severity, and then the suggestion or the information severity. There's also a fourth severity called hidden or silent, but that won't show up in your editor or in your error list. And I'm going to talk a little bit more about that later on. So using my error list, I can go ahead and navigate to all of these code violations. And so this analyzer is offering me a code fix to simplify this conditional expression. This did start off as a single Boolean, but then it got pretty complicated. So I'm going to go ahead and apply this code fix to simplify this conditional expression. And speaking of simplifying code, we also have this analyzer, and it's offering me a code fix to remove this redundant equality operator. So that's pretty sweet. And hopping over to this one here. So analyzers can also surface a less invasive like UI. And so notice here I have these dots, and these are suggesting me that I can go ahead and fix this up. And so one of the latest code fixes that we added was pretty much simplifying this new expression. And analyzers, as I mentioned earlier, can have the hidden diagnostics. So they won't show up in the editor or the error list, but you will see them as represented by a screwdriver or a light bulb in the margin. So if I invoke the screwdriver over here, I have all these different refactoring options. For instance, I can select extract base class, which we just added. So I can go ahead and select different members from this class, and I can transfer it to a new base class. So that's pretty cool. And we also added another refactoring. So this one is inline method. So if I want, I can go ahead and replace usages of a static, instance, and extension method within a single statement body. And I have an option here where I can either keep or remove the original method declaration. So that one's pretty cool. So Roslyn doesn't only provide code fixes and refactorings. Here's a little more on how it hooks into tooling. So notice all of these XML comments I have over here. See, lots of them. These now have style support. So Quick Info will now display a clickable link, bullets, and italics. And we also have the inherit doc tag to inherit XML comments from base classes, interfaces, and similar methods. So let's say I want to add that tag over here. I can go ahead and add it. And so now if I hover over this class, it will now inherit those XML comments, keeping my XML comments in sync without having to copy and paste duplicate XML comments. So I don't know if you noticed in my solution, I have all of these adornments. These are inline parameter name hints. So these are built into the default tools of Visual Studio. They are off by default, so you will need to turn them on in Tools Options. And you would just select these. And in 16.9 Preview 1, we added a bunch of customization options here. And we also added inline type hints for variables with inferred types and for Lambda parameter types. And let's say the UI is a bit too distracting for you. You can go ahead and deselect those options, but you can keep the displays all hints while pressing Alt-F option on. And so what that will do is it will just make these name hints magically appear when you press Alt-F1. Ooh, ooh-wee. So I like to have them on because I find them extremely helpful. So I'm going to turn those back on. And this was built actually by one of our very own interns this past summer using the power of Roslyn. And a lot of these code fixes and refactorings that I actually just demoed are built by the community. We get tons of contributions. Kendra, how many PRs did we get in the last sprint?
We got 89 community PRs in the last sprint.
It's wild.
Yeah.
So it's pretty cool. So anyways, if you're still not impressed by Roslyn and all the smarts that it provides in the editor, Roslyn also powers IntelliSense completion. So a lot of people were really big fans of regex completion. I can go ahead and open IntelliSense by typing Control Space. And here I have my different completion options and an explanation of what each of these regex characters mean. And so since people love that, we added that for date time strings and time span literals. And what I really love about this is that it gives you examples. So it's just a really nice inline experience without having to go on the interweb and learn how to write date time format and so on. So that was a quick overview of Roslyn and how it powers our productivity tools. And now Kendra is going to talk about Roslyn analyzers in the .NET 5 SDK.
Yeah, so if we switch to my screen, I've got a couple new things to show. So in .NET 5, we are including an entirely new set of analyzers that you haven't seen before. We've actually kind of been holding these back for a few years because they might appear and have new warnings in existing code. So we didn't want, for everyone who had warnings set as errors, we didn't want to cause source breaking changes and stuff. Let me show you a few of these and then talk about how we set it up so that we can avoid any upcoming issues with extra warnings appearing in pre-existing code. So this one is warning when an expression is always true or false. It's comparing a date time, which is a struct, and checking if it's null, which is actually always going to be false. So the recommendation is to either delete this line or actually intentionally pass in date time as a knowable object. So now you get a warning for it. The next one, probably super concerning. When you're allocating a stack inside of a for loop, that's not best practice. We always want that to be outside of it. So you're now getting a warning anytime that occurs. And our recommendation is to just pop that out of the for loop, and then the warning will disappear. So this next one, you want a read-only span of characters, and you're getting it from a string, and you're accessing what substring you want using range-based indexers. So that is actually creating extra data copies in the background. So what you want, and we have a code fix for this, is as span in between there. So that will be a more efficient way to access that string and avoid extra memory usage. The next one is, so this is super common, especially for students. When you catch an exception, you have a variable name, and when you catch a ball, you throw it back. But you expect you need to throw that same variable name. You actually don't need to, and if you do, you're actually erasing some of your stack detail information. So we have a code fix to just throw. Don't include the variable name. And then you can clean it up a little more, take out the unused variable and just catch the exception type. So as you might realize, a lot of these occur in code that already exists. And we don't want to cause extra warnings when people aren't ready to kind of deal with them and make those code quality improvements. We want it to be there when you're ready for it and when you want to work on that. So what we've introduced is analysis levels. So by default, all of the .NET 5 SDK analyzers appear in your .NET 5 project, but you can adjust the analysis level. So analysis level 5 correlates with .NET 5. If I bumped it down to 4, it would correlate with .NET Core 3.1. And here's a little bit of what that looks like. So another benefit with kind of decoupling what analyzers you can get with what SDK and making that independent of what your project is actually targeting is you can have a project that's targeting .NET Core App 3.1, but still get analyzers from the very latest ones from .NET 5 SDK. So you could set analysis level 5 in a .NET Core App 3.1. Pretty cool. And in that same theme, we're always adjusting how often you see certain analyzers. So all of these are also, all of these SDK analyzers are also configurable with editor config. So as Mika showed, you can set different severities. So right now it's a warning. And if I go over to my editor config and put in, hey, how about I just want that to be a suggestion? So instead of a green squiggle, when I go back here, it switched to those 3 dots. So you can put this silent, you can even bump it up to an error. It's a lot of configuration. So that's .NET 5 analyzers. Yeah, in Visual Studio 16.9 Preview 1.
Woo woo!
Yeah, pretty cool. So Mika, do we have enough time? Do we need to speed through a Roslyn analyzer template building kind of thing?
Yes, let's do it. Okay, so hopefully we'll have time to just run through how to create a Roslyn analyzer. Today, if you want to write an analyzer, you do need to use the syntax tree API, which basically has 2 components to it. It has the syntax tree, which is a high representation of your code. This includes all your comments, your white space, and line trivia. And then we have the semantic model, which basically contains any information related to the meaning of your program and the symbolic information that you need. So the way that these 2 components interact are through a question-answer model. So from the syntax tree, let's say you have an array and you want to figure out what type the array is. You ask the semantic model, and the semantic model will return an answer to you. Okay, so what we're going to build today. So we're going to create an analyzer that identifies missing braces in a statement that is not enclosed in a block that has curly braces. And then we're going to create a code fix that suggests you add braces. So switching over here, the very first thing that you will need is the Visual Studio. Okay, so the first thing you need is the .NET Compiler Platform SDK. So you can do that through the Visual Studio installer by selecting Modify, waiting that to load. And if you scroll down, you can just select this Visual Studio Extension Development Workload. And I can go ahead and just expand this, and there is my .NET Compiler Platform SDK. So we got that already installed. Next, you want to launch Visual Studio. And we were really nice, and we created this template for you. So you can go ahead and use that. And I think the template, it has a default boilerplate for an analyzer and a code fix that makes all types uppercase.
Very useful code fix. Just capitalize everything. Have all your types yelling at you.
Very useful. All right. And I think we got it. And so then I'm going to create a new project. And to get to that template, I just like to filter it. So I'll just type out analyzer to get to it quickly. And we have 2 options. We have Analyze with Code Fix for C# and one for Visual Basic. I'm going to choose the C# version. And I'm actually going to X out of this because I already have one open. All right, so this is pretty much the boilerplate. This is the template. It has 5 projects, which you can see in the Solution Explorer. And the only code I've added to this so far is really just these few lines here. This is all part of that boilerplate analyzer that makes your letters capitalized. So the most important part is to write the diagnostic, and you would do that in the Brace Analyzer file. And so this file contains the analyzer implementation that reports a diagnostic. And the only thing that really matters is this initialize method down here. And basically up here, the title, the message, and the description is for your analyzer. And I already went ahead and updated that. And I added .NET Conf 2020, so we could test it and make sure it's working. And we know it's working. So yeah. And then another thing and then we have the diagnostic descriptor rule, which is where we define what our rule is. So the rule is where you have the diagnostic severity, which you can see over here. And that's where you just determine how you want this to manifest in the editor. So those are like the red squiggles, the green squiggles, the little dots. And it's also for the error list too, like how you would see that too. So I'm going to keep it as a warning. And then I'm going to scroll back over here. And so that's that. So I already have code ready to go just because we don't have too much time here. So let me quickly add that. And then I think I'm missing a brace. Okay. So pretty much what the initialize does is it gives you a context, which is all the information you can access at this point. And what you're going to do is register a callback in this function. So when the compiler hits a certain node or a token, you can specify it's going to call that callback. And if you want to explore, I don't have too much time to just go over the syntax visualizer here. This will help you explore the syntax tree a bit more, which will help you create this initialize method. And then let's move on real quick to writing the code fix. So this code fix will add the missing braces. And the code fix takes in the diagnostic ID, which you can see here. And so this is the same ID that we created for our analyzer, and it will give that ID to the compiler. And so that's already hooked up by default. So we didn't even have to really do much there. And then we're going to just, again, really just update a few lines of code here. So taking a look here, I'm going to clean this up. So I'll just go ahead and add this here. And so this register code fix async, this is where we're registering our code fix. And then the add brace async is where we invoke the fix to add the braces. So I truly updated, I don't know, under 20 lines of code in only 2 files. Now we are ready to test this analyzer. And so before we do, make sure the startup project is the Brace Analyzer v6. And then you're going to go ahead and just press F5. And so what it's doing when you press F5, it will open an instance of Visual Studio that already has my analyzer installed in it.
So you're launching Visual Studio from Visual Studio?
Yes.
Yeah. Whoa.
It's cool. Crazy. Yeah, it's really cool. And it's the best way to test that if your analyzer works. So I already created a console app over here. And then we can just wait for it to load. And as this loads, if we see a squiggle in there, that means the analyzer works. And then if you see the light bulb and the code fix, we're doing great. So let's wait for that. Okay. So loading.
Yeah, it's just gotta run the initial analysis. Oh, hey.
Ooh, okay. And you see that this shows you, it's from .NET Conf 2020. So this is our analyzer working. And then we also have the code fix to add the brace. Woo! And that's the tea. So that was an overview of the analyzer and the code fix. It was really simple, like really just adding under 20 lines of code into 2 files. And it's really not too complicated to write these things. And you can even, as a next step, build your entire solution, create a NuGet package, and you can just publish that to NuGet so anyone on your team can then use your analyzer that you just created. And yeah, so so hopefully you can go out there. Thanks for joining. Hopefully you can go out there today. Use Roslyn analyzers, try to build some cool analyzers with the syntax tree API, give us feedback. You can also follow us on Twitter and ask the team questions on analyzers and let us know about the awesome analyzers you're building and just spread the Roslyn coolness.
I like it. We'll see you in the open source.
Oh my God, that was so cool. That was so cool. I think we have time for a couple of questions.
Excellent.
So the first one is from Jim Woolley. Has questions about updating analyzers to .NET 5 and using C# 9 records.
I think we know our default templates for Roslyn analyzers don't yet work with .NET 5. I actually think we were debating if they still required a .NET framework dependency, and we had it checked up on that. Did I follow up with Sam on that? I'm not sure. I think we're not too let's see, motivated on that right now, but that's probably a good issue to open on our repo that we could possibly move or encourage or change the template formats to use some of the latest features. And we'd probably get a lot of performance benefits out of it. So we'll have to look at it.
Cool. Nathan wants to know what refactorings and analyzers are available for VB, because we've seen a lot of C# today.
So a lot of them actually work for VB unless they are language specific. So a lot of these that I showed are going to work for Visual Basic as well.
All right, awesome. Thanks, guys, so much for that. I think we're going to move along here. I'm done with my part of the show. Thanks for having me. Good to see everybody. And I'm now going to turn it over to Myra Wenzel. We are having audio issues with Myra at the moment. Okay, well, in the meantime, while we wait for Myra to come back on, don't forget to ask your questions with the hashtag .NETConf. We've had a number of great questions, and if you ask a question and we read it on the show, then there's a prize. We have a lot more questions than we could possibly ask, but good ones are coming in. You can also subscribe to notifications to keep up with the .NET Conf news. Our next session is HTTP API development with .NET, Azure, and Open API, also known as Paper Cuts Be Gone, with my good friend Brady Gaster. So that's coming up. Brady.
Hey, how's it going, man?
Great to see you. How are you?
Long time no see.
I know. I'm doing fantastic. Thanks.
Cool. Well, I'm excited to talk to you today. Hope we can get Myra's audio back on, but I'll just get started whenever you let me know.
In the meantime, yours is on, so we're good.
It's good.
All right. Tell us about API development.
Thanks a lot. I'm Brady Gaster. I am a PM on the .NET team. I like to concentrate on all things real time with SignalR and APIs, REST APIs, HTTP APIs, pick your terminology, it's fine with me. As you saw in the keynote, I'm pretty excited to talk to you today about the concept of using OpenAPI or Swagger, if you know what is Swagger, and I'll use the terms interchangeably in your Web API projects. I've been doing this for quite some time, and the updates that we're making right now are pretty exciting to me. I've been really passionate about it for a while. I'm going to go ahead and move on to the next slide here. So like we talked about in the keynote, OpenAPI is on by default in your ASP.NET Web API projects in .NET 5. We hope to backport that to 3.1 at some point. I don't really have a ETA at this time, but if you do a brand new project with a brand new Web API project in .NET 5, you'll get OpenAPI by default unless you opt out of it. So we're going to talk about how we did that today as well. A couple components there. The first one is we partnered with the awesome team over at Swashbuckle. We've worked with them for quite some time. They put out a great NuGet package, or a series of NuGet packages that enable you to do OpenAPI generation directly from your Web API controllers. They also have a CLI, so if you wanted to build your OpenAPI or Swagger file at build time, you could do that. We actually do that in some publishing stuff that I'll show you later on. We also do a lot of stuff with NSwag as well, such as the client generation stuff inside of Visual Studio. And I'm excited to say Visual Studio for Mac also has the client generation stuff now as well. We'll talk about that a little bit later. But I really just want to go ahead and dive right in. And around all that stuff, we've also updated the HTTP REPL for .NET 5, so it supports all the new stuff that we've done, such as changing your default start page from root to /Swagger. So without further ado, let's go ahead and dive right in with a quick demo. So I've got Visual Studio open right here in a VM. It's actually that machine right over there. And one of the things that we started doing on the team right around the time COVID hit was we started training around a lot of recipes. I know that Barry and Glenn have had quite a few conversations about, whose bread recipe is better. So I started thinking, well, let's build an API and a Power App so that we actually share our recipes and, put this to rest. Get it? Rest? Like REST APIs? Sorry, dad joke. Sorry. Anyway, let's go back into the code. So here you'll see that I have the startup CS. And one thing that I'll do is I'll scroll down and you'll see that I've got a couple of extension methods that I'm using, such as this one right here. I'll be using David Pine's Cosmos DB wrapper here to do generic repositories. That's just his little handy helper method to dial it in. This handy helper method right here, add Swagger Gen, that is actually part of the Swashbuckle service light up. So when you do add Swagger Gen, you just pass it a config object, and then I can say c.swagger. And I can provide the name or the version of my stuff if I want to. And we'll see here that we've got OpenAPI info. That's actually a class that represents the metadata of any OpenAPI document. It comes out of a NuGet package written internally by an awesome friend of mine named Daryl Miller. Thank you, buddy. Called Microsoft.OpenAPI. So that is actually one of the packages that a lot of the different REST API and OpenAPI things that Microsoft use, as well as a couple of different open source projects. One thing I'll show you right here. Now, this comes out of Swashbuckle, so that comes from the great Swashbuckle crew. This is an extension method that I've added right over here in my infrastructure folder. Now, this code is going to be out on GitHub. After this talk, Isaac Levin's going to rub some CI/CD on it for us and deploy it automatically whenever I do a commit. Right here, I'll just do a peek definition, and I'll show you how I discovered the awesomeness of Swagger long, long ago. Is that I wanted to document my web APIs. That's all I wanted to do, and that's how I met up with the Swashbuckle team. Was they have this fantastic ability for me to actually take / comments and decorate not only my web API methods, but if I had models and I actually decorated those models with / comments as well, all of that stuff will be surfaced up inside of the OpenAPI document and inside of the Swagger UI test page, so that folks who discover that Swagger UI test page or that I give it to and want to see documentation about how to use my API, it just surfaces right up. You can actually put all your / comments directly in your C# code, and you can use a handy method like this. This is actually in our docs.ms.com on the Swashbuckle doc for Web API, but you can see here that all I'm doing is I'm getting in all those XML comments at build time, and I'm going to put those into my OpenAPI document. Now that's how I enlist all of the Swashbuckle services, and you don't need to worry about it because we do all of this for you in the template. We didn't just give you a NuGet package reference with no idea how to use it. We went ahead and did the right thing for you too, because we heard from some customers, even myself, who've used the package for years. Sometimes I forget how to do a method here. Sometimes I forget how to wire this up. Please do it for me. So we just wanted to make that as easy as possible for everybody. Now, if I scroll down here to configure, and I want to point out where we're doing this, you'll see here inside of the is development. So we're only lighting up the Swagger document generation and the Swagger UI if I'm in development mode. We have a lot of customers who don't mind having that turned on in production. I personally like to turn it off so that, you know, I can only enable discovery when I'm in development. If I'm working with somebody in another team, they can like try my API out. Once I'm outside of development or I'm outside of my dev zone, I usually turn that off just because I don't want to have accidental discovery. If I need that file, I've got it somewhere that I can actually use it, or I could just do it from my ID. But the point is here is that this app.useSwagger, again, this is also going to be in the template inside of the is development block. All that does is that specifies how I want to generate that OpenAPI document. Now, they recently added support to generate not only in JSON format, but in YAML format too. And you'll see here that I'm doing serializes v2, which is kind of the lowest common denominator in terms of my OpenAPI document. This is essentially going to be Swagger 2.0 JSON document. Okay, so that's really your lowest common denominator. Most folks have migrated to supporting OpenAPI. A lot of folks have migrated to supporting OpenAPI v3 with YAML as well. But for those who haven't, I just want to do v2 just to make sure we cast a wide net, if you will. And then the other thing that I do is I turn on the Swagger UI, which we looked at briefly in the keynote. And if you were to look in the properties and launch settings JSON, you'll see that the Swagger URL is actually hard-coded as the default URL. So at this point, that's kind of the walkthrough as to how you would basically dial in Swashbuckle, which we already do for you in the template. One thing I do want to call out here is over in the controllers that we have, one thing you'll notice is that whenever I use HTTP GET or POST or any of these, I specifically use the name property to name my method. And what that does is there's a property inside of your OpenAPI JSON file called operation ID. And things like nswag that generate clients, which we actually use inside of Visual Studio and Visual Studio for Mac, and internal projects like Autorest, they actually use that operation ID to generate client names. And as you'll see in a little while, so does Power Platform. So I want to stress that if you're doing these, if you're into OpenAPI and you want to make sure that your OpenAPI document can well be ingested by any multitude of OpenAPI tooling, I would encourage you to use this name property, kind of how I've done in this code here. So I just want to point that out. When you use name, you get the operation ID. Operation ID is a good thing, and it will spare you a lot of nightmares and headaches. So I'll just summarize it that way. So at this point, I'm ready to go. I've got my API all wired up, and I'm going to make sure that I've got my web browser set to Edge. Talk about that next. And right here, I'm just going to go ahead and hit F5, and we're going to spin up this API. I'm just using Kestrel here because I usually dev on a Mac, so I tend to take out the IIS stuff just so I'm running the same way in each environment. But you'll see here that now I've got my Swagger UI page. You'll see that it's basically drawn out all the different endpoints for all of my individual Web API controller operations. And then if you look here, you'll see that I've got get all the ingredients, create a new ingredient, and same thing down here for recipes. So I've taken those / comments and I've fed those directly into the OpenAPI JSON, which is then surfaced up directly into the Swagger UI test page. And now I can just kind of try the API out. Why do we do this? Well, in the old days, if you were building a Web API project, whenever you hit F5, you might remember that you would just get a blank page. That wasn't a great experience. So we improved it recently, and the way we improved it was when you hit F5, you just go right to the GET request of that API, and you just see a payload of JSON. If you're like me, you have JSON formatter extensions installed, but for a lot of folks who didn't, it was just a blob of unformatted JSON. I think you're going to like this experience a lot better when it comes to debugging your API. So what I'll do here is I'll hit execute, and this is literally just going to come back to localhost. Localhost is going to reach out and make a call out to my Cosmos DB. If I scroll down here to my get response, you'll see that I've got all of this stuff right here inside of basically all my different recipes that I've got. And if I were to scroll, you can see that I've got a 200. I can literally see all the different HTTP response codes that I need. Now, for posting, it's always been interesting because you'd have to like fire up a third-party tool or something like that. It's never easy to like get your bearer token and jack it into your request. So what we've done with the Swagger UI page is we've made it easy for you to be able to do posts. So what I'll do here is I'll find my create recipe method, and I'll just put a breakpoint right here, and I'll flip back over, and at this point I'll expand post, and then I'll scroll down and I'll try it out. And what I'll do here is I want to create a new type of bread. Think if I've got a lot of breads in there already, I can't think of anything else. We'll go with walnut bread. I think there's walnut bread out there probably. If there's not, Barry should probably invent that. Go ahead and hit execute. Now we're developed. So you can see that I can look at that request, and we can see the payload coming over. There's my walnut bread payload request. I'll just hit continue, flip back over to my Swagger UI, and scroll down. And now you can see right here that I've got my walnut bread created. Okay, so I'm going to do something really quickly. I'm going to copy this ID because we're going to use that here in a minute. So copy that. And now what I'm going to do is I'm going to close down this browser, and I'm going to flip over real quick to this page. So just before the session, I had a request. Please show us how to dial in the ACTP REPL as a debugging tool, because we've shown it a lot. And there is a blog post out there. I don't have that pulled up. Literally right before I went on stage, I had a Twitter request. So I apologize. Reach back out to me, and I'll give you that dev blog URL in a minute. But the great PM, Angelos, wrote that, the guy who created all this, who drove a lot of these different tools that you're seeing here with me. He actually wrote a great blog post on devblogs, Microsoft.com/ASP.NET. It's kind of all one, but you go back, you'll see that he walks through how to get it set up in VS Code, in VS for Mac, and in Visual Studio. The first step is you'd have to go out to NuGet and do a search for ACTP REPL. There's two. You want to get this one, Microsoft.NET HTTP REPL. You'll see that that's the latest version, is the 5.0 preview. And if you want to grab it, all you would do is copy that, and you would run it from the command line, and it's going to drop it into the folder where all of your other .NET tools get dropped. That folder is different for each person, or not each person. It depends on your profile. So what I want to point out here, I've seen it different on my machine a few times. The way you would do that is I'll go right here, and I'll show you how we've got the browse with. And you'll see that I've actually already done it here. I've already got the REPL here. But what you would do is you would say browse with. It's going to fire it up for me. Now it's going to ask me this, and you'll see here that's the .NET REPL, and this is where it happens to be. You'll see here that on my Windows drive, it's C users, .ag, the .NET, and then tools, and then ACTP REPL.exe. So you would literally just hit add right here, and you would find that tool on your path. You don't need any arguments, leave the arguments blank, and then you would give it a friendly name. I call mine .NET HTTP REPL. And what that does is that gives me the opportunity to be able to set, that's running, so let me kill that. What that gives me the opportunity to do right here is to set the REPL as my browser, so that whenever I actually go in and I hit F5 right here, the REPL is going to pop open for me. There we go. So that's popped open, and you'll see that it went ahead immediately and interrogated my endpoint and found that OpenAPI file, went ahead and ingested that OpenAPI file, and now it knows what to do. So what I'll do here is I'll do ls, or I can do a dir, uses either set of commands, and I'll do a clear screen here, and I'll once again do ls, and this time I'll do cd, I'm just going to type that and then hit tab, so I'll point that out, and now you can see that I'm inside recipes. And I want to see all the different calls that I can make with recipes, so I'll do ls here. I can do a couple different things. Now remember that ID that I copied before? So right here, I would literally just say, paste in, oh, darn it, copied the wrong thing. Oh, sorry. Lost about a minute. All right, let me do an ls again. So what I'll do now is I'll cd into search, and you can kind of imagine you're traversing the endpoint here. So now it's recipes/search. And if I do an s and ls here, and I got this, now I can literally say something like banana, and it will go out and do a search for anything that has the word banana in it. You can see there. There we go. If I were to do get rye, I could do that. So now if I wanted to, I could literally go into here. I could copy that. I can cd back. And this is kind of neat. I can literally cd then I could do a get. I just want to show you have that capability. You have a lot of different capability inside the REPL. I like it because it kind of helps me with API design. If I can kind of navigate it through the REPL, people can probably figure the API out because it's more like a directory structure, and that seems pretty logical for folks. So I just want to stress that to folks and show you how to use the REPL departing and stuff. We've also got great help in there. So if you wanted to change anything, you can actually take a look at the help. If I wanted to do a post here, let me just point this out. Right here, I'll just go into recipes, and I'll just do a clear screen one more time. And at this point, I would just type the word post, and watch what happens. It's actually going to open up VS Code. Now, I have configured VS Code as my editor. You can do that using your prefs here, but if I wanted to do something here, I could do peanut butter bread. I'll do that, and then once I close VS Code, you'll see that it actually made that request, and we're good to go. So right here, go ahead and exit. And I'm going to close this down as well and go back over to our PowerPoint because we want to keep on rolling. So we didn't stop at the ability for you to very easily get started with an Open API decorated Web API project. We wanted to make it easy for you to take that Open API Web API project and integrate it across Azure, across third parties, and with things like Power Platform. We already have great features inside of Visual Studio that enable you to generate strongly typed C# clients that we use some open source products for as well, like NSWAG and RS and stuff. We're going to be improving upon those things, and again, we just added those to VS for Mac as well. But one thing that I wanted to kind of show you how to do is that you can right-click publish your API now that you've got Open API enabled by default. You can publish this out to something like Azure App Service. And we've added an additional step directly inside of the publish flow so that you can actually import your API directly into API management. We did this so you don't have to go fumbling with the URL or worry about anything. We generate the Swagger file for you at build time, and then we just push it up in the API management and light up a new API. So with that said, let me show you how we're going to build a quick little application using this publish feature and the Power Platform. So now I'll right-click on my project here. And I'll just do a right-click publish. And again, I know friends don't let friends right-click publish to anything other than their personal development environment. So after this session, stick around because Isaac Levin is going to come on and show you how to take everything that I'm doing here in this exact same code base and do it all with CI/CD and GitHub Actions. So what I'll do first is I'm going to go ahead and create a new publish profile. And I'm going to go ahead and select my target as App Service on Windows since it supports .NET 5 out of the gate right now. I'll go ahead and select it here. I'll click Next. And now you'll see that I have this API instance, or this API management instance right here. How does it know to do that? Because I've got swashbuckle.ASP.NET Core as a NuGet package in this project. So you can do this today with existing Web API projects just by enlisting in Swashbuckle. You can get this for free. So I've already got an API created, so I'll just go here and click Next. This is where Isaac will take over next. I'll click Finish, and got everything ready to go. At this point, I think everything is configured. I'm not sure what this is barking about, but what I can do is just make sure that my stuff here looks like it's okay. I've got that there, I've got that there. I'll just go and do a publish. So now what's going to happen is we're going to package up the code. We're going to publish it up to Azure App Service on Windows. Once it's published up into Azure App Service on Windows, I'm going to use the Swashbuckle CLI. We just do this inside of the build for you right away. We use the Swashbuckle CLI, and we build the Open API file, and then we push that Open API file right up into Azure API Management. So that you can do crazy things with it, like integrate it with Logic Apps, integrate it with Power Apps. You can use Azure API Management to actually control access to customers. We know a lot of customers who build APIs, and their API is their business. So in a lot of cases, you want to control access and monitor how people are actually using those APIs. So you can see since I've got the HTTP REPL open, it went ahead and used that to do the browse. It's already opened this up. You can see behind it, the website has been restarted. The Swagger file has been generated and pushed up into Azure API Management for me. And now I can go over to my Azure portal, and I'll show you that this is my API Management instance that we just published into. And if I go right here over to APIs, there's my recipe API. Now you can see that we've already ingested all of these individual operations that I could perform. And if I were to click on settings, you'll see right here that that's my Azure Websites.net domain. and it knows that my Azure Websites .NET only accepts HTTPS because that's a good idea. So it's gone ahead and we've already configured this to be HTTPS. I've got this subscription required box disabled because it's just my personal development environment, and I just kind of want to make sure that things are working before I go ahead and lock everything down using API management's built-in API key security. But if I wanted to, I could go ahead and test it just by going here to get all recipes and just give this a quick fire. And it takes a second for that first call, but now you can see that we're actually doing that request back to our Azure app service, and we're getting the stuff back. That's great. So how hard is it to get this into Power Platform? Not hard at all. The awesome folks over in the API management team have worked closely with the awesome folks in the Power Platform team, and they've given us this great ability. So what I just did here was go right-click Export. I can select Power Apps and Power Automate. That's the environment into which I want to publish. So I'll go ahead and click Export. And while that's exporting, one thing that I do want to point out right here is in my PowerPoint deck, I want to scroll one step. And we talked earlier about generating OpenAPI clients. That's done through the magic of this thing inside of Visual Studio for Windows and for Mac called Connected Services Experience. You can right-click on Connected Services and say, I want to create a new connected service. You can select gRPC or OpenAPI. And then you basically give it that OpenAPI file, and it will generate a strongly typed C# client for you directly into your project, either on Windows or on Mac. It's pretty handy. So at this point, I'm going to go back to my portal and find my portal. My apologies. So that's been exported. Yep, we've been exported. Now if I go over here to Power Apps, I just do a quick refresh. Now this is what's called a Power Apps custom connector. That is the idea of a connection back to my API. There's a lot of different built-in connectors like the Google Maps connector or the Office connector or the Cosmos DB connector or the Secret connector. There's a million of them. They're already in the box. But if there's one that you need to build to wrap around your API to enable your citizen developer colleagues to be able to like talk to your backends that you've already built, you would do that with a custom connector. So right here, I'm going to go in and remember how I turned off authentication? Well, I want to make sure that I turn that off in here as well. It kind of comes over by default as the API key. So I'm just going to turn that off, and I'm going to update that connector. And once that's finished updating, I can actually use that connector inside of an app. Luckily, I've already written an app because we're almost out of time and want to take some of your questions. So once this connector is saved, there we go. No authentication, got everything turned off. Let me move my Mac bar there. Sorry about that. I can go over here to apps, and you'll see right here that I have this app. I'm going to right click it and say edit. And it might say, I see that you've already got a recipe API connection in here. It might ask me to authenticate myself. It's going to just use see that I'm already logged into this tenant using my AED creds. There we go. Sign in. It's going to give me authentication because I already did it. I'll click allow. And the only reason I did this, I didn't want to go through all the code. Now, to create this UI, all I had to do was drag in buttons and put text boxes on the form. If you've never done anything with Power Apps and you don't like getting into the nitty-gritty of native dev, nothing against native dev, it's awesome. You guys are fantastic. But if you just need to burn out an app that's going to be used by people within your organization, Power Platform is a really great way to just kind of get started on stuff and continue on. So you'll see here that I've clicked on this Show Me All Recipes button. And I go up here to this bar, and I'm going to zoom in on it. So what I'm going to do is I'm going to show you that I've got this variable called the Recipes Collection. What's going to happen is this clear collect is a built-in method inside the Power Platform. It's going to literally clear that collection out, and then it's going to call the recipe API.getRecipes method, my API method, and then it's going to navigate over to the next page. And if I were to zoom out here, you'll see that if I click on this button, it's almost the same thing. I'm going to clear that collection, the recipe API.search recipes by name, and then I just give it the text value of this text box, and then we navigate to the next page. It should just work. So if I go over here and I just click the F5 button, if you will, to run my Power App, now I'll say Show Me All Recipes. There we go. It's actually showing you all the recipes. Looks like a champ. I didn't even have to really write a whole bunch of code. I want to go back. I want to bring up one thing. Would be great. You probably thought this before, but wouldn't it be great if I'm working on the back end of this, and my buddy Pierce or somebody else is working on the UI of it, and they say, hey, I'm making some changes to the UI, or in this case, like I'm noticing that it's not sorting by, it's not sorting alphabetically, and that would be a lot more user-friendly. And I'm thinking, well, it'd be great if I could put a breakpoint on my code and actually have you try it out. So what I want to do is I'm going to show you something that we're thinking of building in the future, and it's just sort of a It's not really any product truth to it yet, but what we're thinking of doing is giving you the ability so that whenever you make a code change right here, we know that you're already wired up to something like API management. We know that you're already using something awesome like, I don't know, live share. So what if we could use the live share tech to basically enable a localhost tunnel back to me? So that all I would have to do would be to hit F5, debug my app. Then I could ping my buddy Pierce and say, "Hey, my app is running. Go ahead and try out the UI. I'll see if everything is still working." And he could go over here and hit show me all the recipes, and then I could look right here, and I could see it come in, and then I could say, "Looks good, looks good." I'll hit continue. What do you see? And Pierce sees what he wanted to see. A newly alphabetized list that we worked on together remotely, because that's kind of how we have to work these days. Thanks a lot. I really enjoyed this. Last thing I want to do is just show you one more slide. I want to make sure you have calls to action. It's great for me to just sit here and show you all this stuff. I want you to go try this out. We love this new app model, being able to use OpenAPI and HTTP APIs together with Power Platform and Power Apps. And we think you will too. And I wanted to just invite you to go try all these things out. Try the REPL, try using Swagger UI, try firing up a consumption mode API management instance, which is what we give you for free whenever you try it out. And just try building a Power App with it and tell us what you think. Reach out to me on Twitter. You can see down there in the bottom left-hand corner is my Twitter handle. With that, I think we're out of time, so we'll take some questions. Thanks a lot.
All right. Can folks hear me now? All right, good. Technical issue solved. Okay, so let's go and jump into one question. So from Stephanus, with gRPC having the significant performance increase, do you foresee that becoming the new API standard for browser to backend communication? Or do you think the easy setup and configuration that ASP.NET Web API brings will keep it as preferred?
That's a really, really good question. I hate to give you kind of an obtuse answer, but I kind of hope both happen. I think that we've made it really, really easy for folks in the .NET community to get started with gRPC, both from a server-side and a client-side perspective. But gRPC requires some things on the network. HTTP 3, 2, I'm not sure. That Web API doesn't require. So there are scenarios where your client might not have that, or you might not have the capability to do that on your server side. And in those cases, it's really great to have something like a Web API in front or SignalR in front. But I will say this. I've also seen architectures where you will have a Web API in front, and that might be the front door of your ingress. So I might have a Kubernetes cluster, and inside of my Kubernetes cluster, I'm running gRPC through all those services. And I might want to have a front door on it that's HTTP1, so that I have kind of a ubiquitous front door, whereas the gRPC stuff is more internal. I do think we're going to see more adoption of gRPC, and I hope that we see more tooling and more capability and more availability creep out there. Looking at you, App Service Team, we want to get there one day. But I wouldn't say that it's either or. I would say use both. Just figure out when to use each one.
Awesome. It was a great presentation, Brady. Thank you so much. And as you hinted, we're going to have Isaac Levin next to speak about deploying using GitHub Actions. So powering up your Azure with GitHub Actions. So let's get ready for that.
Hi, Myra.
Hello.
How are you? I'm glad that you got your audio issues figured out, man. That Brady talk was awesome.
Cool. Yeah, it was. And I expect nothing less than.
Shoot. Okay, well, hopefully I can wow some folks here.
Take it away.
Awesome. Thanks, Myra. See you soon. Hi, everybody. How you doing today? My name is Isaac Levin. I'm a senior product marketing manager at Microsoft. I focus on developer tools and tooling in a way to accelerate how we can better innovate on Azure. I love to tell stories. You can find me on GitHub, Twitter, and Twitch talking about all sorts of fun things. So I wanted to just, before we started talking about all the cool things with .NET and Actions and Azure, I wanted to do a little bit of a history lesson, right? So in the beginning, well, not really. How did we get apps to production before that whole CI/CD thing became the thing you had to do or you got shunned off the face of the earth, right? I asked a Twitter question a few days ago, and some of the results I got were pretty fun, right? So first off, everybody used to copy and paste, right? Or if you were fancy, you would FTP, or maybe you'd build some really convoluted solution that would do some scripting and deploying using SSH or what have you, right? Still talking about manual processes. And then tools started to show up that kind of automated, but not really. Does anybody remember cruise control? I remember cruise control. Cruise control was one of the first introductions to DevOps or CI/CD that I saw in my career. And I thought it was really, really interesting how you could do one click to build, publishing, not even having to worry about, things on people's machines and all that sort of terrible, terrible stuff that we have to deal with. And then you had tools like Hudson show up. Hudson, if you don't know, eventually turned into this tool called Jenkins, right? Well, it's not really quite the truth. The open source concepts in Hudson separated, and Jenkins was created from that. And then finally, we start to see these more complete CI/CD tools that are more deeply integrated with your your code repositories, things like Octopus Deploy, and then the artist currently known as Azure DevOps Server, Azure DevOps, Visual Studio Online, Visual Studio Team Services, Team Foundation Server, right? One place where you had all of your code, the things that built your code, and the configuration needed to get your code to your production endpoints. Now we have a new thing. It's called GitHub Action. So a lot of people ask me, Isaac, what exactly is a GitHub Action? You talk about it a lot. Can you please just give me a real quick rundown? Well, GitHub Action is a YAML-powered workflow linked to your Git repositories. Yet another markup language powered. So I know people have some concerns with YAML. I had some concerns with YAML. I like YAML now. Not as much maybe as some other markup languages, but I definitely can work pretty seamlessly in YAML now after spending some time in it. These workflows are actually triggered a handful of different ways. They can be triggered by GitHub webhooks. You can actually schedule them, or you can manually click a run my GitHub action directly from the GitHub UI. When the workflows run, they actually run on what's called a runner, funny enough. So runners come in two forms. You can have GitHub hosted or self-hosted. The GitHub hosted ones are awesome because they come in a slew of different operating systems, so Windows, Ubuntu, or Mac OS, and they have a ton of pre-installed software, including a handful of versions of the .NET Core SDK, which I think is pretty awesome. Actions, when they run, they generate logs, like basically everything else on the planet. Those logs are available directly in the GitHub portal, so you can actually see the results of your build right there in line with your code, which I think is pretty valuable. And then finally, one of the greatest things that I see from GitHub Actions is that there's a slew of custom workflows that have been built by the community and organizations like the Azure team to come up with every different scenario that you can think of. So then you can use them as building blocks when you build out your workflows for your particular applications. So we're here to talk about .NET, right? We're at .NET Conf. If I started talking about any other programming language, people would blast me on Twitter, and I don't want that. So how do we get our .NET apps wired up with actions? So like I said earlier, there's a GitHub action for that. It's called setup.net. So what does setup.net actually give you? It gives you a .NET CLI environment on your runner. So when you configure it, you have that version that you specify, which you can specify previews. I know we're talking about .NET 5 at .NET Conf. .NET 5 is super awesome. It's GA now. But I know a lot of people here are probably going to be, well, when's my .NET 6 coming out? We know it's coming out next year. And when previews start to flow in, obviously you're going to be able to take advantage of developing with them. And you can use GitHub Actions and the setup.net action workflow to specifically specify that .NET 6 preview all the way through, right? So to give you a little bit of fun things to play with as you're building out to 6. But let's focus on 5 because I think 5 is super awesome. You also have the ability to configure your environment to use private package sources. So for instance, if you have your packages hosted on NuGet or GitHub packages, Azure DevOps Artifacts, you can leverage them in a secure way using GitHub Actions. So we're talking about actions, what they are. We talked about all the different, like the ways that you can set up .NET in your runners. Where can I deploy to? Well, I work for Microsoft. I work in the Azure team, so I'm going to talk about some of the cool ways we can deploy to Azure. Obviously, you can deploy to App Service. App Service is the platform as a service offering that exists in Azure. It's awesome. We're going to talk about that in more detail in a little bit. You can also deploy to Azure Functions, the new fancy Azure Static Web Apps, which now support Blazor and .NET 5. Azure Kubernetes Service, which I'm not going to talk about because I really don't know Kubernetes that well, full stop. And then you can really, deploy anywhere else, right? If you want to deploy to a VM, or if you want to deploy to storage, or if you want to deploy to frankly anywhere, GitHub Actions allows you to be able to do that. So I'm going to go through some of the different scenarios where it makes sense to deploy to some of these different things. So when do we want to deploy to App Service? So when you have a traditional web application with a front end, or if it's an API, Razor Pages, MVC, Web API, server-side Blazor, for instance, it's a good idea to take a look at App Service. If you want scalable production workloads that can be high performance or even dedicated in Azure, App Service is a really good option there. When you want more control over the environment or the being able to configure it, but you don't want the whole VM, you don't want the whole operating system, you can fully take advantage of App Service because it has rich feature sets like slots and VNet support and Azure Active Directory and tons and tons and tons of integrations built into it, which I think is super, super awesome. So I wanted to show you how easy it is to get set up with GitHub Actions and App Service on VS Code. So like Brady hinted, Brady wrote like this really, really, really cool API using Swagger and all this cool stuff. I would love to be able to deploy that out to Azure. I'm inside of Visual Studio Code with the new super .NET theme. I think it's super awesome. Everybody should go and take a look at it. I'm going to zoom in a little bit because it looks a little small for me. But what I want to do is actually want to deploy out. So if I just bring up the command palette in Visual Studio Code, I had this super awesome deploy to Azure, which is an extension to Visual Studio Code, which allows you to configure a CI/CD pipeline there. I click OK. I'm going to go in and I'm going to get my pat. Don't steal my pat. 1 second, everybody. Oh, where'd it go? Sorry, everybody. Too many windows open. Don't steal it, please. I'm going to delete it in 20 minutes anyway. So this is going to analyze your repository, and then it's actually going to ask, what do you want to deploy to? So I choose a simple app service. I choose my subscription. I choose the resource that I want to deploy to, and then it's going to actually build out a template GitHub action. And from that point, like it creates a workflow file. It creates that YAML. So this particular action, like it doesn't really do much, right? Because it's just a template. It can also scaffold out a bunch of different things in here. I'm going to actually take one of the ones that I have already. So, and then I'll walk through exactly what I'm doing a little bit. So I just copy and paste it from a different window to this window. So there is some magic going on here. But, I want to talk really, really quickly what I'm doing. So these are some environment variables that I'm configuring here. As you can see, right, I'm using the new .NET Core 5, or .NET 5, sorry. I'm specifying some paths. The first thing that I do is I say, okay, this is going to run on the latest version of Ubuntu because I do have the ability to run on different runners. I'm going to set up the .NET Core SDK. I'm going to restore my packages. I'm going to build my app. I'm going to publish my app. And then I'm going to use an action that's actually provided by the Azure team called web apps-deploy. This allows you to deploy to App Service. All you need is the name of the app in Azure, the package that you're deploying, which is your built code, and the publishing profile, which you store in a GitHub secret. So GitHub secrets basically allows you to store your secure configuration settings inside the Azure portal, which you can then you can leverage in your workflows. Got a little bit tongue-tied there. But that's just not it. After we deploy the application, there's one thing that we got to do that Brady showed a little bit earlier. So we actually want to set up API management, which we can do inside of the workflow itself as well. So you install a Swashbuckle CLI global tool. I publish the application again, making sure that I'm leveraging the current bits. And then I'm running the Swagger CLI to generate a Swagger JSON file. And then I run some Azure CLI command to actually import into API management that Swagger file. And then once I save this, it gives me the ability to, I'm just going to say, add an action. So when I actually save this and commit it, it's going to kick off that particular runner. And I'm going to show you on a different, show you in a second what that actually looks like. So if I just bring this over, let's just go to 11, my GitHub portal. Let's go to resources, check the time. I got like 10 minutes left. And then you can see that a folder was created called GitHub Workflows. And inside there is that GitHub action that I added. So you can actually see here, I can see all the fun stuff that's going on. So I added an action. This is going to take a little bit of time, so we're going to take a look at it later. But what I wanted to do is I wanted to get back to the deck, right? So obviously I can deploy to app service, but there's tons of other options for you to deploy. What about Azure Functions, right? If you don't know what Azure Functions are, they're these small stateless tasks that you can run inside of Azure, using this serverless hot buzzword, right? You can have stateful functions or observable functions if you want them. So you do have the ability to run, some more complex scenarios if you do. If app infrastructure really doesn't matter for your application, like I said, if you're running some tasks that are moving one things to another or some automation thing, Actions is a great option for you. Actions, lives and dies by this concept of event-driven architecture, where you have things that trigger your application and things that your application is binded to. So, like for instance, non-HTTP things, like if you have blobs being dropped in a Azure storage container and a bunch of other different things. One of the best things about Azure Functions is they can be extremely cost effective. I put an asterisk in there because they can get less not expensive if you take advantage of some more, scalable workloads. Like if you want to use app service environments or you want to use app service plans, it is not cheap all the time, but it's definitely cheap if you have tasks that you're running, based on some of the pricing, right? So if you want to learn how to use Visual Studio to be able to deploy to GitHub Action, it's super, super easy. So I'm going to open my solution here, and I have just a simple Azure function, right? Like there's nothing really like super, this is just a regular Azure function that does a weather forecast. We've all seen this weather forecast demo. I'm going to show you how easy it is in Visual Studio to deploy this to Azure. So I go to publish, and I know what you're thinking, but Isaac, this is a DevOps talk. You're not supposed to right-click publish. I know the DevOps folks would probably get on me, but what if I told you, to quote my friend Abel, we could right-click publish the right way and do the right thing. So I'm going to right-click and publish and click on Azure, Azure Functions in Windows, and then I'm going to specify my particular Azure function. And then I have this cool new thing, publish automatically using GitHub Actions, generates workflow file. But what do you mean, Isaac, generates workflow? Well, what I mean is that it does just that. It generates a workflow file. So if I go in here and take a look, it detects that I'm running a GitHub action, and then it deploys to GitHub Actions. So, what does that actually mean, though? So, like, it's building .NET. It's doing that. Let me just move that over. Sorry. Make Windows open. There we go. There we go. So as you can see here, right, you're specifying a handful of things. You specify the .NET Core version. Azure Functions run on 3.1 of .NET Core right now. I imagine that might change sometime in the future. I don't know any timelines, so don't say I said them. You specify all the different things that you want to run, and then you provide that publishing profile and the package and so forth, right? So I'm going to commit this. I'm going to stage that, add another function. I'm going to commit and stage that. I spelled function wrong. Oh, well. So while that's kicking off, let's get back to the slides. So finally, there's one other really, really cool option, and that option is static web apps. So static web apps allows you to have a front end deployed, or static site, as you will, that allows you to have a full feature-rich environment and that consumes an API. So static web apps is super, super awesome. So when would you use static web apps? When you don't need a server at all. And there's one particular scenario that .NET really, really cares about that I think would be a great option. Blazor WebAssembly. We all know Blazor WebAssembly gets compiled down all the way to JavaScript. So you can take that JavaScript and put it anywhere. Why not on static web apps? One cool thing about static web apps as well is you can actually specify an API to go along with it, and it'll deploy that API out. And I'm going to show you what that looks like in just a second. One of the great things that I love about static web apps is that CI/CD is configured when you build the service in Azure. So what it actually does is it creates a GitHub action for you, puts it into your GitHub repo, and starts deploying your app when you actually specify to create the static web app. And honestly, free SSL certs is super awesome. I don't know if that's going to stay like that forever. So people on the static web app team don't say, hey, Isaac talked about that, and now we got to take it away. Right now, you get free SSL certs. So please take advantage of static web apps if you have value in doing so. So static web apps, let's do this. So here's my repo, right? I'm going to go to the Azure portal. So I'm going to go to add. I'm going to search for static web apps, static web app preview. Zoom in just a little bit. Go to create. I'm going to specify my app name. Let's just call this 11 .NET Conf demo. Sure, why not? Then I'm going to specify my region in Azure. SKU, it's free because right now static web app is in preview and it's free. That's probably likely to change. I'm going to sign into GitHub. It's going to say, do you want this? I said yes. And I'm going to log in. And I didn't get two-factor, which is a blessing. So, and then what it does is it actually reads out your GitHub repositories. So I'm going to choose my personal repository. I'm going to choose the repo itself, which is the .NET Conf demos. And then I'm going to specify the branch, which is main. I'm going to click review and create. When this happens, it actually starts to create, what it does is it creates the service in Azure, and then it actually does a git commit. So if I go here and I refresh my page, so if I go GitHub workflows, you see that there's an Azure Static Web Apps file. So it creates a GitHub static app here, right, to do a deployment. So all that stuff is here, and I can actually view it here. I actually didn't change something. This is probably going to break. So the default setup is that it asks you where you want to put your app, actually, let's just do that again because I failed miserably in doing that demo. So let's go back and try again. I got a few minutes anyway. So I'm going to go in. I'm going to do the same thing. I try to do these demos so fast, and I end up missing like all sorts of fun things. So I'm just going to call this Isaac.NET Conf demo. I'm going to choose a region again, and my printer is going off because that's the world that we live in. My apologies, everybody. I told my wife that I was presenting, and she's like, I don't care, I need to print stuff. So again, same thing again. Sorry that I'm going through this again, folks. All right, .NET Conf demos. Specify the branch. All right. And then if you keep scrolling down, which I didn't do earlier, it gives you these build presets. So you can specify a handful of different frameworks or static site generators. I'm going to choose Blazor. And then I'm going to scroll down, and I'm going to point out where that is. So if I go to my code, this shows you the location of your code base. So that's in static web app. So if I go static web app /client, static web app /API, and then www root, and then I create it, now that will stand up something. Cool. So same thing as before. This one is going to fail. This one is going to fail now. But you know, that's the world that we live in. So to go back finally and finish out my talk, because I only got 5 minutes, to summarize, GitHub Actions are a great solution to seamlessly configure your CI/CD with your Git if you already have GitHub repos. Building and deploying .NET Core apps, especially ASP.NET Core apps, is super painless with GitHub provided workflows and that runner that exists inside of the GitHub portal, and as well as being able to view the logs. You have a plethora of custom workflows, including deployment to many Azure services, like I talked about. And honestly, use GitHub Actions whenever you want to deploy ASP.NET Core to Azure. It's super easy. I showed you 3 different ways to do it in 20 minutes. So what's your excuse if you don't? So one thing to call out, I showed you some really cool thing about Visual Studio being able to generate it. So that's in preview. That's going to come out to GA with 16.9, 16.8, actually. Don't quote me on that. But there's also some really other cool things in Visual Studio, like code spaces, that you should definitely play around with. And that's my talk. If you have any questions, or if you want to take a look at any of the resources that you saw, there's a hot link, isaacl.dev/actions-.net-azure. I'm going to put this talk, and the repo is already available on GitHub. So yeah, super awesome. If anybody has any questions, Myra, are you there?
Yes, and we do have questions.
Uh-oh.
So let's go.
Uh-oh.
So one question, let's see if we can put the board up on the screen. One question from Mitch Kane are GitHub Actions an alternative to Azure pipelines, or do they work together?
So you can trigger Azure pipelines from GitHub Actions. You know, they both do CI/CD. And to be completely honest, like GitHub Actions kind of runs on the same infrastructure that pipelines do. Not saying that you should take all of your pipelines and port them over to Azure, or to GitHub Actions. Like, that's probably not in your best interest. Use the tool that works best for you. If you're already deeply integrated with Azure DevOps, keep using Azure pipelines. The team is continuing to invest heavily there. Just GitHub Actions is going to get better, right? It's still a fairly new tool. And I imagine that as we get further and further along, there's going to be all sorts of fun stuff added to it. So cool. Anything else, Myra?
Okay, I think we have time for one more question.
Yeah.
So will I be able to deploy my apps from GitHub Actions to my target service on premises? We're doing this in Azure DevOps. That's a question from Tajmal.
So currently, no. Currently, there isn't a way to basically point at that. You can use a self-hosted runner, which could do maybe a step in the way there for you. You could use a self-hosted runner or a cloud-hosted runner that puts the code somewhere, which you can then maybe have a webhook, so something internally to deploy it. But right now, that's not there. You know, I can imagine that's something that's probably coming in the future, just because, you know, the team wants to provide a really robust CI/CD process for its customers. So yeah, that's what I got.
Awesome. I think we might have time for one last one, and then we can.
Cool. Super awesome. More questions.
Yeah. So I don't think we'll have time to show, but it's like, can you show us again the script to make GitHub Action runs locally? I like in containers, so we don't have to do 50 update YAML commit.
Yeah. So
is that something?
Yeah. So real quick, I'll tweet it out, but there's a GitHub repository where a guy wrote a tool that allows you to run GitHub Actions locally. So from my experience, it works pretty good in WSL. It doesn't work as good in Windows. I think it's Nico/ACT is what it's called. But I'll tweet it out. But yeah, awesome. It allows you to run your GitHub Actions. Yeah, so like based on that gentleman or that individual. I don't know if it's a gentleman or not. My apologies. So you don't have to like say fix, and have like 35 commits. It allows you to do some testing locally. But yeah, no, I'll tweet that out.
Okay. Yeah, I think it was a question from Alexandre. So.
Okay.
All right. Awesome. Thank you so much, Isaac. It was a great session. I learned a lot personally, so hopefully our audience did too. And now we're gonna switch gears to talk about game development with Unity and .NET with John Miller and Abdullah Ahmed. Welcome, guys.
Hello.
Hi. Thank you.
I've been having a lot of fun with Abdullah lately. We work together, and I've been learning a lot about game dev. It's something that for me, it's like working like in corporate, and like you're always thinking of .NET for like enterprise and web, and like I think it's awesome that we're now going to show a little bit of how to game development with .NET and Unity. Take it away.
Awesome. Thank you. Yeah, I'm excited about it too. So we're going to talk about real-time 3D games with .NET and Unity. I'm John Miller, and I'm a program manager on the Visual Studio for Mac team, but I'm also the program manager of the Visual Studio tools for Unity. And I'm joined by Abdullah. Do you want to introduce yourself, Abdullah?
Yeah, I'm Abdullah Hamed, or Abdullah Hamid in Arabic, and I am a PM for .NET game development.
Here's a quick look at what we are going to cover here, and we can follow a little .NET Bot around our map here. So we're going to start with the overview of Unity. So I'm just going to give a quick demo and instructional kind of and look at what Unity is, and I'll show it to you, and we'll do something really quick in there. We have about 20 minutes, leave some room time for questions, talk about .NET with Unity and the tools for Unity and Visual Studio. A little bit more of what Unity offers. It's not just a game engine, so there's some other cool things there to talk about, and what the next steps are if you want to get started. And we have some helpful links and resources, and feel free to ask questions. So little .NET Bot here wants to know, what is Unity? And many of us have heard Unity as a game engine, but I grabbed this from the Unity website, and I think it explains it best. And it's more than just a game engine. It's a platform, and it lets anyone, you and me, create powerful video games and other real-time 3D and 2D applications. We're going to talk, and I'm going to demo a little bit about 3D, but you can do everything in 2D as well. And why would you choose Unity as a .NET developer? So I've highlighted a couple things here. It's a familiar development environment. You can work in Visual Studio. You can use C# and .NET. You also have a really good kind of write once and deploy everywhere story with support for over 20 platforms.
Does it support like things like VR and consoles also?
Yeah, so you can target all the major consoles, and even that Oculus you have behind you, you can even deploy to that if you want to. So yeah, so 20 plus platforms. I can't always remember all of them, but all the major ones are supported. There's also tons of learning resources online. So there's a Unity Learn portal, and we have tutorials on our .NET site as well. And there's a very vibrant community. There's the Unity forums. And since we're working with .NET, you can also leverage the .NET forums if you have specific questions about how to use .NET technologies or C# or questions like that. And then there's more than just the tooling I'll show you today. There's a whole suite and tools and services that we won't have time to look at, but I will share some links with you at the end and encourage you to take a look at them, because there's a lot of cool stuff that Unity offers there.
And what's the cost of Unity?
So the cost is you can get started for free, and then it kind of scales from there depending on your team size and kind of what your needs are. So as an individual, it'll be free, and you can take a look at it right now if you want to.
Cool.
So I think that's what we'll do. We'll jump into, I'm just going to get into the demo and spend some time there and take a peek at what Unity is. So let me jump over here to Unity. But can you see Unity, Abdullah?
Yeah, I do.
Okay, great. So I think real quick before I do that, I'm just going to launch the Unity Hub, because I want to highlight this as a .NET developer. When you want to start a new project, you're probably used to going into Visual Studio, going to File New, and choosing some project templates. But when you start a new Unity project, things are going to be a little different. You're going to start in the Unity Hub, And what you're going to do is click on this projects tab, and you can see here I already have some projects. Here's your new project button. There's also a tab here for Learn where you can download like tutorial projects that kind of walk you through step by step with different themed games here. There's a Lego game that just came out that's really cool. And if you like FPSs, or there's a karting game kind of like Mario Kart, and some platformers. There's just different things you want to do with learning paths. So that's cool. There's links to all the community stuff that I mentioned earlier. And then this is kind of like the Visual Studio installer in the sense that you can kind of manage your installations of different versions of Unity here. And I can see I have a couple different versions. I have a beta and I have a couple LTS versions. And this is a useful tool. So this is where you'll start. I'm not going to create a new project here because it takes a little while to launch Unity. So I will just open the one that I already have, which is this .NET Conf project. And here it is. So this is the Unity editor. And just a quick overview of the Unity editor if you've never seen it before, because it can be a little overwhelming, maybe if you've never seen it. So we'll start real quick. So let me see here if I can bring up my drawing tool here. So on the left here in the hierarchy, this is everything that's inside your scene. And the scene is kind of like your stage where you're going to be putting different objects like cameras and lights and game objects and sprites and 3D models and everything like that. And then the game view here on this side, this is what the camera sees. So you can see in my scene, I have, by default, I have a camera and a light. And the camera, if I click on it, it gives me a little preview of the perspective, and that's what I see in the game view. And if real quick, I'll just create a 3D object here. I'll right click and go to cube, put a cube in the scene. And let me see where that cube is in relation to my camera, just so I can get it in the view here. Looks like it's out in space somewhere. So let me see if I can move that. Okay, so now you can see. So there's an example of the game view kind of updates in real time as you change things in the scene view. The game view is what you'll see when you actually play your game. So it's helpful to be able to see this kind of iterative experience in the editor. And then we go down to the project view, which is down here. And this is kind of this kind of shows all the files and yeah, all the files that are in your project. I already have a couple folders in here that I've organized things in. So I have some materials and some script files, which are C# files, which I'll show in a minute. So this is where all your files are, and you can move them around and put them in your scene. The inspector is over here on the right-hand side, and this is like a properties panel for anything that you select in the hierarchy view, anything that's in your scenes. You can see as I click on the camera, I get some camera-specific things. I also get a transform, which defines where this object is in 3D space. I have some different camera options, and it also has this other thing called an audio listener. A light has some different properties as well. So it's not like what you see when you're in Visual Studio and you select an object in a designer and you want to customize properties, whatever the object is. So that's the Unity editor. I think real quick, so what I do here is just kind of show in the scene. What I was going to do here is kind of build out a little platformer level, but it takes a while to do that. In 20 minutes, I don't have a lot of time. So real quick, I'll just show this toolbar up here on how to manipulate some objects, and then we'll jump into a scene I've already prepared and kind of show you what I've done with it. So Unity has some kind of built-in 3D primitives. So you can see I added a cube. You can use this toolbar up here at the top, and you can translate things and move them, grabbing these anchors in the scene view. You can see that's moving around in 3D space. That changes the transform over here in the inspector. And you can rotate things, get them in position however you want. You can scale stuff. If I want to scale this out like this, and that kind of maybe starts to make a little bit of my base platform, and I'll just hit Control-D and duplicate this and pick it up here. Maybe scale this down a little bit, and maybe one more platform to keep it interesting. And there we go. So I've already kind of made my level here, and to make it a little bit interesting, I've already spent a little bit of time making it a different scene. So what I'll do is I'll open up another scene file, which has all the data for all my objects in it. I'm not going to save what I just made. And here's that same kind of thing I just did, but I've added a couple more boxes and made a character. So here's what I'm calling a player. You can see I have it over here in the hierarchy view. And I have some other cubes that I'm gonna represent as, as a pickup I'm calling it, but you can think of it like any other platformer, maybe with some coins or some type of health thing or something that you want to pick up. And I've put them throughout my platforms. And I've added some text up here to show how many pickups how many points I've got as I pick things up. So if I just play this quick, I'll show you what it does, and then I'll try to explain a little bit of how the interaction works. So here we go. I'm pressing A and D to move my character left and right, and you can see my pickups kind of rotate, and as I walk into them, they disappear, and I get 10 points. And if I keep picking them up, and if I press spacebar, kind of make it up there. I didn't say I was any good at this. There you go. So yeah, so that's my real-time 3D game that I made in about 10 minutes with some boxes, and that's a great start. So let me just dive in a little bit of exactly what I did here. With my player cube, I mentioned I was doing things with A and D and I wanted to move it. So what I did is I went into down here in my projects folder, you can see right here in scripts, and I created this C# file called keyboard movement. The way you create code and create scripts in Unity is you right click, you hit create, and then C# script, and that creates a new file. And I'll just name it something for now, but I created this code. When you double click on it, it'll open up in Visual Studio. Here's my generated solution. You can see here's the scripts I already have that you saw in the Unity project. Here's my keyboard movement script. So a couple things, we'll take a look at test scripts since that was a brand new file. You can get an idea what a file new looks like for a mono behavior class, which is part of the Unity API. And that's what all scripts will subclass by default. And that gives you some special methods here that you can see, like start and update are added by default. And mono behavior has a bunch of different methods. You can think of them sort of like a virtual method, but they're not implemented that way in C#. They're more like a callback, so which is why it's not overridden here. But you can hover over it here in Unity, or Visual Studio will tell you kind of what this method does. You can see start is called just before any of the update methods. So when this script or when this object is first enabled or the game starts running, start's called. So that's like your start callback. I'm going to do something on initialization or something like that. Kind of like a constructor here. Is probably when you would want to use this. There's some other methods that are similar. And then update is called once per frame. So this is kind of like where you would handle some game loop type of information. So if we jump back over to my keyboard movement, take a look at what I did in the start and update methods here. So if we look at the start method, all I'm doing in here is just getting some access to what's called a rigid body. I won't dive into that, but it's something for Unity's physics system, and it's going to allow me to jump. So every frame, jump down here to the update method. Let me just zoom out a little bit because I think this is big enough. First thing I'm doing is just checking what I'm doing on the horizontal axis. I want to be able to move my character left and right pressing A and D. Unity has some helper methods for that, and that's what this is. And then I am just multiplying that by some speed value that I'm doing so I can move a little faster or slower depending on what I like, and scaling it by how much time has passed per frame. So this is just a little technique in game development, so that way if I'm running at 60 frames per second, I'm not any different in movement velocity than someone who's running at 120 frames per second. I want to scale it based on the time that's actually changed, not how fast my CPU is. And then I'm just moving that character on the X, Y, Z, and I'm only moving on X here. So I'm passing 0 into sort of things. Translate is a little helper method in the Unity API, and checking for space, and you can see kind of what I'm doing here, and then using the physics system to make my character jump. And here's another helper method that Unity provides for collisions, part of the physics system here. And these are all kind of things you learn as you go through the Unity API. So don't feel like you have to digest all this right now, because you can definitely walk through one of the tutorials and kind of do things step by step, and it'll be a little easier to get it right. But I think it'll illustrate what the power of it is. So what I want to talk about real quick is one of the key things with Unity and scripting and kind of the interop between it. There's a little bit of magic happening here. So let me jump back over to Unity and show you something.
Talk about debugging now?
Yeah, let's do that. Let me jump into what these inspector properties are, and then we'll do some debugging.
Cool.
So I keep circling with my mouse, I apologize. So I'm clicked on my player object over here. And here's how I have added my movement script to define the behavior for that. So what I've done is I've just take my movement script and I've just dragged it over to here. If I just remove that real quick, I'll show you. And yeah. If I just drag this over here and put it on there, that's how you link up the script to that object. And now whenever I use the keyboard, that object's going to move based on the behavior I just showed you in the update method. Here's the speed thing. I think if we jump back over to Visual Studio, I can highlight this serialized field attribute is a special piece of the Unity API that tells Unity to expose this field in the Unity editor, so in the inspector. So you can see here it's called speed. Unity does a little bit of niceness. Let's see, go back to, where did Unity go? I lost it. Here it is. It makes it capitalized just to make it look nice in the inspector, but it's that same variable. So if I tweak this as 10, then we can see if I play my game. Now my character will be, oh wait, maybe I did. Yeah, so if I would be a little faster, but if I do maybe 20, it'll be even faster. And I could do it maybe 30, and I can kind of tweak my parameters of my game a little bit here. Here I have jump power set to 5. If I boot that up to maybe 15, he's probably going to rocket up in the air. So there he goes. He went even higher. So you can, this is kind of one of the great things about working in Unity is you can expose these properties, or these fields really, in Unity, and then be able to tweak them within the editor and get kind of this live editing and iterative experience that's a lot of fun and gives you a lot of power and saves you time. You don't have to code everything and go back and recompile and build everything completely. So Abdullah mentioned debugging.
And from what I understand too, if a variable was public, then it also appears in the editor, right?
Yeah, that's another trick you can do. So for example, if I delete this and just make it a private field, and we go back to, I keep losing where Unity is. I go back to Unity here, you can see it recompiled now that I gave focus back to Unity, and now the speed is gone from the inspector because I no longer have that attribute. But if I go back to Visual Studio and make it public, which is another option, depending on kind of what you like to do. If you like to have public fields, maybe you don't. So then you can use the serialized field attribute. See if I can, there we go. There, now see, now I have speed back as well. So there's different techniques there to expose these things, either use serialized field or make them public. And then Unity knows to put that in the inspector. Debugging is really simple as well. Let me go back to Visual Studio. And what you can do, let's say I have a problem here in my movement script and I want to look at it. I can just put a breakpoint and hit attach to Unity. And Visual Studio will attach like you're used to. Go back to Unity and press play. Once my game starts running and that code's called, there I'll jump back over here and I'm debugging, and I'm back where I want to be. I can step through and I can look at different objects in here. I've got my autos and locals and everything you would expect in the Visual Studio environment. So that makes debugging really simple.
Cool.
All right, so that is how you can start making real-time 3D games. That's how you can use Unity and Visual Studio together. Let me jump back over to let me stop Unity quick. Back over to my presentation here. Let's talk a little bit about what .NET with Unity means. There's some things that align, and then there's some nuances that you have to consider when working with Unity. So .NET with Unity is you get to script in C#. So that if you are familiar with C#, that is a bonus. You also have access to all the .NET system APIs. I put a little asterisk here because there's a lot of platforms that Unity supports, and they do a great job at making sure that the .NET system libraries work on all those, but it's not always guaranteed. So you do have to make sure that whatever you want to do in the .NET APIs is supported on the platform that you're choosing to target. And then you also can use third-party .NET libraries that you might love to use already, but with the caveat here, which is the asterisk, that they may not be tested on the platforms that Unity supports either. And also you're working in a mono environment here too. So that's something else to consider when using third-party libraries. Some differences I wanted to highlight. So project creation, so getting started is a little different. You don't do file new in Visual Studio. You download the Unity Hub and you go from there and you start a project like I showed. And then also Unity has its own packaging system.
So can I use like NuGet packages here, for example?
So there's no official support to use NuGet packages with Unity projects because Unity has their own packaging system, but we do have some documentation on our website on how you can use NuGet packages with Unity projects. But again, you have that same caveat as you have to make sure that they support the platforms and the runtimes that you're targeting. Publishing is also different. So there's all the publishing support would be inside the Unity editor. You kind of build out your binaries from there rather than do things from Visual Studio like you might be used to.
Yeah, that's a lot different.
And there's some different Unity conventions and practices. And I think a good example of that is what I just showed. So you have this like concept of having public fields or these attributes on fields so they expose to the inspector. That's kind of a Unity unique thing that you have to learn. Some of the naming conventions of the Unity APIs are a little different than what you might be used to in the .NET APIs. But those are just little nuances you get used to as you learn Unity and get familiar with the environment. So what do we do in Visual Studio for Unity developers? So we have the tools for Unity, which is a free extension that you can install. It's included with VS for Mac, and it is also available in the Visual Studio installer. It's called the C# game development with Unity. And yeah, it's on both Windows and Mac. We have the debugger, which you saw. You can attach the debugger. You can step and inspect and use locals and expressions and conditions and all those things that you would love to do in debugging. We have IntelliSense support for the Unity API methods. So those things like start and update. IntelliSense will still help you with those, even though they are kind of like magic callbacks that are not defined anywhere in code. All that stuff will still appear for you. So it helps you out as you're learning and also as you're programming. And then we have Unity specific diagnostics. So there are some gotchas with the .NET APIs and maybe techniques that you might use as a .NET developer that may not be the best practice in a game environment, or they may just conflict with some of the runtime choices of Unity. So our diagnostics will help you kind of learn those best practices and then give you quick fixes so you can change your code quickly. And then we have other productivity helpers built in to help you generate code a little faster as well. And if that's not enough for you, like I mentioned earlier, Unity is more than just a game engine. It has all sorts of services. One of my favorite is the asset store. So if you're not an artist, or maybe you just want to prototype something, the asset store is a great place where I like to go and download anything like 3D models, 2D sprites and art to code, like code packages and complete projects. Like if you want to do like like a Tetris style game or an Infinite Runner style game, but you don't really want to do everything from scratch, you could go check out the asset store, and there's a lot of complete projects on there that you can download. And go ahead.
Yeah, and one of the cool things that I like about the Unity Asset Store too is that if you're a developer and you created a library, created assets, created tutorials, starter packs, you can actually sell those in the Unity Asset Store. You don't have to be a full game developer. You can just create these assets and libraries and code and just sell it there.
Yeah, that's a good point. It's kind of like a commerce market there, and so you can be an asset store author and write cool packages and little module units of things like AI behaviors or some system to do something, and then other game developers can plug that into their projects. There's the build server for cloud builds, Multiplay and Vivox for multiplayer services, and voice chat are part of Unity. They have a CDN to use for your games, and Unity Reflect is a cool tool that lets you visualize and manipulate kind of in real time CAD data, which I think is pretty awesome. So if you're in any of those industries, that would be something to check out. We also have Microsoft GameStack. If you're not familiar with GameStack, it's pretty much Microsoft's kind of complete package of our tools and services to help you build games. Some I've highlighted here are Azure PlayFab. There is a Unity SDK for Azure PlayFab to let you do things like make leaderboards, and it also has a multiplayer service. The Unity SDK handles things for live ops too in your games. And then if you want to build your own, there's always Microsoft Azure as well. And then we have GitHub, and there's some community extensions to make working with GitHub Unity projects simpler. And your buddy Abdullah here, game developer Abdullah, has some great tutorial series, and I have a link here to it. aka.ms/unity101. And that is a great place to get started as well. And I think there's 6 videos there, right, Abdullah?
Yeah, there are 6 videos that take you through the process that you just demoed. And it will teach you step-by-step how to create a project, install Unity, install Visual Studio, and start coding with C# and Visual Studio, and how to use the input system, physics, how to build things. It's designed also for .NET developers mostly. So if you're already an established .NET developer, this is a really good place to start.
Awesome. And here's some helpful links. Slides will be available to you, but if you want to take a look now, you can get started at unity.com. If you're brand new to Unity, that is a good place to go as well. And we also have the documentation for the Visual Studio tools for Unity, which is VSTU-started, and a couple of .NET tutorials there for Unity. And we also have the Microsoft GameStack Discord, which is a community with game developers of all backgrounds, not just Unity developers as well. And if you are interested in .NET game development, maybe Unity is not the right choice for you, or maybe you're just interested in what else you can do with .NET and game engines, there's also tons of options. Abdullah, do you want to talk about this a little bit?
Yeah, so there are multiple types of game engines. There's mostly game engines that are built with C++, but they also embed the .NET runtime in it, like Unity, for example, CryEngine and Godot, and you can use C# to script for those engines. But there's also engines that are completely built with .NET, like MonoGame, Stride, and Wave Engine. And I think Wave Engine and Stride are going to support .NET 5 pretty soon, so that's pretty exciting. Maybe MonoGame too. So if you're also familiar with the .NET ecosystem and you want to remain there, you want to use NuGet packages, you want to remain in the in kind of the world that you already familiar with, then maybe trying one of those would be a good idea. Yep, just go to .net.microsoft.com/apps/games, and you can go and take a look at all of these engines and make your choice.
Awesome. And that's it. Thanks for joining. I have a conversation on Twitter. Is .NET Conf is the hashtag. You can ask questions, chat about, and yeah, feel free to reach out to me on Twitter. My tag is in there at Gmail or Dev. Happy to help if you have any questions about Unity or Visual Studio.
Sure. I'm always there. I'm Indy Saudi, so try to contact me anytime you want. DMs are also open.
All right. So let's go and ask one question here from the board. So Bitbonk asks, do you think there's a way to embed a Unity interactive 3D visualization into a .NET WPF application 3.1 or 5?
There is a way right now to embed Unity libraries inside of different .NET workloads. Soon, hopefully, you're going to see maybe more documentation and more blog posts about this. I'm working on it. But yes, the answer is yes.
And for you, Abdullah, what path or book do you recommend to begin developing with Unity from Diego?
If you're a .NET developer, go to my videos right away, aka.ms/Unity101. That's a good place to start. There's also a quick start tutorial on the .NET website. There's also the Learn portal in the .NET website where you can see a lot of community videos and tutorials out there that are developed by the community that you can go and start with it. Also, Unity have their own quick start tutorials, and they just launched one with Lego too. If you like Legos, you can go and try it out. So yeah, there's so many choices out there.
Awesome. Thank you so much for the session. It was great. And don't forget to ask your questions on Twitter, hashtag .NETConf. So next, I'll introduce our next host. We'll be taking over. Cecil Phillip will join us to take it over to the next sessions. Thank you for having me.
Hi, everybody. Thank you, Myra. Appreciate it so much. And so hope you all have been enjoying .NET Conf so far. My name is Cecil Phillip, and I'm going to be with you for the next couple of hours or so, introducing the next few guests that we have on. But before we do that, I definitely do want to remind you As you're enjoying the rest of the conference, please make sure you check out our swag. We do have digital swag. So if you go to dotnetconf.net/swag, there's tons of really cool digital swag for you to check out. There's a really cool Visual Studio theme, VS Code theme in there for you to check out. And there's also our technical treasure hunt too, where there's tons of prizes in there. Lots of great stuff for you to get. So please make sure you go ahead and check that out as well. Now, that being said, I want to go ahead and introduce our next guest that's coming up. We're going to have Jeremy. So Jeremy, he is a Azure software architect, and he's going to be talking to us about some of the new and improved Azure SDKs for .NET. So Jeremy, why don't you go ahead and kick it off for us?
Thanks, Cecil. And it's Jeffrey, not Jeremy.
Oh, I'm sorry. I apologize. I thought I said Jeffrey.
All right. And you can see my slides now? Yes? Or no? Yes, there you go.
Yes.
Okay, better. Thank you. Hi, everybody. I'm going to be talking about the new and improved Azure SDKs for .NET. I am Jeffrey Richter. I'm a partner software architect on the Azure SDK team at Microsoft. Some of you might be familiar with me from some of the books that I've written in the past. I did some Windows Runtimes books, some .NET books with C#, and a bunch of Windows books. Also have some contact information in the bottom left. Most recently, though, I did a video series on how to architect distributed cloud applications. It's a 6.5 hour long free series just on YouTube. And here's a link to go to for that, and I would encourage you to check that out. A lot of the principles and things that I discuss in that series affected the design and architecture of the Azure SDKs that I'll be discussing in this presentation. So the Azure SDK team was created just over 2 years ago within Microsoft, and we had several goals for the creation of this team. The first goal is that there were a lot of Azure service teams, and they were building client libraries or SDKs for customers like yourself to use, but every service team had their own way of doing things. And so there was very little consistency. It didn't look like Azure was a holistic developer platform. So that's why this team got created 2 years ago, was to say, let's look at all the Azure SDKs and let's have them be idiomatic, which means if you're in C#, we use the C# idioms that are there, like properties and methods, and it's object-oriented and it's virtual methods and so on. And if you're in some other language, we do the proper thing for that other language. One of the things Microsoft has gotten feedback on in the past is that our Python libraries looked a lot like they were created by a C# developer. And that's because that's what happened. But now our Azure SDK team, we have experts in these various programming languages that we support. And there are many languages that we support. And those developers, they live and breathe in that language and the ecosystem. So the package managers and the way you design code. So it should give developers like you an idiomatic experience when you grab one of our libraries. The next goal that we had was we wanted to make the libraries be consistent, so that the way they do authentication, for example, or the way they do logging, or the way they do send telemetry and so on, there's a consistent experience, and the way you configure those things, retries is another example. And actually, that's what I'll be spending a lot of time on in this presentation, is going through some of these places where we get a lot of this consistency and bring you a lot of features as a customer using our SDKs. We wanted to make the SDKs approachable, so they're very easy for you to get started with them, and I'll show you that on the next slide. They all have a very consistent pattern to them, and then you can start leveraging the Azure services in very short time, like less than a half hour probably for most, maybe even less than that, for some of the services. And then you can gradually grow into the SDK and learn more of its features and parameters and different overloads, so that you're fine-tuning the behavior as you desire for your own application. Another thing we focused on very heavily is diagnosability. When you're using one of our SDKs, you're building a distributed system where your application is talking to Azure services. And whenever you build a distributed system, there's a lot of potential for failure. The network might go down, you might have the wrong endpoint, authentication might fail, and so on. A timeout might occur when waiting for a response. So we have focused on this very heavily, and we've built a lot of mechanisms into the SDK so that when failures like this occur, we surface what the problems are, and we lead you in a direction that you can self-correct these things without getting other people involved to get you back on track so you can start writing code and get things working again. It has been a very big, significant part of our push as when we design new features. And then, of course, dependability. We test our SDKs a lot. We do performance testing. We do unit testing. We're adding features. We have an active team that's working on them. We ship new versions almost monthly for each thing. We have a very high quality bar. We avoid breaking changes, not only in the SDKs themselves, but we work a lot with the Azure service teams so that they don't introduce breaking changes, which means we don't have to break anything in the client library. We're not perfect with this. We're doing the best we can with it, but it's getting better over time, and so the dependability should be greatly improving. And we've documented all of this in SDK guidelines, which we publish on GitHub and available for anybody to see, are guidelines that are overall, and then we also have guidelines that are unique to each programming language. So I said that it's very easy for you to get started using our SDKs. So let me give you what the typical code is that you would write to make some service request. Normally, after you download one of our client libraries, and in .NET, you would add a using directive to the top of your source code. Then inside your function, when you want to talk to an Azure service, you would write code to new up some kind of client. Like this could be a blob client or a key vault client, right? Depending on what kind of service you want to talk to, you would download that service's client library, put the using directive in, reference the assembly, of course, and then you new up the proper client. This is usually your starting point to get started with any kind of Azure service in your code. When you new up a client, all clients typically take two things that are mandatory. The first thing is, what is the endpoint for that client that for the service that you wish to speak to? So you would put in here the endpoint. We make you do this explicitly because a point of failure is that endpoint can't be reached, but you're passing the endpoint in, so you have complete control over this endpoint. If something fails to connect, it could be that the endpoint that you passed was wrong, so then you can easily go and fix it, and you know what it is you're trying to talk to. In addition to the endpoint, when creating a client, you must also pass in what kind of credentials you wish to use in order to authenticate. Our client library is shipped with many different kinds of credentials. The easiest one to use when getting started is the default Azure credential. This one analyzes the environment on your machine. It can look at environment variables. It can look if you're logged into VS Code or Visual Studio with an Azure credential. It can grab that stuff and it can use that for doing the authentication. But we do have other credential mechanisms that are available as well. After you've created this client object, you get a reference to it back, which I'll put in the variable client here. And then in order to make a call to the Azure service, you simply use that client, you say dot, and then you call some method. And in .NET, we have async and we have synchronous versions of all the methods. In this example, I'm only showing the async one, but we have sum up without the async suffix as well. And this will call whatever service operation you desire on this client using this endpoint and using this credential. And then depending on the operation, you may have to pass in some additional parameters. Like if you're uploading a blob, you have to pass in a reference to a stream, and that's where it'll read the data from the stream and put it into the blob up on the server. And then typically you will await an asynchronous operation, and this returns to you a response back that you get back from the service. And that's basically it, right? So you new up a client, it has the URL and the credentials, and then whenever you call some method on that client, that method will go to that URL using those credentials to perform that particular operation. Now, that's the simple getting started scenario, and I think we'd all agree this is fairly simple. But we do actually have a lot of stuff that's happening under the covers here that I would like to spend the time on in this presentation. When you new up a client, we internally create a thing which we call the HTTP pipeline. The HTTP pipeline looks something like this, and it's extensible, which means that you can enhance it. And in my demo, I will show how to do this. So on this client, we're calling some method. Internally, that method call is going to run through this HTTP client, which is a bunch of policies that the constructor of the client has created for you and initialized. And the last policy in that pipeline is the transport policy. This is the policy that actually takes the HTTP request and sends it over to the wire to the Azure service you're trying to talk to. And then when the Azure service sends a response back, it goes back to the transport, and then the transport sends the response back up the pipeline and then ultimately returns a value to you. But let's talk about what's actually happening in this pipeline. The pipeline, as I said, it takes a request and it passes it down. And we have a bunch of what we call policies in the pipeline. So the first policy gets hit is the client request ID policy. What these policies typically do is they can mutate the URL or add query parameters or headers onto the request. They usually do not affect the body of the request, although they could. They usually do not. And so they're modifying the URL, the query parameters, and headers typically. The client request ID goes and adds a unique request ID header with a GUID, and that will be ultimately sent over the wire to the service. This way, the service can keep track of your client request IDs, and this can be used in case you need to call customer support to track down, hey, I got a response from the service. I didn't expect what I saw. This was the request ID that I used to make that request. Another policy in the pipeline is the authentication. This one typically adds the authentication header into the request using the credentials that was passed into the constructor when you newed up the client object in the first place. The next policy is the logging policy. This policy will notify you, after you configure this, that a request is about to be sent over the wire. So your logger can know every time any one of our clients is sending about to send an HTTP request over the wire. So you can track all of that. And then you can see what the request looks like with the headers, the query parameters, and everything else. Again, very important for diagnosability and debugging of problems. The next policy we have is a distributed tracing policy. This adds some additional headers for services that support distributed tracing. So that you can track a client request from its origin as it travels through multiple services to get to some other service. That can be treated as a single logical request, even though it's spanning multiple servers. And this distributed tracing policy goes and tacks on that additional information. So now those policies have modified the request. They send the request to the service, and now the service sends a response back. When the response comes back to the client object, the response now walks backwards through the policies. So most of the policies don't do anything to the response, like distributed tracing doesn't do anything. However, the logging policy does. The logging policy will log the response and correlate it with the request. So now in the log, you can see this request created this response, and you have those correlated together. Another policy that's in here is the buffer response policy. This policy does nothing on the way, it does not modify the request, but when the response comes back, this buffer policy will typically read the entire response payload from the service at this point. The reason why this is here and not somewhere else is because we have another policy, which is perhaps the most important one, and that is the retry policy. Because distributed applications are very likely to fail due to some networking issues, like timeouts or the server doesn't reply in time or so on, we have a retry policy in the pipeline. And the retry policy doesn't actually mutate anything. It doesn't mutate the request, and it doesn't mutate the response. This policy instead modifies the behavior. When the request is going down, it doesn't do anything at all. But if we're reading the response, let's say back from the service, and because of the buffer response policy tries to do that read, if while we're trying to do that read, the network connection fails, then an exception will be thrown. That exception will be caught by the retry policy over here. The retry policy will then loop around and it will reissue the request automatically, sending it back through the authentication, logging, distributed tracing policies, and then issue the request again. So in other words, when you're using our clients and you're making an operation call, you're making a single logical operation call, but under the covers, it might end up being multiple physical operations because of the retry policy here. They all share the same client request ID because this is the logical operation, but each of those physical responses will be logged separately so you can see them. And this allows you to not have to think about retries in your application and makes your application more robust and reliable because we have built this mechanism into the pipeline for you automatically. And then these are policies that we ship with each of our SDKs. But as I mentioned up here in the top left, our pipeline is extensible. That means that you can go and create your own policies by creating a class derived off a base class, and I'll demonstrate that in code in just a moment. And then you can insert your policies into the pipeline. And you can insert them as per call policies, which means they will execute once per the method call, or you can insert them as a per retry policy, which means it will execute once per every retry. And you can pick this whatever is meaningful to you. Whatever you need to be involved with. Okay, so that's our underlying mechanism. Now let me switch over to Visual Studio Code, and I'll demonstrate how this works and how you can tap into it. So the first thing I wanted to do is I want to create my own policy. So in .NET, we have a base class called HTTP Pipeline Policy, and to create your own policy, you create your own class and simply derive it off this base. This one here, I'm just calling the simple tracing policy. And then it has a virtual method on the base class called process async, and I am overriding that virtual method. You see that it receives an HTTP message as input, right? So all the policies in the pipeline, they receive an HTTP message as input, and then they receive this is effectively a pointer, if you will, to the next policy in the pipeline, because your policy has to invoke the next policy in the chain in the pipeline. Inside the HTTP message, there's also the response. So you'll have to return the response back when you're all done. In this very simple demo here, when this gets called, I just have a console write line that says we're about to make a request. Look at the request method. So this will be like a put or a get or a post or a delete possibly. And then I can also get the URI. And again, I'm not mutating these things here, but you could actually mutate them in a policy if you wanted to. Then I go and call the next policy in the pipeline, passing it the new message, and then this pipeline thing, so it knows how to call the one after itself. And then when this returns, so now I have the response, and this is returning back, I will say, oh, I got the response, and we can look at the response status code, like is this a 200 OK or a 201 created? And then I also have access to the original request method and the original request URI, right? So you have all this rich information about what was going up and down through the pipeline. So I've created this class and I've overridden this one virtual method. Now let's go and use it in our code. So here I am inside main, and what I showed you earlier was that you normally create a URI and then you new up some client. In this case, I'm using a blob service client. You pass into a client the URI and you pass into it credentials. But what I didn't show you on the slide is that we have another overload of this constructor. All clients have an overload of this constructor that can also take an options structure over here. And the option structure is how you can modify the pipeline that is being used internally by this client object that you're creating. So to leverage that, I'm newing up a blob client option structure. It already allows me to modify the behavior of the retry policy that's in the pipeline. So I can set the maximum retries to 10, and I can set the delay time to 3 seconds. And in this case, I'm going to turn off the logger that's usually turned on, because instead of using the built-in logging policy, I'm going to use my simple tracing policy instead. And in order to accomplish that, I new up an instance of my tracing policy. That's the class I showed you down at the bottom. And I say that I want it called once per call instead of once per retry. This is an enum that has 2 possible values. And then on the option structure, I add this policy into a collection. So now my options are all initialized for how I want to fine-tune the behavior of the pipeline. I can then go and new up the client, and I pass those options in over here. This now returns back to me a service client, which is exactly like what I showed you on the previous slide. Now that I've done that, and actually let me step through this. Done that, okay. Now, in this example here, I'm going to use that service client, and from the Azure Storage Service, I want to go and get a URL to a container that's within that service. So I'm calling this function getBlobContainerClient. What this function does is it takes the URL that's in the service client and it appends this path to the end of that URL, because this is how the Azure Storage Service works. Containers are created as children, if you will, in the hierarchy of the path. And this is going to return back a blob container client. This is a different client object than the one I had before. But here's the interesting thing to note about it. When I use this parent client to create a child client, the child will inherit the pipeline of the parent. So in other words, all these options that I set up above and I applied them to the blob service client, those same options will flow down and will now be on the blob container client as well. And to prove it, I will now use that blob container client, and I will call this function createIfNotExists, which will try to create the container up in the actual service. And when I do that, if you look at my debug console down below, you'll see that my policy got invoked. And we see it's a put request, and here's the URL for it. Here's the some container, which got concatenated on because of this. And then here's the response that came back, which is a 201, which is a created. So the service successfully created the container that happened because of our original put operation to this URL. So that's our tracing policy working, and we can see it functioning properly. And then I'll show another example where now, because since I've created a container in storage, I can go and get a blob client, and this goes and takes the name of the blob and concatenates it to the end of the URL in order to create a new blob client object. But just as before, in this case, the parent, in this case, which is the blob container client, it has a pipeline, and that pipeline will be inherited by this child client, which is the blob client. And then to prove it, we'll use that blob client, and then I will upload some data to the blob. And if you look at the debug console at the bottom, you can see that it did a put request. So it inherited our options, so it's calling my tracing class object. You can see the sum blob.text was concatenated to the end of the URI, and that the service returned a 201 created from this operation. And so this demonstrates to you how we have this pipeline mechanism, kind of explains how it works and what it does. Also shows you how you can modify the behavior of the built-in policies, like the built-in retry and the built-in logger, and also demonstrates to you how you can create your own policies that do whatever it is you want them to do, like client-side caching or fault injection. There's a lot of possibilities there. And then how you can add them in when you create a client to modify the pipeline's behavior, and then how the pipelines get inherited by the children, so you get consistent behavior throughout. All right, so that's my demo and my slides. I will now take any questions that people might have.
All right, sure. Thank you so much, Jeff, for that presentation. Why don't we head over to the tag board and we'll take a look at some of these questions that folks have. I know we have a couple of minutes, but I first wanted to shout out Peter Stacy on Twitter. And Peter here is showing off some of that .NET swag that we have. And so he printed this off a little while ago. So just wanted to show that to everyone really quickly. And remember, you can get swag if you head over to dotnetconf.net and you head to our swag page. And we have lots of really cool swag like this that you could check out. Now, questions. All right, let's take a look at Charlotte's question. So I'm going to click on Charlotte really quickly. And this one says, can we use that XYZ client object with a using statement?
Well, it's more of a .NET question than anything else. It's the name of a class. So I know they added that feature in .NET where you could say using console, and then you can just call WriteLine everywhere. But it wouldn't know what instance. That only works for static. So the answer would be no. Oh, do you mean using a statement for calling dispose? If that's what you mean, then the client objects are not disposable, so there's no need to do that.
Okay, great. Yes. All right, next question. I'm going to check out Sergio's question. And Sergio is asking, I noticed that web application service can generate more than one instance. Does this mean that a copy of the website will run simultaneously on another server? If so, what will happen to SignalR users who are connected into different servers?
Well, this is not really related to the conversation at all. But yes, if you're running multiple instances of the web application service, then your code will be running on multiple instances. And what impact that has on SignalR is not my area of expertise.
Yeah, I don't think that's so much a security question. Let's see, what else do we have? I'm going to click on this one. All right, and so this question here is asking, does MFA work with Azure default Azure credentials when debugging with VS? I know there were some issues in the past.
This would also be probably better asked on our GitHub repo where our security person can go and respond to that. I do know that we have a credential. I do know there were some issues, and I know that we were fixing them. I don't know what state that's in. So I think I'd be better off not being the one to attempt an answer on that.
Okay. Looks like we have a really good comment here from Patrick as well. Patrick is saying the new Azure SDK is really well architected, and Jeff is explaining it and the thoughts behind it very nicely. So definitely appreciate that, Patrick. Appreciate the sentiment. Do we have any more questions that we could ask you? No, doesn't look that way. Like the rest of these questions are not related to your talk. So with that being said, Jeff,
I have a few more things I could say then.
Sure.
So I didn't think I'd have time for this, but another part of our design is that the pipelines are immutable and that all of the policies in the pipeline that we ship are also immutable. And the benefit of that is that means that multiple threads can be using a single client and with its pipeline all simultaneously, and we don't take any locks or do any kind of thread synchronization, so the performance is really good, and that is guaranteed to work. That being said, and even when a pipeline is inherited by the children, they're really sharing pipelines under the covers because they're all immutable and thread safe. So that means we're using memory very efficiently, and because they're immutable, there's no locks, and so performance is very high. And that being said, one policy in the pipeline actually is mutable, and that is the authentication policy. And the reason why we allow that one to be mutated is that it allows you, the customer, to be able to roll over a password or to refresh a token in the policy. But we make sure that that refreshing or updating is done in a thread-safe atomic way. So we do take a lock over the update, but then we release the lock right away. And that allows you to be able to roll over credentials while multiple threads are using these clients simultaneously. One thread can roll over the credentials and everything keeps working. So again, you have very high performance, very efficient use of memory, and the ability to roll over credentials in real time without blocking your application or restarting it, or without having to do any kind of thread coordination.
Got it. Okay. All right, Jeff, we have time for just one more question, and I'm going to ask this one really quickly. This one's from Joe. Joe's asking, what is the best option to authenticate an app service?
I'm not sure what you mean by app service. I mean, again, if this is a service you yourself are building, you have to decide what your own authentication mechanism is that you want to go and use and how you want to manage that. Our SDKs are for authenticating with Azure services, and those Azure services, they define what authentication mechanisms they support, and sometimes that does change over time. A lot of them are supporting Azure Active Directory today, for example, and then they didn't used to a few years back.
Got it. Yeah, the way I kind of read that was, how do you authenticate with Azure App Service or Azure Web
App Service?
And so that would probably be thinking more about like user authentication, probably.
Yes, I don't know what the authentication mechanism that app service uses. Or if you're building an app that runs inside it, then it's your authentication that you want to use for your app.
Sure, that makes sense. Well, hey, Jeff, thank you so much. Really appreciate it. And for all of you that are still watching, please go ahead and continue to submit your questions. We're taking questions on Twitter at #.NetConf. And also, we're going to queue up our next set of guests that are going to come on very shortly. But while we do that too, again, let me take another look at some of the folks here on Twitter. We have a lot of great folks here that are, here's a picture of Jen. I don't know if you could share my screen really quickly, but here's Jen, again, showing us some more of that cool swag we're getting. And you all can check it out too. It's free. Again, head over to .netconf.net/swag, and then you can check out some of this really cool swag that we have up here. Now, that being said, coming up next, we have two guests. We have Raul, and we also have Jeremy. And Raul and Jeremy are going to come on, and they're going to talk to us about diving into the world of big data with .NET for Apache Spark. So, gentlemen, I'll let you go ahead and take it over.
Sounds great. Sounds great. Hello, everyone. My name is Rahul Pothraju. I'm from the Azure Data team, and today I'm joined here by my colleague, Jeremy Lickness from the .NET Data team. We hope you're having a wonderful day so far. Today, we are going to be talking about the role of .NET in big data. And before we start diving into this new library that we've built called .NET for Apache Spark, let me start with something more fundamental. Let's start with the basic question, what is Apache Spark and why are we actually talking about it today? So Spark is a unified parallel data processing framework. What does this mean? Imagine you're writing a console application, and when you hit something like F5, it usually ends up running on top of your machine. But in this particular case, Spark is a system that allows you to take the exact same code and run it on a cluster of machines. When would you use this? Well, when the amount of data that you're trying to process is increasing in size, especially when it starts hitting into gigabytes or terabytes, then you would need a cluster of machines to start processing that. One of the nice things with Spark is it comes with this thing called as the Spark Core Engine, which attempts to unify batch processing, interactive SQL. It does a bunch of real-time processing. It also allows you to do things like machine learning, deep learning, and also graph processing. And all of this works seamlessly well in the form of different kinds of libraries that are built on top of this Spark Core Engine. That way, once you learn something, pretty much you can use the same knowledge in order to do anything inside Spark. And one of the questions that you might be wondering at this stage is, hey, yes, we are targeting .NET developers. Why didn't we just go ahead and build something from ground up from Spark? Hopefully I can convince you now. So Spark is an open source project. And one of the great things about Spark is it's heavily popular. Whether you take it in data engineering or data science community, it has a pretty large following on GitHub. It's all open source. You can go look at the code. And if you start looking at the number of people contributing to Spark, it's roughly about 1,600 people. And it's all the goodness of open source. And pretty much if you want to understand something, you can just go dive right into the code. And at that stage, what we also ended up seeing is there was a tremendous amount of demand that came inside Microsoft from all of our teams, including large teams like Office, that wanted to get into the world of Spark, but not having to relearn like a new programming language like Scala or Python. And this is the basic reason that we started investing in .NET for Apache Spark. So what does .NET for Apache Spark provide you with? Well, it provides you with first-class support, and I really mean first-class, and I'll show you hopefully with some examples to convince you that it's really first-class. It provides you with support for Spark data frames, which give you the full power to leverage the underlying Spark's optimizer without having to worry about manually optimizing code with hand. It works seamlessly with the major versions of Spark that are out there in production, like in many companies, essentially. To name this, it works with Spark 2.3, 2.4, and 3.0. It targets .NET Standard. One of the nice things we get by targeting something like .NET Standard is the nice thing that now your code is cross-platform. If you want to run it on .NET Framework, feel free to do that. The recommended approach is .NET Core 2.1+. And majority of the cloud providers anyway support .NET Core, so you should see some nice goodness coming out of it. And finally, one of the great things is the library .NET for Apache Spark also supports both kinds of computation. One is batch as well as streaming, and it includes first-class support for Spark structured streaming, which is one of the nice things that you end up getting. So if you have scenarios where you have real-time data coming into your compute clusters, you can go ahead and start using .NET for Spark in production pipelines today. And one of the nice benefits of building a layer on top of Spark is if Spark can talk with any data source, think of Azure or maybe Amazon's S3 or even like Cosmos DB, you name it. One of the nice things is because we leverage everything from within Spark, if you see some data source working perfectly with a Scala example or a Python example, you can use pretty much the exact same thing in the .NET world as well. So let me just briefly start explaining what does the programmability model look like. Step one, when you start writing this, most likely this statement will become your best friend. The first thing that you would end up doing is you would end up creating a session. So a session, think of it as being analogous to requesting some kind of machines or cores in order to run your application itself. So in this case, I'm saying like Spark session, go ahead and get or create a session for me. In step two, what I would end up doing is I would create something called as a data frame. You can think of a data frame as, if you're familiar with SQL Server, you can think of it as providing the table name essentially, wherein you say select something from the table. This is analogous to saying Spark, go ahead and read this particular JSON file, and the name of the JSON file is input.json, and you're basically specifying that this is my data provider, which is JSON. In step three, you get the goodness of C#, and this is what really made the entire team proud when we managed to achieve something like this. You can write a simple user-defined function. In this case, this is a user-defined function that takes two parameters. One is a nullable integer, the other one is a string, and returns a string. And what it does is, it's basically saying expect two parameters, one is an age, the other one is name, just go ahead and concatenate it and return it back. And here's where something interesting happens. Now you can take this user-defined function and basically give it to Spark. You're now saying dataframe.filter. You're providing some kind of predicates in order to filter your data based on this criteria that I only want to select records which are greater than 21 years old, essentially, right? And then you're saying select, and then you're passing in the user-defined function that you defined into Spark. And I want you to take a moment to notice what we just did. Without any difficulty, we took a user-defined function, gave it to Spark, and now Spark can automatically parallelize this across 10 cores or even thousands of cores, essentially. So that is one really nice thing that you end up getting with this kind of a library. It simplifies the entire abstraction and allows you to focus mostly on your business logic. Having said that, you might be wondering at this stage, hey, what am I going to lose? Like, it looks like Scala is written in the JVM, Scala being the primary language. What am I going to lose? Well, you're not going to lose much. So for comparison, just to kind of make a point here, the left side here shows a TPCH query 2 written in Scala. TPCH, for those who are not familiar with, is a standard industrial benchmark. It's a collection of 22 queries, and you'll have to kind of show that your system passes those 22 queries for it to be useful in any real production use cases. What you notice here is the left side shows a Scala example, and the right side shows the exact same example written in C#. You can take a moment to see what exactly are the differences here, and you'll immediately notice it's dangerously copy-paste friendly, and the team has been very conscious about allowing and encouraging you to do this, because we do want you to search on Google. We want you to search pretty much anywhere on the internet, go to Stack Overflow, copy paste the examples, and just change very trivial things in order to make the example run on top of C#. The second piece you will notice is there are subtle differences, like the way you would address a particular column. And finally, some bits and pieces about capitalization. But I'm not kidding. The 22 queries of TPCH, it literally took me about less than an hour to copy paste from Scala into C# and just change them to actually make them work inside C#. And I'm pretty sure you're going to love the experience. Having said that, if you're familiar with Spark at all, you would be very familiar with this particular thing called a Spark Submit. What it does is it's a small companion tool that comes with the Spark distribution itself, which allows you to specify what is the entry point of your application, along with what is the user jar that will host your application logic and any particular arguments to your app. Now, one of the nice things that our team has done is .NET for Apache Spark does not modify Spark core at all. The biggest advantage that you end up getting by having something like this is you can take exactly the same Spark Submit companion app that comes with the open source Spark. You just change these two minor things. One, whatever is highlighted in yellow here is the one that's provided by the .NET for Spark library. You don't need to change this at all. The other piece, this piece is the one that you would pretty much specify with your application executable, and that's basically it. This is how you would end up running it. And let me show you quickly how we end up doing that. So in this case, the whole code is available under .NET/Spark. You can basically go here, browse around for examples. You can basically also see, how do you go ahead and build or get started on any of the three major operating systems. Again, I do encourage you to kind of try out, but an easier way to start would be the .NET Spark homepage. Once you get to the homepage, you just do a getting started, the get started piece, and we've put in a lot of thought in terms of simplifying the entire thing. There's also a video that is accompanying these instructions in case you prefer a video style. And what I've done before this talk is something as simple as just go ahead and install .NET Core, install a bunch of prerequisites. There's not many, like there's just the Java runtime that you need on your machine. Again, if you choose to develop using a cloud provider, you don't really need any of this stuff. And the one thing that I've done is I've gone ahead and downloaded Apache Spark onto my machine, and I've just followed the instructions here. Basically, there is nothing else that I've done here. Now, once I do this, one of the nice things here is I set some environment variables, specifically these pieces. Right after that, you can use whatever .NET knowledge that you already have in order to go ahead, create a new console application, and basically just CD into that. So essentially, those are the steps that I've done before beginning this talk. And I've landed into my favorite IDE, which is VS Code. And all I've done, just to convince you here, is I have a very simple project. All I've done is there is a program.cs. I've copy pasted the same example from that that website that I've just shown you, and I'll cover what this actually does. And I've also created this input.txt file here. This input.txt file, it basically contains a bunch of things, and I'll run you through what exactly this sample app does. Like I said in my talk, I go ahead and create a Spark session. Once I create the Spark session, I'm basically telling Spark, go ahead and read my file. My file is in the text format, and here's the path I want you to read that file from. Right after that, I'm going ahead and invoking operations that look very analogous to LINQ or SQL. And you're actually right when you guess the thing. Like you will see Spark is heavily inspired from LINQ, and you'll see a lot of syntax which is very analogous to LINQ itself. In this case, what I'm doing is I'm taking the data frame, I'm doing a bunch of transformations using select, and I'm doing a group by. Why? Because I want to count the frequency of each of the individual words, and I'm doing a count right here, and I'm finally ordering it by this particular column. And I'm instructing Spark, go ahead and show me what you have. And I'm stopping my session. It's as simple as that. Now, when I run it, all I need to do is I just need to do .NET build. Once this gets built, essentially what I can do is I can just go here, and there is one command that I had shown you in the previous slide. This command, what it is doing is it's basically going and specifying the fixed parameters that I've shown you inside the slide, and it's using the latest version, which is 1.0, and it's specifying this is my application and this is my parameter. Let me go ahead and run that, and you will see now what's going on is this particular command is invoking my C# application to leverage the underlying, the Apache Spark binaries that I've actually downloaded locally onto my machine. the first time that I'm running this, it takes like, a couple of seconds for it to initialize and whatnot. But you will see very shortly that there's going to be like a flurry of messages that get printed out on the console. And, if everything goes well, you will end up seeing some of the output that gets printed out here. So like I mentioned, you will see some debug information that gets started. And what's happening in the backend is we've taken very, very good measures to make sure all the complexity gets hidden behind the scenes. You will not really know what's really happening on the Spark side. What does it take to kind of start all of those pieces? Here, it ended up going ahead and running Spark, and you get like a first-class C# experience. You did not have to really know anything on the Java or Scala side. Don't be worried about the logs that are getting printed. Spark is quite chatty, as you can already see it. If you can see here, what just happened is I took that input file and I managed to just go ahead and print the word count. It's as simple as that. And we do have some other demos that show you some of the nicer, cooler new things that we have actually built. So the one other thing that we've been doing is we've been in contact with the community quite a lot. We've been doing quite a lot of surveys to actually understand what is it that our users want. And I'll now hand over to my colleague to present some of the results from our developer survey.
Sure thing. We are on the developer survey. If we want to switch to my share, I'll advance from here. So we reached out, especially around, we just went to a 1.0 version. So we were pretty excited to hear from the community and understand exactly how they're using Spark. We got just over 200 responses, and the majority of those respondents were developers and architects. You can see the breakdown here. What was interesting to us is Python, Scala, Spark, SQL are sort of the out-of-the-box languages and have been around for quite some time and are preferred to be used for that. So it was exciting to see that we had a 30% or 1 out of 3 using C# now, which means that .NET for Spark is making some inroads. We actually have some F# usage as well. So F# users are plugging into the .NET for Spark paradigm. As far as platforms, we noticed that 2 times the number of people were using Visual Studio compared to Visual Studio Code, and 70% were running on .NET Core. And the team was looking at, are these workloads mostly run on .NET Framework, .NET Core? And it turns out there are a significant amount that are on the .NET Framework, but a vast majority are on .NET Core. And then we went across the board. We asked a lot of questions, but we wanted to know what scenarios are people using for big data and .NET for Spark. And it turns out the common scenarios are extract, transform, load, analytics, and data warehouse. Now the challenges, it's interesting, the challenges for big data in general and specific to .NET for Spark were the same. People said that the dependencies and the setup was a challenge. There were a lot of prerequisites, and documentation was a challenge. And I'm happy to say we were already on the path to address both challenges. Our documentation has been completely updated. That's been rolled out. But I'm going to talk about dependencies and setup in a second, so we'll come back to that. As far as requested features, so where do we want to take .NET for Spark? A top feature was deployment from Visual Studio, being able to do that Spark submit as something as simple as a right-click gesture. Another is integrating with CI/CD for those who don't right-click deploy, right? And the other is integration with ML.NET. And to be clear, .NET for Spark allows you to use any of your .NET libraries. So you can today take advantage of ML for .NET in those jobs. This integration is tighter integration between data frames and sharing data between the two tools. Now, one of the nice things about .NET for Spark being open source is we get these amazing community contributions. And one of those that's helping us close that inner development loop is this community contribution of a set of Docker images. So there's several Docker images that out of the box create that environment. And that is actually perfect for me because I have a brand new laptop and I did not install Java. I did not install Spark. So I have none of those tools on my machine. I'm going to pop over to Visual Studio Code and I'm going to show you a program that's very similar to Rahul's. I obviously stole it and modified it, but I took some of the text from the .NET Conference site. That's what's in this text file. And in my program, I updated it to a .NET 5, so we have a top-level program. But it's doing the same thing. It's creating a Spark session. It's grabbing a file. It's doing the word count, and it's stopping. Now, if I hit F5 right now, we can go ahead and see what's going to happen. It's going to build. It's a typical .NET project. It's going to try to run it, and we're going to immediately fail because there's no connection to be made. There's no Spark running on my system. It has nothing to attach to. I have a Docker extension here, and all I did prior to this was I did a Docker pull on this .NET Spark image. So I have that Docker image on my machine. So what I'm going to do is right-click from Visual Studio. Actually, I need to get to the tag and go ahead and tell it to run that. So it's going to launch that Docker container for me. And you can see the containers up here now. And I'm just going to do one quick thing in the terminal. This job is going to run inside of the container, so it needs to be able to see the file that we're counting. So I'm going to do a Docker PS, which shows me the running containers. And then I'm going to do a Docker CP, which will copy the .NET text file to the container. And I'm just giving it enough to uniquely identify the container. And it's .NET debug is the path. So all we've done is we've just dropped that text file into the container. So I'm going to pop out of this, and I'm going to do the same thing I did before, and that's hit F5 and run this. And what's going to happen now is because that container is running on a known Spark port, that Spark session is going to be able to actually request the session and start a session. You can see I've had a breakpoint, and we've stopped on my breakpoint right here. Right now, the words are null. If I do F10 to step over, now we've got a data frame here inside of the words. Let's do the show. We'll step over that, and I'm just going to expand my console so we can see the output. And there's our word count. And obviously, it's from the .NET Conference site, so we would expect but that's just an example of things we're doing to close that inner loop. I was able to .NET New, type in a program, run a Docker container, and have that Spark experience right away. I'm going to turn it back over to Rahul now.
Thanks a lot, Jeremy. Wasn't that wonderful? Our contributor, Martin, when he showed us that particular how he actually built some of that Docker pieces, it honestly blew our mind. And that's one of the really cool things about open source as well, right? I think the project, the .NET for Spark project, builds quite heftily on the shoulders of many of our contributors who have taken a lot of time to contribute some really awesome pieces into the library itself. And now I will take a moment to explain like some of these pieces, essentially, like specifically what are the updates that we would like to kind of give to the entire community itself. First, there's also like a pretty hefty contribution that came out, which is support for Spark's MLlib. And you should really check this out. I will not do justice to explaining any of the stuff because I'm not a machine learning person. We build platforms for machine learning, but I highly encourage that you folks, if you're interested in how would you do machine learning in a distributed fashion, like using Spark's MLlib implementation of machine learning algorithms, we highly recommend that you check out some of the new contributions that came into .NET for Spark. The second piece is, over the last 2 years, we've been working extremely closely with some of the massive teams inside Microsoft. One to specifically name is the Office team. And there is a team called MSAI, which is responsible for Microsoft search, assistance, and intelligence, and everything that powers some of the really cool new features that are coming out of Outlook. And one of the things is they are now using .NET for Spark in production consistently well for the last year or so, running regularly on workloads of size pretty much 50 terabytes every couple of days. And that is just one team. There are many other teams that have adopted inside Microsoft, and that's what has given us ultra high confidence that, yes, I think this library is ready for production use. Yes, we will still find like a couple of bugs or two, but we did manage to get a number of people tell us that they truly love the experience that they end up getting with .NET for Spark. And that is the main thing that has given us the confidence to release the latest version, and that's version 1.0. On behalf of the entire team, I would like to announce the .NET for Apache Spark latest version, which is version 1.0. It comes after a lot of hard work from all the community members and almost like close to 300 pull requests that have been merged. There are 42 project contributors, and we've had like a number of NuGet downloads and GitHub stars. So thanks a lot to both our users for reporting all sorts of problems and also our contributors. And rest assured, this is exactly the same pieces that are also made available in some of our newer products that we're releasing called Azure Synapse Analytics, which I will give you a very brief introduction. But before I go into that piece, I do want to kind of call out all of the community members. Thanks a lot, folks. Like without the help from each and every person listed here, and also some of the people that I may have subconsciously missed, this project would not have really reached this particular milestone. And for that, like the team and myself especially are eternally grateful for all of the help. And added to that, one of the really awesome things is the library is cross-platform. It works on Windows, Ubuntu, and Mac, and it's also cross-cloud. It works with pretty much like every other cloud provider that you can imagine, like who offers Spark. Yes, you may hit into like a problem or two, but that's because like we don't really have visibility into how the Spark runtimes are evolving in each of these cloud providers. But you will see that our team is extremely active on GitHub. I highly recommend that you come and chat with us on GitHub if you have any issues with anything that's running on any cloud, no matter what. Having said that, I also want to take a brief moment to just, stick this in here, which is Azure Synapse Analytics is one of the latest products from the Azure team, which allows you to do pretty much anything that has to do with data management or big data in like a super simplistic way. And .NET for Spark is available as a first-class citizen. Why do I say first class? Like, why not the demo that I've shown you or like the one that Jeremy has shown you, right? Let me take a moment to explain briefly what exactly I mean by first class. So Synapse is a huge ecosystem. And today what we're going to do is, obviously, I will not have time to talk about everything inside Synapse, but feel free to ask me any questions in like the Q&A. But we will be talking about the specific Spark portion right here. So with this, let me just deep dive into Synapse just to show you what you will end up getting. All I've done is before this demo, you can go into this piece, you can just type Synapse here, and you can create a workspace. And your entry point into everything starts with the Synapse workspace. So once I've created the workspace, this is my workspace. This is the homepage that you're going to end up seeing. You can click around everywhere. It's really a pleasure to explore Synapse. Honestly, like I'm really thrilled that we as Microsoft are actually building a product like this. And if you start looking into some of the experiences here, what I can do is I can go into develop and I can start writing notebooks. And you will immediately see that once I click notebook, this is what I mean by first class. What you can now do is you can basically select .NET Spark. And for this, I'd like to call out huge kudos to the .NET Interactive team. We've worked very hard with the team very closely over the last 1 year to give you a first-class REPL experience. You can start kind of just writing C# code right here. And everything will just work as expected right there. Of course, I'm not going to show you console.writeline, but there is a very awesome guide that I recommend that you check out. And everything is documented right here. All the links I'm going to show you. But as Jeremy was hinting at, you can use the whole power of .NET ecosystem that's out there. You can install NuGet libraries, and I can show you very quickly in terms of the experience that you're going to end up getting inside the notebook itself. One of the cool things is you will be able to use this semantic called #R. Like you can see, of course, I'm jumping way ahead, but you can see I can plot, I can do some really crazy things inside this REPL. And what you will also notice is, there's not really any features that are missing right here. And of course, you can extend things in ways that we have not even imagined in the first place. And if you go in, you can also use some of the latest developments from the community in the form of Apache Arrow, which is more memory optimized for transferring data from the Spark runtime into your C# runtime. If that's not your thing, and if you just want to install some libraries from NuGet, you can do something like #R, specify the name of the library, and you're good to go. Essentially, you can basically register it as a user-defined function. And look here, right? I'm actually doing some matrix multiplications right here, and I'm calling all of that code using Spark. And that should give you hopefully like a brief intro to the power that you end up getting with these kinds of integration. And with that, let me switch back here. I'd like to conclude this talk. I'm very, very happy to take like any questions for me. I've included a bunch of links here. If you are curious, like what can you actually do in order to immediately get started? With that, I'll open this up for a Q&A. Thanks a lot.
All right, thank you all so much. Really appreciate you sharing that stuff with us. And Jeremy, that information you shared with like the metrics and whatnot was really cool. But I do want to remind you, man, like friends don't let friends right-click publish, right? So make sure you use your CI/CD. Kind of like how don't let friends use tabs over spaces. We don't allow that kind of stuff over here. So that being said, we do have to keep it going. We do have a few questions that y'all got, but we don't have time to get to those at the moment. So Jeremy and Raul, if you don't mind, probably like after you get off, would you mind heading over to Twitter, answering some of these questions that these folks have asked? Like, there's a lot of great questions here.
Yeah, I see Twitter right over here. I'm gonna head over there right now.
Yeah, like just go over, just knock on the door and tell them I sent you, and then we'll be good to go. Right? Awesome. But again, thank you all again so much for that presentation. And now we're going to keep it moving. We're going to roll over to the next one. And coming up next, we have Mike Roussos. And Mike is going to talk to us about how we can collect ASP.NET Core performance traces with a Kubernetes cluster. So that sounds really cool. So Mike, why don't you go ahead and take it over?
All right. Absolutely. Thank you very much. So yeah, I'm Mike Roussos. I'm a software engineer on the .NET customer engagement team. And we're going to be talking today about tools you can use to collect performance information on your .NET apps in Kubernetes. And so we'll jump right in, look at some of the tools. And I should point out, even though this is called ASP.NET Core performance tracing, because that's usually the type of app you're going to have deployed in a Kubernetes cluster, there's really nothing here that's ASP.NET specific. These tools work on .NET Core. So there's a variety of tools that you want to look at when you're trying to understand the performance of your app. The primary ones you're going to want to use are the .NET CLI tools, things like .NET Trace, .NET Dump, and so on. I've got those listed here. If you're not familiar with them, just briefly, the way these work is you use the .NET Core SDK to install them, and then from the command line, you can run them as .NET CLI tools, and they gather information on the processes that you're running. So .NET Trace is useful for collecting performance traces so that you can understand where your app is spending time. You can understand things like how often the garbage collector is running. You can see perf counters for information on threading and so forth. And so that's a really useful one. Another tool that complements it well is .NET Dump. .NET Dump allows you to capture a dump of a process so that you can see the heap and what's happening in memory. You can look at sort of where the call stacks are for each thread when the dump was captured. You can see exception information. And so that's kind of the second one that we use a lot when we're debugging issues with customers. A variant of .NET Dump is .NET GC Dump, and the only difference between them is that .NET GC Dump only captures the heap information, so all you see is what's happening in managed memory. But the benefit you get from that is that those dumps can be analyzed cross-platform. So you can take a dump that you captured with .NET GC Dump, and you can open it up on a Windows machine using Visual Studio or whatever tools you like. Whereas with .NET Dump, you get the broader context of the app. You get the managed memory information. You also get call stacks, exception information, and so on. But you have to analyze those dumps on the same operating system they were captured on. So those are sort of the differences there. And then a couple other tools, .NET Counters will show you sort of perf counter information live. So this can be a useful first tool to run when you're analyzing a problem, because you can run it and it will show you things like, in addition to just like CPU usage and memory usage, it'll show you .NET specific information as far as thread pool count. It'll show you different GC generation sizes. You can get information on ASP.NET Core response times. And so it's a good way to sort of look at a dashboard and understand at a high level how an app is performing. And then an interesting one that a lot of people don't know about is .NET Monitor, which is new. It's still in preview. So this isn't quite ready for prime time yet, but it's in the works. .NET Monitor will set up HTTP endpoints in your Kubernetes pod so that you can diagnostic artifacts. So once you've got .NET Monitor running, you can make an HTTP call to request a dump or to request a performance trace and so on. And so again, this one's still in preview, but you know, if we've got a blog post which has been out for a number of months, so some folks have probably already seen it, but we'll keep you posted on the .NET blog as this evolves, so you can sort of look at this as another option. I'll just move this back over here. So those are kind of the primary tools. Now, in addition to the CLI tools, you may also need to use things like perf collect or create dump. And these tools are a little bit more challenging to use in a containerized environment because they require elevated permissions, which isn't always something you want to do in your Kubernetes cluster. But these tools have the benefit of also capturing native information. So all of the CLI tools can run easily without having to be elevated, without any special environment variables, but they're only going to capture the managed state of your process. If you use something like perf collect, that's going to be analogous to .NET Trace. So you're getting information on performance tracing, you're getting your perf counters and so on, but you're going to need elevated permissions to do that. Similarly, create dump is analogous to like .NET dump, but it has the benefit of getting both managed and native call stacks and memory information, but it has the downside of requiring elevated permissions, which may be problematic depending on your environment. So these are a lot of tools. I'm going to kind of go over some of the pros and cons of each of them in more detail, and then we'll do some demos and show what it looks like to use these in a Kubernetes environment. Oh, also, I have this environment variable com+ debug enable mini dump. That can be useful because when you set that environment variable, it informs create dump that you want to automatically capture a dump anytime a managed process crashes. So if you have some sort of intermittent crash that's killing your containers, you can use this environment variable to have create dump automatically capture dumps for you when you hit an exception. So those are some of the tools that we're going to be looking at, and some of the ones that if you're not familiar with, you want to go search for. We've got docs for all of these on docs.microsoft.com, and you just want to familiarize yourself because these are the best tools for understanding what's happening in your .NET Core process. Now, when we talk about using these specifically in a containerized environment, there are some specific challenges we want to keep in mind. One of them is deployment. Because the CLI tools are installed with the .NET Core SDK, it can be a little bit tricky to get them into your containers because typically your production containers won't have the SDK installed. You'll just have the .NET Core runtime. And so you'll want to think about this ahead of time. In some cases, you may want to actually install the tools when you build your Docker image so that they're all ready to go in case you need them. Just having the tools present won't slow anything down. They will make your Docker image larger, though. Each of the tools on this slide, .NET Trace, .NET Dump, so on, they each take about 10 megabytes. .NET Dump actually is the outlier. It's 50 megabytes. All the rest are 10. This one's 50. So you want to bear that in mind because depending on how sensitive you are to image size, that may or may not make sense. If you don't install the tools ahead of time, you'll want to be able to copy them on as needed. So to do that, you'll typically spin up another container using the same base image. So you make sure that you've got the exact same image of .NET Core so that you've got the same OS underneath, but you'll have the .NET Core SDK in this image instead of the .NET Core runtime. And then you can install the tools. And once they're there, you can just xcopy deploy them. I'm going to show you that. It's very easy. You just copy the binaries. But because they're typically installed with the SDK, it's a couple extra steps. Okay, and so that's going to apply to like .NET Trace, .NET Dump, things like this. For some of the other tools, they're easy to get on there. In fact, Create Dump comes with the .NET Core runtime, so it's already in all of your Docker containers, whether you knew it or not. The challenge with these ones is you have to run with elevated permissions. In the case of perf collect, you have to have some environment variables set. So I'm going to walk through this in more details, but those tools often will require you to restart your container with different privileges or with different environment so that they're going to work. So they're easier to get on the box, but they're a little bit trickier to use. So just kind of walking through these in more detail here. When you're talking about collecting a performance trace so that you can understand where time is being spent, maybe you've got a bottleneck, maybe you've got high CPU usage, The two tools you want to look at are dotnet trace and perf collect. And I've tried here to sort of summarize why you might choose one over the other. Again, dotnet trace is going to be the recommendation typically because it's the easiest to use. You don't have to have any sort of special privileges, but the downsides are that it's managed only. You can't use it with .NET Core 2.1. And if you were to try use this from a sidecar container, which is another scenario I'm going to talk about, running from a sidecar container, all of the .NET Core CLI tools like .NET Trace, .NET Dump, and so on require access to the temp directory of the container where the .NET process is running. So if you don't run .NET Trace in the same container as the app, you're going to have to make sure that the temp directory is shared between your containers so that it works. Perf collect, on the other hand, like I already alluded to earlier, is going to give you even more information because it shows you both managed and native portions of your app. It, in fact, can show you multiple processes at the same time. So if you have a cross-process perf issue you're trying to track down, you probably want to use perf collect. But you're going to need to be running with sysadmin capability, which I know some folks don't want to do in their containers. There's also a couple of environment variables which need to be set before your .NET Core app starts. So you may need to restart the app or restart the container with different environment variables if you need to use perf collect. Similarly, if you're going to be using .NET Dump, .NET Dump, .NET GC Dump are sort of the recommendations here, again, because of their ease of use. If you can use them, this is what I'd recommend you go with. And again, the only difference between .NET Dump and .NET GC Dump is where you can analyze the dumps and how much is contained in them. But if you need to fall back to create dump because you need to see both managed and native portions of the process, that's an option. And it's super easy to deploy because it's already present. But now you need to make sure that your app has, or your container has started with sysptrace capability. So that's something that you sort of need to keep in mind when you're using those tools. So again, these are the tools you'll want to be looking at. These are some of the things you want to keep in mind. And I want to spend the bulk of our time here just sort of walking through them to show you what it looks like using these in a real world environment. So I'm going to switch screens here over to my my terminal, and we're going to test these out. I've got a Kubernetes cluster already deployed. So if I do a git pods, you can see I've got one pod running with 2 containers, just called test app. It's not running anything interesting. It's got an ASP.NET Core 3.1 app. If you were to do this with .NET 5, the story is exactly the same. I'm using 3.1 because it's an LTS. A lot of our customers are still on, but .NET 5, newly released, awesome, really exciting, and definitely worth checking out. The process is going to be identical, so you don't need to worry whether it's 3.1 or 5. Anyhow, the app is just a simple ASP.NET Core app with a background service just running in the background, eating up some CPU, so there's something to look at in a trace. Okay. Now, because we don't have something like .NET Monitor out of preview yet for us to do this remotely with HTTP requests, the easiest way to profile is just to exec into your container, exec into the pod, and run the tools locally. So in this case, if I wanted to collect a performance trace, I would just do a kube control, exec, and make it interactive, and then I give my my pod name. And because this pod has multiple containers, I need to specify that I'm going into the test app container. And then we'll just jump into a bash shell and go from there. Now, in this case, it's going to be really easy for me to run .NET Trace because it's already present in my container. That's because I sort of did the hard work ahead of time by making sure when I built this image, it already contained .NET Trace. So let me show you that. This is my Docker file. Most of this is going to be a super standard Docker file for an ASP.NET Core app. We've got our base image, which is just based on the ASP.NET base. We then have our build image based on the .NET Core SDK, where we do things like restoring, building, and then publishing our app. And then we just copy it over into that ASP.NET runtime image. So that's all pretty boilerplate. The thing I did that's different here is that we're running .NET Tool install on .NET Trace and some of the other ones in case we wanted to use them. And this is the thing that's extra here. And if you can spare 10 megabytes in your Docker image, it's sometimes worth dropping in .NET Trace or maybe even .NET counters so that they're there if you want them. Because since our build image has the SDK present, we can do this and it installs the tool. Then once we're publishing, we just copy everything from the tools directory into our runtime image, into our final image, and they're all ready to go. Because like I said, installing these tools is as easy as copying them. So if I come back over here and we go into that tools folder, let's see, what do I call it? Tools. Now it is important that you look at all files, not just what's visible, because if you just do an ls, you'll see .NET Trace, you'll see this exe here, but that's not the only thing you need to copy into your container. When you install the .NET CLI tools like .NET Trace, .NET Dump, and so on, you get the exe, like .NET Trace, but that's just the entry point. There's also a .store directory where we've actually got a lot of implementation details. So whether you're doing this when you build your container, or if you're going to do this after the fact and install the tools in a separate container or on a separate Linux machine and then copy them over, make sure that you're copying this store directory also, because that's necessary for the tools to run. But having got the tools onto the container, that's really the only hard part with the CLI tools. Once you've got them in your container, as long as you're only looking at the managed portion of your process, you're good to go. You can run them by just doing a .NET Trace maybe start file. Okay, we see process ID number 6 is my .NET process. So that's the one I want to collect a trace for. So I'm just going to do a .NET Trace collect, and we'll do it on process 6. So we do that, and now it started collecting. So at this point, it's profiling the app. It's getting information on how much time's being spent. It's collecting perf counters and so on. So at this point now, we would apply load to our site, make sure we're hitting the interesting code paths. Usually once you've got 20, 30 seconds of a trace, that's going to be sufficient as long as you've got interesting traffic coming in. So at that point, we can hit enter or Control C to be done. It finishes up, zips everything up, and now we have this trace.net trace file, which we can open in Purview. Now, one of the drawbacks to doing this on Linux is that you can unzip this and pull out some stuff that you can analyze with the perf tool in a Linux environment, but the best way to analyze these is using Purview, which is Windows only at the moment. So in order to analyze this trace, we're going to jump back out of our container, and we're just going to copy this locally. So we'll do a kube control, copy, and we'll copy from the test app container. It was in tools, trace.net trace, and we'll just put that here in a folder I've got set aside for that. And again, because I've got multiple containers in my pod, I specify that this is coming from the test app container. So we do this. It copies the performance trace from my cluster locally. Now I'm on my Windows machine. I can run Purview, and we can go ahead and open it up. Now, if you're not familiar with Purview, it's definitely worth learning. It's a very powerful performance analysis tool. It's been around for a while, so folks who are coming from the .NET Framework side may have some familiarity with it. But you can go out to github.com/Microsoft/Purview. It's all open source now. And we've got some links there to tutorial videos, some useful blogs. So if you're not familiar with the tool, definitely go check it out. It's worth learning. And I'm not going to dive way into this because I don't want to get too sidetracked from gathering the data, but you would bring this over here, you'd open it up in Purview, and now we have access to the various events that happened. We've got our stacks, so we can come in here, try to figure out where we're spending. Let's look at our CPU time, perhaps. We'll drill into that, look at callers, and pretty quickly we start to discover that, there is, especially if I take off the filter, it'll be more obvious. See in here that we've got something called spin service, spin for a second. This is an API that I have running as a background service in my app that's just continually checking the date time and waiting in a tight for loop. And it's really just burning CPU. But, that shows up in here because we've gathered this performance trace. So that's one option. The other option would be to use perf collect, which I want to move on to the dump debugging because I want to make sure I cover that one as well. But perf collect ends up being similar, but you have to make sure that you're running with a couple extra permissions. And we'll see that also with the dump debugging. So we'll get a little bit of that in a minute. So let's take a look now at how, if we wanted to gather a dump for that process and understand what was happening on the heap, or to look at specific call stacks. So for that, again, we can we can go into our Kubernetes cluster again. We can exec in. Now this time, I could go into the test app and I could use .NET dump because I've got that tool there. But let's suppose that we want to use create dump because we want to see both managed and native memory. And we want to get that broader view. Or this would be the way you would do it if you wanted to run perf collect, if you want to use one of these native tools. In that case, we could jump back in where we were. In fact, I'll do that and I'll show you what happens. But it's not going to work because it needs additional permissions. So if we come in here, and now, again, the one nice thing about if we use create dump to get a dump is that it's already present. So if I just take a look, let's see here. If we copy this path, make sure I get it right. If we look next to the .NET Core runtime, create dump's already there. So we just go to user share, .NET shared, your runtime folder, the version. The create dump's already present. But in this case, we're not able to run it because we're not running with proper permissions. So even if I do this, we get permission denied. So what we can do here is we can run it from a sidecar, or we could just restart this container with elevated permissions. So let me show you the way I set this up in the Kubernetes manifest, because that's going to be sort of interesting. So we already looked at the apps Docker file. The other one that's interesting is I've got this sidecar Docker file. Now this one, it's just based on the .NET Core SDK because we're not worried about it being small. I've installed perf collect already. So if you wanted to do that, installing perf collect is as simple as just curling down the script, making it executable, and then running perf collect install. And this gets perf collect ready to go. And I'm also installing the .NET Core CLI tool, so I've got them there if I need them. But the interesting part is really in the Kubernetes manifest. So in here, this is a fairly standard Kubernetes manifest deploying my app. We've got test app, and we've got the port, we've got some resource limits. The things that are interesting are that I've also included this sidecar. And now with the sidecar, I've also added the security context section with certain capabilities. And I'm running it with the sysadmin and sysptrace capabilities. And that's going to give this sidecar container the ability to do some things that our normal app container can't. Sysadmin is going to let it run the perf tool, which perf collect is using, and sysptrace is going to allow it to use create dump to capture dumps of any processes. Now, also, when I set up this pod, I've made sure that I'll specify share process namespace is true, and that's important because that allows my sidecar container in the same pod as my target app to see those processes, see my .NET processes, and profile and debug them from a separate container. So because we've got shared namespace, shared process namespace is true, and because we've got elevated permissions on our sidecar, we're able to actually now exec into that sidecar container and use tools like create dump, or if we wanted perf collect to profile. I'll also call out that I do volume mount the temp directory. This is not something that we'll likely see in this demo, but if you wanted to use the .NET CLI tools from a sidecar, like I said earlier in this talk, you need to make sure that your temp directory is shared between the sidecar container and the test app because files get written there that they share. So that's why those are have that. So having shown this, we can jump back over here and let's go ahead and run create dump just to show what that looks like. We could do .NET dump as well, but it's basically the exact same experience as .NET Trace, so it's not terribly interesting. So we're going to exec in. This time I'm going to exec into my sidecar. And again, it doesn't have to be a sidecar. You could use the target app itself. It just would have to have those elevated permissions. Something that's worth keeping an eye on, and I think I actually had this on one of the slides, is ephemeral containers. Ephemeral containers are only in alpha right now for Kubernetes, and they're not available in AKS. But in the future, ephemeral containers will allow you to, on the fly, add a container to an existing pod for debugging purposes. And this is like exactly what we want. So it's not ready to go yet. You can't do it today. But as this comes out of alpha and gets support in Azure Kubernetes Service, kind of the dream state would be that you don't even have to put anything special in your production container. Instead, you could add an ephemeral container to its pod as needed and run these tools from there. So if we do that, let's come back over to this window. I've exec'd into my sidecar. And so from here now, we're able to actually run some of the tools like perf collect and create dump that didn't work in the other container. So we'll go to user, share, .NET, Microsoft, let's see, oh, sorry, shared, Microsoft .NET Core app version, and create dump. And this is a super simple tool to use. It sits next to the runtime, and you just provide it with the process ID of the process that you want to capture a dump for. So we do that, and it takes a couple of minutes, or maybe not, it takes like a few seconds, but it's going to now write that dump to dump temp/core dump.6. We can analyze it using .NET Dump. The .NET Dump CLI tool is both able to capture dumps and it's able to analyze them. So we can analyze it with .NET Dump, or if we wanted, we can copy it to some other machine. Now, you're going to want to use a Linux machine to analyze the Linux dumps, unless you did .NET GC dump, which is sort of its selling point. But that's fairly easy to do. Just very briefly, and then we'll sort of move over and see what sort of questions folks have. If we were to copy from the temp directory, it's called, let's see, core dump.6, and we'll just put that in our traces folder also. And let's see, we have to specify the container name. This will take just a minute to copy over because the dumps are sort of large files. But once that's copied over, we can debug it either with .NET Dump, or you can use LLDB as a Linux debugger that's good for debugging dumps that are captured from Linux operating systems like Ubuntu or whatever. And so let's see if that's copied yet. So it's still copying. But what you'll want to do is you'll first use the .NET symbol tool to make sure that you've got all of the files you need. And we've got docs on this as well. So again, if you go out, if you search on the internet for Linux dump debugging .NET Core, it'll take you to our Microsoft documentation where we explain this process in more detail. But basically, you use .NET symbol to make sure that you've got the DAC, the core CLR, the various things that you need, depending on where that dump was captured. So I'll do that first. So now it downloads a handful of files, because when you open up a Linux core dump and want to debug it with managed debugging, you need to have the DAC, the host, the core CLR. And so this .NET symbol tool will actually download all of those for you. And actually, I tried it before the dump file was copied, so it failed. But now the dump file is actually copied, so we can do this. We'll copy these files down. Should only take just a short time here. And then once you have those locally, you're able to just use LLDB and SOS to actually open it up. Okay, so we've downloaded the core CLR, the DAC, DBI, and the host. So then at this point, we'll run LLDB, we'll give it our core dump, and we'll give it the host, which is .NET. Now you're able to use SOS commands the same way you would have in WinDBG or something like that previously on Windows. So you can do things like dump heap.stat to see everything that's on the heap, for example. And this will show you, there we go. Now we can see that strings and bytes are taking up most of the heap, as always. But anyhow, I know this was a super quick demo. There's a lot to cover in this topic, but I just kind of want to show you what's out there. And again, we've made a real concerted effort over the past few months to beef up documentation on these tools. So if you want to dive in more, just go out to docs.microsoft.com, search for, debugging in containers or Linux debugging on .NET Core, and you'll get docs. But these are the sorts of things that you'll be looking at, and hopefully this gives just a kind of brief idea of how they work. So with that, I haven't been watching the chat window. Let's see, do we have any questions?
All right, thanks, Mike. We do have some questions for you.
Okay, awesome.
So let's head over to the tag board. And this one's from Robert Emmett. And Robert is asking, can .NET counters be used as an equivalent way to use Win performance counters in macro Linux environments? I'm assuming it uses event counter APIs.
Yes. So .NET Counters works cross-platform. It doesn't actually use perf counters since they're Windows only, but as you point out, there's event source event counters, which are in .NET Core, the cross-platform replacements. So .NET Counters works everywhere. In fact, well, I don't want to spend too long on this one. So the short answer is yes. If we run out of questions, I'll demo .NET Counters. But yeah, absolutely cross-platform, and it's a useful replacement.
All right, great. So that was our only question, but we do need to move forward and head over to the next speaker that's coming up really quickly. So Mike, thank you so much for coming on and sharing your stuff with us. And, you know, folks are on Twitter. If you head over and you check out the hashtag .NET Conf, you know, there's tons of questions that are on there. So, you know, definitely please head over there. And, you know, if there's any additional questions, please make sure you know, give everyone some attention.
All right. Yeah, absolutely. Thank you very much.
All right. Thank you so much, Mike. And right now, coming up next, we're going to have John Gallant. Now, John has a really interesting presentation. He's going to be talking to us about secretless development from local to cloud with the new Azure SDKs, Project Ty, and Kubernetes. So it sounds like there's a lot of cool stuff in here, John. So I'm going to go ahead and let you take over.
All right, great. Thank you. All right, so I'm John Gallant. I'm on the Azure SDK team, and I do a bunch of work with Azure Developer Experience. With things like Project Ty and deploying to Kubernetes, I work with Storage Explorer, Azurite, a bunch of these tools that surround the developer experience. And a lot of the things I do, I build apps, and I learn a lot and give that feedback to the product teams, as well as work with partner teams like Project Ty. So today, what we're going to cover, let's go to the next slide here. Three big things. The new Azure SDK, we heard Jeff talk a little bit about that. The new preview Project Ty, and how that all relates to Azure Kubernetes. So a quick mention about the new Azure SDK effort. Please go back and view Jeff's talk earlier. But the gist of it is that it's all about developer productivity. So what we want to do is help improve developer productivity for our team, as well as anybody using Azure. So when we joined or formed the team a couple of years ago, we looked at the landscape of the Azure SDKs, and we discovered that they're spread out amongst many repositories. So we have, I think, dozens, maybe 100 repositories out there with all the various languages and services. It was really hard to keep track and didn't have a consistent experience, which means developer productivity dropped. So what we wanted to do is say, how can we improve things? And we said, let's have consistent language support, consistent OS support, a consistent CI/CD pipeline, as well as consistent package delivery to all of the mainstream package managers. So you can see at the top, it's kind of chaos, what we adopted, and the new is the bottom is what our aim is to go to something much more consistent, much more predictable. And so we have all of these design guidelines that we'll talk a little bit about later, but they're all open source, and we'll reference those. So to get to the main SDK website, go aka MS-AZ SDK, which we'll take a look at in a minute. And then a 3-minute video that I created, aka MS-AZ SDK/intro, will bring you through that in much more detail, as much detail as we can get in 3 minutes. So what we're going to talk about today is how we can use Azure SDK and Ty together to build secretless applications. And by secretless, I mean the only secrets that are stored are in Key Vault. So local development as well as cloud development, you are not storing or having to manage your own service principals. And we can do that through the new Azure Identity Library, which we'll talk about in a minute. And so locally, we are using Azure CLI, the credentials that you already have. And in the cloud, we're using managed identity. And any other secrets, like I said, are stored in Key Vault. So how that looks is like this. So the new Azure Identity Libraries provide us with this object or this class called the token credential. And we have a slew of classes that are derived from token credential, and token credential basically gets tokens. And so from a developer experience perspective, you have the Azure CLI credential, you have VS Code credential, you have Visual Studio credential, and a slew of other developer credentials. So for Java, we have IntelliJ credential, for example. So for .NET, we have those three plus environment variables, plus interactive browser control, a ton of these credential types available that you can use in your application. And so what that means is that when you're already logged into one of these tools, you'll be able to use that identity to authenticate with Azure. So for example, if you're Azure CLI, you do AZ login, you assign roles to your principal, to your account, and then you access say blob storage. And in production, you use managed identity. So this is a quick code example on what Azure identity looks like. We have var cred equals new default Azure credential. So default Azure credential is an opinionated chain token credential. So what that means is it first looks for environment credential. So look for Azure _client _ID _client _secret and tenant ID that you have stored in environment variables. It'll look for managed identity and then a slew of developer credentials, Azure CLI and so on. So it's an opinionated way of building, a chain token credential, which you can see on this the next line here is an example of a custom chain token credential. So if you don't want to use Azure credential, you want your own chain, you can build it however you like. So you have managed identity credential here, and then Azure CLI. So what this does is it will first try managed identity credential, a fast fail. If that fails, it will try Azure CLI credential. If it can't find it either, it will just fail. And then as you can see, getting back to the consistency and productivity part of things, you can see that the last line there is new secret client. So all of our clients, all of them that support OAuth and token-based authentication, accept a token credential as one of the parameters into the constructor. So you see URI here, that's the URI to your key vault. And then credential is one of these objects that you've constructed. The clients are smart enough to know when it needs a token. So you don't have to get a token at a time. You just pass that in. It will call get token on that token credential object and be on its way. So let's take a quick look at a quick breeze through. This is the app we're going to look at a little later. Take a quick look here. So we have the Azure SDK website. So this is AZ SDK, AKS MS AZ SDK. So all of the releases here, you can see that we have a lot of packages. So when we built this website back in November of last year, I think we had 7. Yeah, it's continuing to grow. These are the libraries that follow the new design guidelines. As you can see, we have many that are in GA, and we ship betas continuously. We ship monthly. So you can come here, you can find all of the new client libraries, all the new resource management libraries, which are in preview for .NET. And then this all tab, I've been working hard on this, but this is all of the libraries that have ever been published for Azure. There's a lot of them out there. What we're trying to do is, as part of our inventory, is collect them all. And we decided to just open source all of them so you can find, so this is like the de facto list of repository of packages. And we have the same across all the languages. So let's just take a look at the website. So up at the top, we have blog. So let's just make sure that you are subscribed to our blog. And we have weekly posts, sometimes twice a week. And we also have guest posters. And so we're, if you have a good experience with the Azure SDK or want to, share your experience, please do contact me, and I can set you up to be a guest blogger. Daniel Krzyzkowski did a good post. Mike McCall did one. We have a lot of good posts out there that you can go and follow up and read on. So also from this website, we have all the guidelines, open source, published, right there that you can review. You really shouldn't have to, but sometimes it's good to go and reference and see, what were the design decisions behind the libraries and so on. And also we have the releases page, which is this, and we have the API reference, which we'll talk about in a second. We have this GitHub link here, which takes you to the central repositories. It links to everything that we create are here. So we call this kind of the landing repository. It's a good one to go to. And then obviously we're on Twitter. So Azure SDK, please go follow us. right now, and we post quite regularly about new SDK stuff coming up. So definitely good to subscribe there. So let's take a look at a scenario. Say you're looking for the table client. You come here, you click on client libraries because you know you want the latest one, and you find table. Okay, so then you see the tables is in beta right now, beta 2. We have Microsoft Docs, we have GitHub Docs, and we have the source code all linked there. So if you wanted to install it, you click the NuGet link, you add a package however you'd like through the .NET CLI, package manager, or what have you, and then you go here. These are the official Microsoft documents for the client library, and it contains the latest version, a preview version, and the old version. So what we did is we currently this platform doesn't support every version ever published. So what we did is we created a website like this that publishes every version of the library documentation. So if you happen to be on a version that is not mainstream, we hope to provide that documentation for you. But eventually those will be merged, so you don't have to worry about that. And then we also provided a link directly to the source code from that releases page. So if you have to debug something, you want to research something, or whatever you need to do with that. Okay, so let's switch back over to slides. So that was just a quick introduction there to the Azure SDK. So let's talk a little bit about this app I've been building. So I wanted to build an app that uses many of these Azure SDK libraries as possible, and something that we can continually grow on. So if we have a new library come out, we could integrate it into the apps. And one of the libraries that we support includes extracting text and analyzing sentiment. And I thought, what better way than to extract text from memes and decide if they're positive, negative, or neutral memes. So I created Memelizer. And this is all open source, John GIO, Memelizer on GitHub. So let's talk about it. So you click the plus sign under the logo. This is not currently public because it's easily hacked, and I didn't want the risk of having images out there that were not safe for kids. So when you click plus, it will add a random meme from Reddit to the list here. It will extract the text, determine the sentiment of that text, and then change the border color. So green is going to be positive, yellow is going to be neutral, and red is going to be negative. So my kid actually uses this. He'll come here, he'll click plus and just read memes for a bit. He finds it entertaining. So there's some value here. So the goodness behind the funness is this architecture here. And so what we have here are a Blazor WebAssembly web app. So I tried to use all the latest and greatest stuff in building this. So Blazor WebAssembly has been a treat to work with. ASP.NET API, a .NET service, which is actually just a console app that runs in a container, as well as an Azure function. And so how that works is you post an image. See, number one there, you post an image to the API. The API adds it to blob storage, adds it to a queue. The .NET service receives those messages, extracts the text. Number 6 gets the sentiment, saves the document, and right now that we have a data provider model, so we can try the new Cosmos library or the new tables library. And so there's a switch there that you can turn off and on through configuration. And then once that's saved, it goes back to another queue, back to the Azure function, signal our service, and then back to the Blazor front end. There's obviously many ways you can build this app. You can do functions, you can do whatever you want. But I wanted to build something that uses as many of the libraries as possible. As speaking of libraries, so I mentioned the Azure table library that we are in beta. Let's take a look at this next slide. I think you're going to find this interesting. So I've been working a lot with the storage team to get us to a point where we can ship Azurite with table support. It's been a huge ask to the community. For those of you who don't know, Azurite is a cross-plat Azure storage emulator. It's had blobs and it's had queues for a while. And if you wanted to use table, you had to use like an old version. And so a kind of very bad experience. So we worked hard to get a preview one ready for today. And so now the app is all running on preview 1. Azurite is running, so I'm saving the table storage. I pushed out a sample at John GIO Azurite-table-type. Go take a look at that. Please use it. Let us know if it works or not. We're also working hard to get that to work in durable functions. So coming soon on that. So let's go and take a look at how we're doing secretless in the Memelizer codebase. So this is an identity class here. This has a chain token credential, and I'm calling get credential chain. And this is shared amongst all my clients, so you can reuse this. And I am saying I want to use managed identity and Azure CLI credential, just like we saw in the slide earlier. Okay. Then when I new up my clients, I have my data provider and I initialize it based on some config value. I initialize my data provider and I pass it that same credential that I initialized up here. I then initialize my other clients. So I have app config, I have blob, I have queue, I have another queue, I have form recognizer and text analytics, all using that same Azure CLI credential for local. And then in the queue service, you just new up that client, initialize async, and then you can access your clients that way. So this right. So all I had to do locally is just AZ login, and this just works. Inside of my Cosmos data provider, how I have no secrets is when I want to get my Cosmos key. So Cosmos doesn't officially support, Azure Active Directory or OAuth. So what we need to do is store the secrets somewhere. We don't want to store it in application code at all. So we want to put it in Key Vault. So I'm using that same credential. My credential has the appropriate permissions to access Key Vault. I'm getting that secret name. And then when I new up my Cosmos client here, I'm passing it that key. I also took it a step further. So I've been playing with functions a bit. And I realized that functions, can use some work when it comes to the secretless development paradigm. They, expect you to store your settings in local settings or environment variables. But for locally, what I wanted to do is, store locally and production, store my secrets, connection strings in Key Vault. And so what I'm doing here is inside of the function startup configure method, I am calling Key Vault using the Key Vault clients. I am getting the secrets, and then I am setting an in-memory collection here, and then adding those to environment variables, and then the client sync function just automatically works. So let's take a look at that here. So you can inject regular environment variables into the bindings like so, and you can also pull this from an environment variable here, which I set in my startup. So a super good way to integrate Key Vault into Azure Functions, okay? And then just quick look, this is my .env file. It's super simple and it works across all of my applications. So whenever I load an app, I always just load my .env file. Also, this is all Terraform. So all the Terraform scripts are up there that you can steal, use in your own apps. But I just have a couple of variables here. So there's no secrets stored in my code at all. Okay, so let's jump back to the slides. So the next big thing that we're going to talk about is Project Ty. So as I was bringing my app to Kubernetes, I discovered that, wow, it is very difficult to do inner loop Kubernetes development in the current state. There's so many tools and so many YAMLs. And just the cognitive overload is crazy. And so what I did was I did a phone a friend a lot. So Vita has been helping me out. Noel has been helping me out to try and figure this out. But there's so many things that you have to do when you want to take an application from local to containers to Docker Compose, Azure Kubernetes Service. There's just so much. And so as I was doing this, Fowler said, hey, check out Project Ty. I did, and I'll tell you what, I love it. It's absolutely a lifesaver, and I'm going to show you how. So basically on the left, you have all these tools. On the right, you have Project Ty. I'm going to get into this in detail. So we have all of these things that you need to do for inner loop development, right? When your end game is Kubernetes, when you know that you're going to have to ship to Kubernetes, meaning that you're going to have to containerize your app, you're going to have to think about all the Kubernetes things, you have to go through a certain flow. And honestly, a lot of people, copy and paste from existing applications that they've already built, don't know that Compose exists, don't know that Scaffold exists, and just don't know that these tools exist. So they struggle really hard to get anything going, and often just leave in frustration, which was, I was there many times. So let's talk about each of the things that you need to do and how Ty can replace them. And I'm going to switch back and forth between codes so you can see what I'm talking about. Okay, first thing, containerized projects. So with other tools, you have to create Docker files. You have to know what base image you need to go for. You need to know that you need to publish your .NET application and bind to this DLL and all of that work. And then you have Blazor, which uses Nginx. You have all which can use Nginx, and all of that is for somebody who hasn't done containers and just let's say you're a .NET developer who's never done containers. There's that step that you have to go through to learn about Docker and learn about Docker files. Eventually you should, but should you have to in order to get something running? Well, with Project Ty, you create an app and then you call Ty run, and it will automatically detect that you have an application in your directory, and it will run it just without you having to create a Docker file. Okay, so let's just switch over to that here. So this is a typical Docker file that I had to create for each part of my application, right? And so I have MCR, Microsoft .NET SDK 5.0. I upgraded all these to 5.0 recently, and then you got to do a bunch of things. You got to know to do all of this stuff. With Ty, I don't have to do any of that. I don't have to create a Docker file. Now you can create your own Docker file, totally fine, but you don't have to, and that's the point. Okay, so here, the next step, okay, so you've containerized your apps. Now you need to run them. You need to start them. You need to tear them down all together. How do you do that? It's typical to go with the Docker Compose approach, which basically it's just that. You do DC up, or Docker Compose up, Docker Compose down, and it will start and stop your services. Okay, so up until this point, yes, it's one-to-one. Ty YAML to Docker Compose, and as an aside, the team is looking at Docker Compose as potentially have parity with Docker Compose, so to make it easier to go from Docker Compose to Ty. But as of right now, there's a few differences. So what we do is we say Ty run Ty YAML, and that will give us the specifications of the applications that we want to start and stop, and they have tagging and so on. So let's just take a look. So inside of my run, so this is a simple Ty run here, right? So simple Ty run is going to by default use the Ty YAML file that's in the directory. There's a bunch of flags. We'll talk about some of those in a bit, but that's Ty run. So I just created this script called run, which wraps Ty, because Ty currently doesn't do environment variable replacement, which I need. So I have a couple of scripts to do that work for me. So let's just take a look here. So we have Ty. This is what a Ty YAML file looks like. And you can see here, I'm using that alpha of Azure, which includes table storage right there. You can tag, so you can filter. So I only want Azure for dev. You can say, I want a web app. Here are the ports. Here's what I want to bind in my container. Here's the API container ports. And it also supports ingress. So you can say, map this URL, this path to this service, even locally. This even works locally. So it's super, super nice. And this having ingress here saved me from having to do a bunch of config, especially with Blazor. Blazor WebAssembly doesn't have service discovery built into it yet because it runs in the browser. And so Ty does service discovery. I'm not going to get into it, but where you can, Ty will automatically discover your services for you. But having ingress allowed me to just minimize my configuration for that. Okay, so that's Ty YAML. Now let's take a look at the next one. So debug, debug symbols in a container. I've talked to some of the people that I trust in this space, and they just like, I don't have a way to do this consistently that I really like, and so it's not something that people do typically and do it with ease. And when you want to do it, it's pretty complicated. And so the Ty's way to solve that is to add a -- debug. And after debug, you can put a service name. You can say -- debug, Q service, for example. And that will wait. It'll spit out the process ID and it will wait for you to attach a debugger to that process. So let's take a look at that. So here in my debug, right there, I'm doing Ty run, still Ty run, right? But I have this debug down here. See that? And I'm saying, wait for this service. Pretty cool, huh? Okay, so what you do is you open up the project for that service, You attach, it'll stop at breakpoints. It works beautifully. Another option to debug is the TIE Explorer VS Code plugin extension. Sorry. So you can come here. You can click on this little bug icon here to attach to a running process. Super slick. I tried it a couple of times since I installed the extension. Works great. Next thing, scaffold or watching files. Typically you use scaffold, which is another YAML. With TIE, so what this will do is it will watch files, rebuild your containers, deploy to Kubernetes. With TIE, you do TIE run -- watch, which is pretty self-explanatory for Kubernetes files. So we want to go from Docker Compose to Kubernetes files, which you need to deploy. So you have to do, you have to use something to convert them, or you have to copy and paste, as my friends say. Compose with a K, you feed it your Docker Compose YAML, and it outputs Kubernetes manifest files. So with TIE, you don't have to worry about those manifest files at all. But if you want to, you can use the TIE generate method, which will spit out the file. So let's just take a quick look at that. Take a look here. So this is after running TIE generate. Yeah. So here you go. So deployment, all of this stuff, all the services, all of those things are all defined right there in that, including ingress. So like I said, you don't have to think about it, but it's available if you need it. Right. The next thing is deploy. So when you want to deploy to Kubernetes, you can use kubectl, you can build a Helm chart, or instead of those things, you can use TIE deploy. And that's going to talk to a container registry. It's going to build your containers. It's going to push that registry, and it's going to push your Kubernetes manifest files to the Kubernetes context that you've specified, right? So super handy. So taking a look, we have 1, 2, 3, 4, 5, 6, potentially 7 tools that TIE replaces. And I personally can't see I can't see myself going back to the old way. And I wish I would have had TIE, months ago when I started. So I hope you check it out. I hope you start there and don't have to go through the pain that I went through. So let's take a look here. Okay, so let's wrap it up. So I want you to get in touch with me, anybody else on the Azure SDK team. You can contact us. You can follow through Twitter. Give us feedback on GitHub. We are on GitHub. We have all our repositories, our issues, everything is filed there. So please do go visit us on GitHub. All of our releases, start using them, contributing to them. Subscribe to our blogs. So two big things to check out: new Azure SDKs and TIE. So thank you very much. Let's take some questions.
All right, John. So it looks like you got some questions for you. So let's get to it. First one's from Dan. Dan is asking, question for John: desktop apps can't have managed identities. How can a store app access Key Vault without storing credentials strings in source code or config files?
Yeah, so in that case, you would want to use something like the interactive browser control. What that allows you to do is to the end user would get a pop-up and say authenticate, and then at that point, if you have MFA enabled, they would follow that authentication path. So that's a good way. I know a lot of people in the identity space, but please do reach out to me on Twitter if that doesn't answer, and we can get that resolved for you.
Sure. All right, let's move on to the next one. Alex is asking, do you have any advice towards Git repo structure? For making it easier to use tools like TIE, it makes sense to combine several microservices into one repo. On the other hand, dividing in several repos makes releasing/deploying individual services easier.
Yeah, so one of the things with TIE is that you can specify as a service, you can specify other YAML files. So you can do that construction like you're talking about. For my sample app, Memelizer, I decided to put all in one TIE YAML file. And somebody else asked a question today too on Twitter, which was, how do I manage, building and deploying only certain, services? So there's a lot of these complex scenarios that I would love to dig deeper into. So all the capabilities might not be there right now, but let's hear your scenario and let's flesh it out.
All right, sure. And let's, I think we have time for just one more question. And this one is coming from Metro Developer. This person is asking, can I use Cosmos DB instead of Azure Table?
Absolutely. Yeah, you can use Azure. You can use Cosmos DB instead of Table for sure. And take a look at the Memalizer repository. I actually have a data provider in there where you can switch between the two, but it's full code for both Cosmos and Table. The Table, Azurite supports Table emulator, but Cosmos has its own emulator, if that's what you meant. Yeah.
All right, great. Well, John, thank you so much, man. That was a great presentation. I know for me, I've been playing around a lot with ties, so I didn't know until today that there was a VS Code extension. So I'm going to make sure I spend some time today and go ahead and check that out.
You got to know some people. No, it's coming.
Apparently, I don't know the right people, man. I need to work that out.
All right, thanks a lot, man.
All right, thank you so much, man. I appreciate it. And for all of you that are still here watching us, please do remember you can submit your questions on Twitter. You can use the hashtag .NETConf. Also, to make sure you head over to our website, check out the swag page. There's tons of great free digital swag that you could get. And then also make sure you go and check out our treasure hunt, which, there's tons of great prizes, lots of money to be won. So go ahead and head over there and check it out. Now, that being said, really sad to say that I do have to go. We do have another host that's going to come and take over from me, Abdullah. So Abdullah, I'm going to give it all to you, my friend. This is all yours. And I hope you all enjoy the rest of .NET Conf.
Thank you very much. Appreciate it. So I'm your host right now. Hi, I'm Abdullah. I mostly work with video games. But right now, I would like to introduce Alan and John, and they'll be talking about bringing .NET Interactive support to Azure Data Studio notebooks.
Hello, you can hear me, right?
Yeah.
Okay. Well, welcome everyone to our wonderful session here. It's a pleasure to present all the really awesome partnerships that we've done over the past 4 months between Azure Data Studio and .NET Interactive. And we really want to show a bunch of the work that we've been doing with notebooks across Microsoft through this presentation. To kind of start off, my name is Alan Yu. I'm a program manager on the Azure Data Studio team.
And I'm John Sakura, and I'm the dev lead on the .NET Interactive team.
And throughout this presentation, you're going to be able to see, at least a little bit of the ideas of why notebooks are a very important concept, and especially of having a better SQL experience in notebooks, while also being able to see a plethora of demos across both Azure Data Studio and Visual Studio Code. So let's kind of just start off really briefly. I don't want to spend too much time talking about what is Azure Data Studio, but to kind of understand the motivations behind it, the Azure Data Studio team not only works in Azure Data Studio, but also works on tools that you might already be familiar with, like SQL Server Management Studio and SQL Server Data Tools, SSDT. And what this means is that we work very closely with SQL Server and Azure SQL to go and build really great SQL experiences. Now, over time, as SQL has kind of evolved and our customer base has evolved, where they are all over the place, they're on Mac OS, they're on Linux, they're on containers. With the release of SQL Server 2017, this was the first time that SQL Server is available on Linux and on containers, which is just crazy to think about. But it also meant that our tooling also had to evolve, where, as you may know, SSMS only works on Windows. So how can we have a cross-platform open source tool that allows you to work with SQL Server, Azure SQL, and other Azure data services? So we went ahead and created Azure Data Studio, which is open source and cross-platform, and is actually a fork of Visual Studio Code. In terms of the main personas for Azure Data Studio, the main data personas are kind of like the database administrators, the database developers, and the data analysts. And it's really like anyone that's really working with SQL. And you can see that we support things like SQL Server and Postgres and eventually MySQL and as well Data Warehouse. And this kind of represents what Azure Data Studio looked like for a very long time. Now, since we work very closely with SQL Server, with the release of SQL Server 2019, this allowed for the very first time where you're able to ship both SQL Server and Spark together. And what this meant is on the experiences side, we had to think about new personas, such as the data engineers and the data scientists who need the ability to manage things like Spark jobs and be able to virtualize data for Teradata and things like that. And as we thought about this persona, we thought, what experience do data scientists absolutely need? And when we looked, we realized that we needed to bring Jupyter Notebooks into Azure Data Studio, which didn't exist at the time. And before we go into a little bit of the development and the motivations for building notebooks inside of Azure Data Studio, here are some of the principles that I wanted to share with you as we, over the last few years, tried to learn about this new world where we're not only building Windows tooling. One thing is that we want to leverage open source as much as possible. We don't want to be creating experiences that only work in the Microsoft ecosystem, but kind of think about how do we be good open source community members? How do we not only build things or take things from the open source community, but also contribute back? On top of that, notebooks is essentially, or Jupyter Notebooks is essentially an open source concept. And so that means there's so many other Jupyter viewers out there in the world. So we want to really make sure that anything that we build, we want to optimize for backwards compatibility. So if you have your notebooks, or the data scientist already has all these notebooks already, and want to use it in Azure Data Studio, that it will just work seamlessly. Or if they started and created their notebooks in Azure Data Studio, they could then go use that in anywhere else. And then finally, our engineering approach is very much this crawl, walk, run philosophy, where we want to just iterate very quickly, ship out incremental experiences, and always be talking back to our customers, getting validation from them, and figuring out the experiences that we really need to go and build a beautiful experience for. And so, for those of you that aren't familiar with notebooks, it's a concept that data scientists are very familiar with, but basically it's all about having these reproducible data sets so that you can then, basically tell a story with it. Notebooks really consist of two main things. One is that they have executable computer code cells. So in this example, if you're executing Python, you could be able to run it within the notebook and get the live output of it. And then in addition to that, we allow for accompanying having rich text cells. So you can have rich formatting that instead of just having a Python level code or code comments, you can have this rich formatting to kind of accompany and include tables or images or GIFs to kind of accompany the data that you're trying to share with anyone else on your team. And, so that's kind of what we first thought when we created notebooks in Azure Data Studio, where we need to optimize for the data scientists who need to be able to execute Python inside of a notebook. And that's kind of where we really put all of our energy towards. But as you know, and this is why I brought up SQL earlier, there's already this rich ecosystem of people that are already using the tool and using SSMS, who are the DBAs. And they saw this new experience that we're building for the data scientists. And they're like, I actually like this a lot. Can we use SQL with this? And, how can I start using SQL with this? And, they said they liked it. We showed them SQL Magic is kind of an incremental experience, but, they were kind of all telling us the same thing. They wanted to basically feel like they're writing these notebooks as if they're writing in a query editor itself. So they want syntax highlighting. They want IntelliSense. They want an interactive results grids. And having Magic wasn't enough for them. In fact, them having to learn Python was very intimidating. We're having to manage these Python dependencies. So, this helped us as a team kind of prioritize, let's not only think about the data scientists, but let's also think about the DBAs or anyone who really wants to use SQL, because even data scientists will use SQL. And so we created this kernel, which is kind of focused, it's this dedicated SQL kernel, which allows for using a lot of the Monaco features with syntax highlighting and IntelliSense and things like that, and kind of see how this lands with the community. And it turned from an experience that DBAs really liked into something that they really loved. And so this kind of triggered this journey where we had to go talk to the Jupyter open source community, because we didn't want to just build things that only worked here, but think about how do we contribute a SQL kernel back into the rest of the world. And then also always asking the DBAs about how can we introduce them more to notebooks, because it's always a challenge, even in the Jupyter community today, of how do you bring on these new users, bring them along on this journey so that they could, find a way to incorporate this into their own workflows. And so this triggered focus groups, research studies, user calls, engagement on social media or on Twitter. You could feel free to tweet this presentation on Twitter right now. And also these long GitHub threads, and just trying to figure out how can we, unify these concepts, find similarities, and work with the open source community. And this kind of triggered this, this kind of high level view of all the scenarios, looking at both for data scientists and for DBAs, where, when you talk about Jupyter notebooks, anywhere outside the context of SQL, you're really looking at notebooks for data workflows. You're looking at ML, looking at data prep, you're looking at operationalization with Papermill. But on this journey, we discovered things like notebooks as UX, where we have wizards kind of accompanying you as you're deploying Azure SQL for the first time, or having like this rich training to kind of train your team of how to get used to using a SQL server, or learning all the basic commands for it, or even using for troubleshooting. And yeah, these are all scenarios that we had to kind of keep in mind as we're building this out. So really quick here, I'm going to show a demo of Azure Data Studio in action. And this is what Azure Data Studio looks like. And I want to share this with you because I want you to kind of put on your DBA hat, understand what their world looks like as they traverse into notebooks. So, one thing that we learned from, managing SSMS for such a long time is that this is kind of right here where 90% of DBAs are spending their time. They need the ability to connect to things. They need the ability to manage things and kind of organize their connections. And then more importantly, they need the ability to write these long SQL queries, comment them, and then execute them as well. So, when they first, some of the limitations with this current experience is that, let's say that you're a DBA that wants to go share this with someone that doesn't really have the same access to databases like you, and you want to kind of just quickly have a bird's eye view of the results and which query it's from, and kind of how do I use information from your SQL query and make data-driven decisions behind it. So that's kind of where notebooks kind of was like a light bulb moment. And when we showed this to people in user research studies, they were like, hey, you want us to use notebooks? Make it so easy for me to take my existing SQL queries and convert it into a notebook. So that's what we did with the latest release of Azure Data Studio, which comes out this month, where we added this button where you could convert any of your query files directly into a notebook. So we parse the SQL query file, identify anything that are comments and anything that is the query itself, and create your notebook so that, in terms of the adoption of SQL users to use notebooks, it's as easy as a click of a button. And here, they're already within the context of a SQL kernel. We can allow them to make a connection to a database. Change connection, sorry. I will connect to one of my SQL Server instances. And as you can see here, we already have syntax highlighting, which is not available through SQL Magic. We have things like IntelliSense, and we also can obviously run the result and then save the output of the result as part of the notebook metadata and share this out with any of our other, maybe on the business segment of our team. And that's kind of, what the workflow looks like or the benefits of having a SQL kernel available through Azure Data Studio. And in terms of kind of the reactions to this experience, it just kind of caught like fire. Like these DBAs and SQL Server people just love this and just finding out more and more ways of how they can incorporate this into their workflows. At the same time, telling us where we can improve. Like, for example, they don't want the they cite some adoption frictions, like having to learn Markdown and having to look up this Markdown all the time. So we added some improvements really recently where you could as you're typing rich text here, we automatically convert it to Markdown for you, so you don't have to worry about looking at the syntax. So as if you're like writing an Outlook email, you can then interact with notebooks. Or if you want to like paste an image, if you wanted to paste an image from online, like this cute hamster here, and you wanted to paste this here, you don't have to remember any of the Markdown syntax for any GIFs, because once I exit the cell and view the Markdown here, we already convert it into Markdown for you. And that's kind of the beauty behind this experience, that we're always trying to learn more from our SQL customers. So now this kind of leads me, now that you kind of got a sense of the importance of having a SQL kernel and the kind of value that it could bring to the notebooks ecosystem, there was two pieces of feedback that not only kind of came from these GitHub issues and social media and user research studies, as well as at JupyterCon, which we presented about a month ago. These were two of the really key takeaways, where one, they don't want this kernel available just in Azure Data Studio. They want this available in VS Code. They want this available in GitHub code spaces. They want this in Azure Notebooks and just all over outside of even the Microsoft ecosystem too. How can we get this SQL kernel? And then on top of that, they want to take this one step further. I don't want just the ability to run SQL. I want to, for each code cell in there, I want to be able to run SQL, PowerShell, C#, or just any other languages, just so that I could have this one notebook where I could just run all the cells and I could do all the jobs and tasks that I need. So as we kind of thought about, instead of us having to custom build all this all the time, let's go back to our principles. How can we leverage open source? Can we build consistent experiences across Microsoft? And that's where .NET Interactive comes in. .NET Interactive is open source and already has support for C#, F#, and PowerShell. Now imagine if we, as the kind of experts in the T-SQL side, what if we could work with the .NET Interactive team to contribute T-SQL? So now you can use all these languages in the same notebook in any Jupyter Notebook viewer out there. And so this, we had this conversation over the last 4 months, led to several hackathons, made a lot of progress, and we're really excited to kind of share the outcome of all that work. And John's going to take a moment here to talk about .NET Interactive.
Sure, thanks, Alan. So .NET Interactive started out. It started out from the Try.net project, which was effectively a code as a service tool that allows you to write interactive documentation. But the documentation tended to be something you had to write ahead of time. It wasn't as open-ended as a Jupyter Notebook. And people kept saying, can we have Jupyter Notebooks? We want to be able to add packages. We want to be able to define new dependencies on the fly and things like this. So at the same time, .NET, a lot of .NET developers, for similar reasons as what Alan was talking about with SQL, didn't want to have to go and learn Python. They wanted to use the tools they already knew, the languages that they were already familiar with. And as well, they had different workloads other than just data science workloads. So you see a lot of these operationalized things like PowerShell. So what we started out with was that was one of the reasons to go down the direction of doing Jupyter Notebooks, but also to think about it in terms of polyglot. We wanted a kind of common base of experience and a common set of visualizations, magic commands, things like this, which typically will differ from one Jupyter kernel to another when they're specific to one language. We said we wanted to be able to share these things across different languages, so for C# and F#. We also wanted to be able to fill in some gaps in the story for visualization libraries, because there are some great visualization libraries out there, but for the most part, at the end of the day, what you're doing is you're building things in things like Plotly or D3.js, where you want to be able to write JavaScript. So we figured if we build from the ground up as a polyglot kernel, you can write those visualizations directly in JavaScript. The PowerShell team was already working with the Azure Data Studio team to provide crucial infrastructure for being able to do things in the control plane for DevOps workloads, which are a big differentiator for the .NET community. Reasons why people want to use .NET versus Python often has to do with that kinds of system administration and backend systems. So on top of all these, the kind of missing piece of the puzzle, we realized from talking to all of our friends and customers was SQL. So that's where we are here. We said, can we bring SQL into this polyglot mix? So with that in mind, I'd like to show you a demo of where we're at right now. So what you're seeing here is Visual Studio Code Insiders. The Visual Studio Code team has been working on a notebook interface, right, which is only available right now in Insiders. But what I'm showing is the .NET Interactive Notebooks extension for Visual Studio Code Insiders. So you can see that we've got this little language chooser here. Now, an important principle is that we want all these, even when you don't have a language chooser, because Jupyter doesn't have one, right? And we want this thing to be able to work in other contexts, is that I want to be able to change languages even without the language chooser. So we have this, we use magic commands for this. Now, magic commands are often used in Jupyter to trigger different kinds of functionality, and they may correspond to other languages. In .NET Interactive, these are actually different subkernels. So what we can see here, here we go, right, is that I've shell access. I get completions from the shell, and this is going to let us do really important work for all of our DevOps needs. So I can display this here, and now we can do some really important work in PowerShell. Now, we have facilities for sharing data and so on. I'm not going to go into that. This is sort of a different story, but what I want to show here is that using this magic command subkernel concept is that we can now start to think about how we bring in SQL kernels into this world, right, where we don't necessarily have a language chooser. So right now, this is a C# cell. # NuGet in .NET Interactive is a way to load in NuGet packages on the fly. So you can see here that I've installed a NuGet package, and NuGet packages can contain extensions to .NET Interactive. So they use the .NET Interactive APIs to change the behaviors of the workspace itself. So they can add magic commands. And in this case, they can add subcommands to an existing magic command. What the connect magic command does in .NET Interactive, and you could add your own extensions and add your own other connections as well. It allows you to create new kernels. And so what we're going to do here is we're going to be able to create a magic command. Let me grab my connection string. Now, the secrets sharing is one of those places where Azure Data Studio and .NET Interactive will hopefully share some infrastructure. You won't eventually have to paste a connection string in here. Obviously, that's a security issue, but for now, this is what we have. So now I have this AdventureWorks subkernel. Right? The AdventureWorks subkernel is a SQL subkernel, and I can type SQL directly in here, and I get IntelliSense. Right? It's connected to my database, and I can run this. What you're seeing here, another thing that came in from our extension was the Interact Data Explorer. And we're using this, again, in order to have a common, because .NET Interactive is just a backend, right? And it'll work in all these different front ends. One of the things that we want to be able to do is carry our own custom visualizations that are associated with specific kinds of data. And so eventually what we'll want in Azure Data Studio is to be able to use the Azure Data Studio, its own data viewer. But here we have the ability as well to bring in an extension that brings in the Interact Data Explorer. Interact is a project that builds all these great components for Jupyter, and this is one of them. So let's try a little bit more of an interesting query now. I'm going to grab this from my other window here because it's a little bit trickier to type. Okay, so here's a bit more of a fun query. Oh, and I've been having this problem here where it doesn't recognize that, but here's what it looks like when it actually works. So what you can see here, right, and this, again, the IntelliSense all works. The Interact Data Explorer gives you some great ability to look at the shape of the data without having to write code to do the visualization. So if you don't know what you're looking for, you can kind of start to play around with it. And this is one example, so we can see, a breakdown of how many items are in each of our orders. So I'm going to go back to this other window here. Now, another thing about the ability to use magic commands to load subkernels dynamically is we can manage multiple connections in the same notebook this way. So I'm going to do this again. Now, in order to use some of the same metaphors between different languages in terms of SQL connections, some people want to query their database using SQL, obviously, and some people might want to query their database using C#. So you might have noticed before that we have this create DB context here. So what this is going to do is you'll see here it's scaffolding a DB context, and it's dynamically pulling in references to entity framework in order to do this. Okay, so we still have the worldwide importers subkernel. We can send SQL directly to that, just like you saw with AdventureWorks. But we also, in the C# kernel, now we have this variable that was created for us, worldwide importers. Okay, so now I have an entity framework DB context that's ready to go. This right here, now I just evaluated that, so it treats it as effectively as an IEnumerable. It spins off query to the database, and what you're seeing here is the default .NET Interactive HTML output. But you saw the Interact Data Explorer before. We wanted to we're using that right now as the default output for a straight SQL query. But you can also use it, let's grab another more interesting query here. You can also use it for any IEnumerable. So here's, again, this slightly more interesting query. Right, so we've got customers by state. This is the default HTML output. But what I can also do is I've got this extension method that the extension lab brought in. This is the extension method that's going to, and we don't have documentation in place for that yet, but you'll see it soon. And this gives us the Interact Data Explorer. And so now we can come in here and we can start to look for, things that are interesting about our data. Customers by state. Right, and so this is quite a powerful tool for exploring your data. And again, to create workflows that cross multiple languages. You'll be able to share data between SQL, between C#, PowerShell, and put together workflows to explore your data and reproduce that. And that's kind of the current evolution of the data story in .NET Interactive. Back to you, Alan.
Thanks, John. That's really awesome demo here. And what this really kind of highlights, or what you kind of saw here, was that in a single notebook, you're able to have PowerShell, you're able to have C#, if you notice that on the kind of the bottom right of the cell. We had T-SQL as well, all within the same notebook. And that's just such an exciting thing, because not only is, like you saw the demo in VS Code, but this will soon be available in Azure Data Studio and hopefully through Azure Notebooks and just all over the place. So, we're going to continue to work on this. There will be, keep an eye out for some announcements coming down the road. But really, this kind of highlights this partnership of Microsoft teams coming together to really build consistent experiences and not kind of work in these silos where it feels like there's clear org line separations, but kind of trying to come all together, and then also validating with many of our open source community friends over in like Netflix and like Jupyter Books and just all over the place. And we're always trying to share any of our learnings, our research studies with them, so that one day we can all contribute this back to open source. So just a quick thing. I really encourage all of you to just maybe take a moment, take a screenshot of this page and try to just check out the Azure Data Studio project. It's all on GitHub. Also check out the .NET Interactive project, which is also on GitHub. And more specifically, we have some instructions for you if you want to try out some of the things that you've seen today at this ak.ms link. SQL is not fully available, but just keep an eye out because we will have some announcements around that relatively soon. And yeah, without further ado, are there any other questions? Feel free to also follow us on Twitter.
You're muted, Abdul.
Whoops. Thanks, Alan. Thanks, John. That was amazing. The collaboration, the customer development process, both of those are just amazing. I got I got a couple of questions here, and I think one of them kind of summarizes a whole bunch of them. Is .NET Interactive an alternative? Oh, wait, that's another question that I wanted to ask. This is the question that I wanted to ask. What all the databases that the notebook supports right now?
So as of today, when you go and switch to the SQL kernel in Azure Data Studio, we actually support all like SQL Server, so both on-prem and on the cloud. So if you think about Azure SQL or also Synapse is also supported through that SQL kernel. In addition to that, we also support OSS databases too. So both on-prem Postgres and Azure Postgres. And then in the works is MySQL, but I'll give you a hint that also MySQL will be working all the same kernel. And that's kind of the beauty of it. As long as you have the appropriate extension installed for Postgres or whatnot, the SQL kernel is the only kernel you'll need to execute any SQL. At least for the .NET Interactive component, our first on our roadmap is T-SQL, obviously, and supporting SQL Server, both on-prem and cloud. The other ones will just kind of come on a case-by-case basis.
Yeah. We also have a prototype version of SQLite for .NET Interactive, which is also part of the Extension Lab project.
Cool. The next question, is .NET Interactive an alternative to LinkPad with additional features?
I think, so there are some overlaps there for sure. .NET Interactive is really a service backend. So you could imagine that LinkPad could be, it's both a front end and a back end, and it's got a very rich UI that's built specifically for that feature set. Whereas .NET Interactive is intending to be code as a service. You send it code, you get back responses. It's very, very flexible. And so right now we're at the back end for Synapse notebooks for .NET and .NET for Spark. We work inside of Jupyter, we work inside of Interact. You saw it working inside of Visual Studio Code Insiders, and it will eventually be inside of Azure Data Studio as well. So in that sense, there's some overlap there, but there's also a lot of difference in terms of their purpose. We also think that in the future iterations of Try.net, the backend will be .NET Interactive as well.
All right, great. Next question. What's the maximum number of examples you could store in a notebook?
How much RAM do you have? Yeah, I'm not really sure. I think this is going to be a question for the VS Code insiders, and as you start piling up more and more complex notebooks, then they will fix the bugs for us, I hope.
Great.
Yeah, same thing for Azure Data Studio. We're going through some perf testing and things like that, but yeah, it depends kind of on your machine limitations and things like that.
All right.
One of the things that's actually really interesting that the VS Code team has done here is that they've virtualized the viewport. So the reason, and a big, you may have used the Python notebook support in Visual Studio Code, and that was sort of a UI that they had built themselves, but it had some performance problems as you start to pile up more and more cells because the Monaco editor is fairly heavyweight. So they're moving as well to the VS Code native notebook experience, which virtualizes the viewport and gets a lot more performance out of it.
Great. I think we have time for one more question. When will the .NET kernel be included with ADS?
As soon as we can. We're working as fast as we can with John's team, and as long as Diego and Maria, I want to give them shout outs as well because we've been working together over the last 4 months for some time. But yeah, it's like we're going to work as quickly as we can. Like actually, you can download .NET Interactive through Azure Data Studio, but in terms of also having the full support with SQL, that's TBD. But at this time, you can download .NET Interactive. It will work in Azure Data Studio, but it would only be for C#, PowerShell, and F# at this time. The SQL announcement will come shortly.
Welcome to Tech of the Day. Today I'm going to talk about this channel with all of you guys. So I started this channel. What we do in this channel, we talk about robbery, fraud, and lie. So this is what we do: robbery, fraud, and lie. Well, not really, but also we talk about latest technologies. So what are the latest technologies, what will be the top technologies in 2020 or 2021, what is the future of machine learning or artificial intelligence, like that. And we will learn new technologies there. I will help you, or we will get together, get new certifications. Like I have already started Azure certification videos. So first I did AZ 900 Azure fundamentals. Second I did AZ 203 or AZ 204, and I will continue doing that. And I will talk about .NET, .NET Core, C#. I will do hands-on practical knowledge. Actually, I will solve some practical problems, real-life problems. Actually, I will also take your suggestions, what you want to do. I will also do some applications from scratch using .NET Core, C#, Angular, Vue.js, Azure Cloud. So all the new things I will do from scratch. So this channel will help everyone who has some basic knowledge or who is advanced, and we will learn together. So please like, share, and subscribe, and explore my channel if you find something interesting. It's enough of listening. Hope to see you soon. Thanks. Bye. Till then, have a nice